Hello team, welcome back. And today we are going to start a new section in which we will learn about the Docker stack services, right? So first we will see what is the Docker stack. So let's start with. So as the word stack is explaining itself, this is something which could be the stack of the services, right? So in Docker Swarm, the stack is a group of interrelated services that share the dependencies and can be orchestrated and scaled together, right? It means if you're running a service, it means if you are running an application and that application is using 9, 5, or 7 services, and these services are interrelated, then you can create a single stack of these services, right? Because they are interrelated so that they can communicate to each other over the one network or two networks. They share the dependencies as well, right? And the orchestration of these services is quite easy if we are using the stack. And in some time, if you want to scale up some services, then you can do that as well, right? So the best example, we have seen the orchestration or the stack in the last lecture, in the last assignment, where I have deployed 5 services, right? One service was running on 5 replicas, another service was running on 5 replicas, and db result and vote was running on the single node, right? So that was also a stack, right? But the situation is, we have started all the services as a individual. In the stack, we will declare all the services and dependency in a single file, and then we can use that particular file as a blueprint to start these services. A single stack is capable of defining and coordinating the functionality of the entire application. As we have already discussed, if my application have more than one service is required, then a single stack is capable to define the complete definition of that particular service and the coordination functionality between these services. Some complex application may have multiple stacks as well. It is not like that a single application can use a single stack. A single application may use multiple stacks as well. And as I told you, the Docker stack services we need to define and file. And that file share the Docker Compose YAML file format. In the Docker Compose YAML file, we just need to insert it the swarm specific properties for the services. So in shortly, we are going to discuss about this. Shortly, we will again discuss what is the Docker Compose YAML file, what is the structure of the Docker Compose YAML file. Although we have already discussed all these things in the Docker Compose YAML lectures, but again, I'm going to show some things, right, so that we can relate the things. And the file name of the stack should be the docker-stack.yaml. So if you have the Docker stack YAML in your project, then you can start your stack by a single command. So we are going to discuss this. First, we will develop an application from the scratch, and then we will start it with the Docker Compose YAML file, and then we will start it with the Docker Compose stack YAML file. So we are going to build our own images. The image will be called as sample underscore nginx project. This image is basically a composition of 4 files. First file is the requirements file, second file is a Python program, third file is a Docker file, and fourth file is a YAML file. So let's see what is the image. And here I have implemented 4 files. So you can say the first file is app.py, right? This is the Python file, which what is doing, which basically connecting the Redis socket and putting some HTML code over here, right? So we don't need to understand this particular code. Then we have the second file, Docker Compose YAML file. The third file is Docker file itself, and the fourth file is requirement, which is Flask and Redis is required to execute this particular program. So let's first start with the Docker file, right? What my Docker file is doing. So Docker file will basically first download the Python 3.7 Slim, right, from the official Docker Hub repository. Then I am defined the working directory, which is underscore app, right? Then I have copied the current directory to the app directory. Then I have installed the needed package, right? I have installed the needed package. I've installed the Flask and Python. I'm exposing this on port 80, right? And define the environment variable name equals to world, right? And I'm executing the command python app.py. So first, let's create an image for this particular project. So we have discussed these particular things earlier as well, how we can create the image from the Docker file. If you don't remember, then there's the command docker build hyphen hyphen tag equals to your image name dot. Dot means from the current directory, right? So we will go to the terminal, right? And if I execute pwd, then you can see I'm inside the sample underscore nginx project. If I will put ls, then you can see we have 4 files over here: the Docker file, app.py file, Docker compose YAML file. We will discuss it later, and the requirement.txt. Right now, what I need to do, I need to build this particular image. Right, so for this, we can execute Docker build hyphen tag equals to image name. Suppose I'm going to take it friendly hello colon version 1.0.1. Right, hit enter button. Oh, so you know why we are getting the error? Because we didn't define the Docker file location, right? So I will again execute the same command and put a dot over here. Dot means take the Docker file or take the necessary resource from the current directory. And right now I'm inside my sample nginx project, and at the same location I have my Docker file, right? Hit enter button. So you can see it is downloading something, right? And it is working, right? So you can say step 7 is completed and image is successfully generated. See, you are getting the message as well. Successfully tagged friendly hello version v1.0.1. Right? If I will put ls, if I will clear out my console and execute a command docker image ls, then you can see a friendly hello repository is being created. The tag is v1.0.1. This is the image ID and created 35 seconds ago. Now what I need to do, I need to push this image on my hub.docker repository. For this, I will execute a command docker login, hit enter. Sometimes it show you this message, login succeed, without any prompt of username and password, because I just log in my hub.docker a few seconds ago from the same terminal. So it have, maybe it have saved some session, so I'm not getting that particular prompt username and password, right? In your case, you may get the prompt username and password. In the username, you need to provide the username of your hub.docker.com profile, and in the password, you need to provide the password. So if you will go to the hub.docker.com, so you can see after the login, I will land on my dashboard. So this is my username, Anshul DevOps, right? My username is not my email. So if I will go to my profile, then you can see your username is being displayed over here, right? So you need to insert this particular username to log into your hub.docker.com from your terminal. Now I need to push this particular image. How we can push an image, right? If you remember the command, you can insert it directly. Otherwise, to help you, I have mentioned that command as well. And the command is docker tag your image name, then your username, your repository, and then provide a tag, right? So we will go back to the terminal and we will enter docker tag my image name. My image name is friendly hello colon v.1.1. Then my repository name Anshul DevOps. Suppose I want to name it friendly hello only. I don't want to provide any tag, right? Hit enter. And then I will execute a command docker push Anshul DevOps, then friendly hello. Hit enter. So you can say it is preparing your image and pushing your image on the hub.docker.com. So we have to wait until until it will complete, and you can see this is complete and this is the digest. Size is this. If I will go to the hub.docker.com and if I will refresh this, then you can see a new image is basically pushed a few seconds ago, right? If you will open this, then this is the image and tag should be the latest. See, the size is 55 MB. So this is the way how you can create your own image and how you can push your image, right? We have already discussed all these stuff in the Docker tutorial, but I'm just explaining all these things because this is related to the current section. Now let's move further and we will see how we can deploy a stack by the help of YAML file, right? So we are going to start with the Docker Compose YAML. Then we will move to the Docker Stack YAML, right? So first we will discuss the Docker Compose YAML. Although we have already discussed all these things in the Docker Compose tutorial, but few new tags, few new operations are basically inserted in this file, so that I'm going to discuss it, right? So let me open this particular file in my Visual Studio Code. So this is the Docker Compose YAML file. I will open this, right? So in the very first line, I need to define the version, and I'm defining the version 3. Then the new tag is services. Inside the services, I need to define my services, right? So my first service which I'm defining is the web, right? So this is the service. Before every instruction, I have put it the comment over here so that you can relate this, right? So service name defined as web. After this, we need to define the image, what image we need to download and from where we need to download it, right? So pull the image from the repository, replace the username repo tag with your own name and image details. As in my case, this is Anshul DevOps, hello friendly, sorry, friendly hello latest. In your case, you can define your own username and your own image name and image tag, right? Then I am deploying this particular image, right? The command is, or the instruction is deploy, right? How many replicas I want to deploy? I want to deploy 5 replicas of this particular service. So run 5 instances of this particular image as a service. This is something new, the resources. In the Docker Compose or in the Docker stack as well, we can define the resources, right? How many resource this particular service can use. So over here, you can see I'm defining the resource, I'm limiting the resource, right? So limit each one of use at most 10% single core CPU and 50 megabyte of RAM. So what I'm defining, okay, execute this service, but every task, every container which is running inside this particular service may use most 10% CPU and 50 MB RAM. By this particular way, by defining the resources limits, you can define your own service limitation so that you can check the bottleneck, you can check the performance on the limited load and on the limited resources. So this is very useful feature in the Docker stack. After this, I'm defining the restart policy, right? And inside the restart policy, I'm defining condition on failure. So anytime your container will failed, a new container will be spin. Or in layman terms, we can say anytime any task of your service fail, it will spin up a new container, right? The ports what I'm exposing is 4000 for the external world and 80 for the containers communication. Over here, I'm defining the overlay network as well. And in my case, the default overlay network should be webnet, right? Which I'm defining inside the networks as well. So you can see this is the network which is defined inside the service. See, the service tag is over here, right? This is defined inside the service indentation. See, then we need to define the network separately as well. Which network we want to create. So networks, then webnet. So what this will do, this will spin up the webnet overlay network and start this particular service in 5 replicas, right, on your container. So the same instructions are being mentioned over here, right? So what this will do, this will pull out the image from the repository, run 5 instances of that particular image, limiting each resource to use at most 10% of single core CPU at a time and 50 megabyte of RAM. Immediately restart container if any fails. Map port 4000 to the host and webs port 80. Instruct webs container to share the port 80 by load balancer network called webnet, and define the webnet network with the default setting, which is a load balancer overlay network. Now, what we need to do, we need to start this particular Docker YAML file with the help of a Docker stack, and we can deploy this with this particular command, right? So Docker stack deploy -c Docker compose YAML and define your service name. So we will go to the terminal, clear out the console, and first check how many services are running. So Docker service ls. So you can see nothing is running over here. In your case, if some service is using port 4000, then your service will not start. So please make sure none of the service is using the defined port inside the image, right? And I will execute a command docker stack. Let's get the help. What are the commands available inside the Docker stack? So you can see deploy, ls, ps, rm and services command are defined over here, right? So we need to deploy. So docker stack deploy -c. Then I need to define my Docker compose YAML file name. Then I need to define my service name. In my case, I'm going to define it nginx start. Hit enter. Then you can see we are getting the messages creating network nginx start webnet and creating service nginx start underscore web. Now we need to understand this. We didn't define the network name, we didn't define the service name, then how it is creating nginx start webnet and how it is creating nginx start web? This is because the webnet is the network we have defined inside my Docker Compose YAML, and web is the word which I had defined inside my Docker Compose YAML. See, web is my service name and webnet is my network name, right? And to start the service, first we should have the network. So first it is created the nginx start hyphen webnet. Nginx start, it taken from here, right? This is the stack service prefix I have mentioned over here, right? So if I will execute docker network ls, then you can see nginx start webnet swarm network is basically running over here. Clear out your console. If I will execute docker stack ls, then you can see nginx underscore start service is running in the swarm orchestration, right? So we have created the docker stack service, right? Now if you want to verify, then we have already seen this command docker service ls, right? If you want to stack name, you can execute a command docker stack service and your service name. A single container running in this service is called as task, right? So basically inside the service, every replica which is running inside the container is called a task. So we have started the service. Now let's see how many services are running. So we'll execute a command docker service ls, and you can see a single service nginx start web is running. If you want to know that how many tasks is running in this particular service, then you can execute a command docker service ps, then your service name, which is nginx starter web. So you can see 5 tasks is running on different containers on different machines. So some are running on node 2, some are running on node 1, and some are running on node 3. Now if we will go to the digital ocean and copy any ip whatever we want, right? Paste it here and try to open it on port 4000, because the same port we have mentioned in our docker compose YAML file, right? So service should be accessible on this port. We will go to the browser and hit enter button. Then you can see it is returning the hello world, host name is this, and visit cannot connect to Redis, counter disable, because till now we don't have implemented the Redis in our service. If you will copy some another ip, suppose I'm go copy the ip of this machine, the first node, right? Again paste it here and access it on port 4000, I will get the same output. So team, if you want, you can compose your own build and push your build on your docker hub account, right? If you don't want to do that effort, you can mention my repository name Anshul DevOps friendly hello in your docker compose file at this particular location over here, right, in the image, and you don't need to do anything else, right? So this is the first lecture of the Docker stack. Today, with the help of the compose YAML file, we just started an application which is using some Python code. In the coming lectures, we will extend this and we will see how we can deploy complete stack with the help of a Docker Swarm stack. So thank you team, thanks for your time. Hello team, welcome back. In the last lecture, we have seen how we can create the Docker stack. Today we will see how we can scale up the stack in the Docker Swarm. So let's start with. So we have seen we have already seen something about the Docker stack, and today we are going to discuss how we can scale up the services. When we are talking that we are going to scale up the services, it means we are going to increase the services or we are going to decrease the services. We are going to increase the resources for the services as well, right? So you can scale the number of services, plus you can also scale the number of resource to a particular service, right? And how we can do that? And we can do that by changing the YAML file, right? So in the last lecture, we have executed an YAML file to create the service, right? So first we will change the particular things like the replicas, the resources in that particular YAML file, and to reflect the changes, we need to redeploy the service, right? So what this will do, right? So we will see when we are scaling up the services, it don't have any downtime. When I'm talking about the downtime, it means your service will not be stopped, right? It will scale up your services on the running mode. So let's see. So first, let's verify the status of my Docker Swarm. So I will insert a command docker node ls. So right now you can see we have the 3 nodes in our Docker Swarm, and this is the leader node, right? Now what I will do, You can see I will enter the command pwd to get the current directory. So I'm inside my sample nginx project, right? The same project I have compressed and attached with the last lecture. So if you want to use that, then you can use it, right? And now first I will check, is there any service running? So I will execute a command docker service ls. So no service is running. So what I will do, first I will start my service. So we will enter a command docker stack deploy -c. Then you need to mention the YAML file name and then the service name. Hit enter. So what this will do, this will start the service, right? You can see a new nginx start webnet and start underscore web is being created. If I will execute docker service ls, then you can see this service is running, right? And if we execute the docker stack ls, then you can see the nginx start service is running, right? Now what we will do, we will identify that how many resources are running in this particular service. So we will enter docker service ps, then the service name, which is nginx start web. So you can see the 5 containers are running in this particular service. Some are running on node 1, some are running on node 1 cpu1 machine, and some are running on node 2, right? Now what we will do, we want to scale up the services. For this we will open the docker yaml file in the editor, right? And suppose we want to start the 6 replicas instead of the 5. So over here we are going to scale up the replicas, right? To go into the insert mode in vim, you need to press I, otherwise you would not be able to edit the file. And suppose I'm going to use the 30% of cpu at max and 100 MB of memory at max, right? I will save my file. Now what I will do, I need to again execute the same command docker stack deploy -c, my file name and then the service name. And please make sure you are creating the same name as you have inserted in the last command, right? Hit enter. So you can see it shows you updating the service nginx web, right? If I will again execute the command docker service ps nginx web, now you can see the number of containers are being increased, right? You can see some are being shutting down, right? Some are still running and some are in the ready state. So what is happening over here? When we are updating the service, what is happening over here? So what docker swarm is doing, docker swarm is stopping the container one by one so that your service will not get any downtime, and it is spin up in new containers with the new configuration one by one. So suppose the 5 containers was running in my service, then docker first down the 5th container or any random container, spin up the new container with the new configuration, down the 2nd container and spin up the new container with the new configuration particular, and it will process this particular phenomena until it will update all the containers with the new configuration. So in this particular way we didn't get any downtime, right? My service was accessible all the time, because in the docker swarm we can access the service on any node which is the part of the swarm, right? So it is not dependent that container 1 is going down or container 2 is going down, right? All the nodes should be able to serve the traffic, and load balancer will manage the request as per their own algorithm, right? So without any downtime, without making any impact on the running system, we are upgrading the system from the backend, you can see. And this is something like a magic for us, because till now we have not seen any application on any configuration which can upgrade your service without impacting its uptime, right? So definitely if you are going to upgrade your services, then you have to take some maintenance time, and in that maintenance time, in that maintenance window, you are upgrading your services. Because, and why you are taking the maintenance window, because you need to stop your running system, upload the new configuration and spin up the new system. But with the help of the docker swarm, we don't need any downtime. This is the same reason you have not seen the big technology giants have taking any downtimes. Facebook will never down, Google will never down, Flipkart, Amazon, they will never down, right? They are managing their uptime with different technologies, with different processes, right? If I will clear out my console and again execute the same command docker service ps nginx web, then you can see right now all the containers which was started earlier has been shut down and new containers are being spinned up, right? So you can see this is running 1, running 2, running 3, running 4, running 5, and running 6. Now 6 containers are running, and all the containers which have the last configuration has been already shut down. So this is the benefit of the Docker Swarm. With the help of the Docker Swarm, you can upgrade, you can scale up your services, you can upgrade your application without any downtime. Now let's move further and let's see how we can add the more services in the Docker stack. So till now we was just executing the Nginx replicas, right? We are going to add a new service in the stack. We are going to add a visualizer. So this is an UI application which will display you the containers which are running inside your Docker Swarm and the manager and worker node, right? Visualizer is basically an official app provided by the Docker community, and we can easily find out it on the hub.docker.com. So let's go to the hub.docker.com. So you can see right now I'm inside my hub.docker.com, and over here I will search for visualizer. So you will get an visualizer inside the Docker samples, right? So we have already discussed about the Docker sample. We have configured the voting app with the help of the same Docker samples, right? So here is the Docker sample visualizer. This is an official repository of the Docker community, and it have 10 million plus downloads, right? Now we need to discuss how we can add a new service inside the Docker stack. For this we need to update your YAML file, right? So let me open my YAML file. So you can see this was my old YAML file version 3. Then we have the services, and we was executing only one service, which was web. I have added one more service over here, right? This should be at the same level as the web. You can see this is at the same level. See, web and visualizer at the same level, because YAML file prefer the indentation like the Python, right? So we need to make sure that we are putting equal spaces between the services, and all services are defined at the same level, right? So the name is visualizer, and we are taking this image, Docker samples visualizer and stable release. We are going to publish this particular service on port 8080 for the external world and port 8080 for the container itself, right? And over here we have defined two new parameters, the volumes and the placements. So let's first talk about the volumes. Inside the volume, what we are doing, so basically I'm pointing out a location in my Docker hub with the Docker container socket. See, with this particular way, you can find the same thing which is mentioned inside the Docker file of the visualizer, right? After this, I am executing the deploy command, and this is the placement, right? And inside the placement, I am putting some constraint. And what is the constraint? I am putting the constraint that this service will execute on the manager node, right? Where node.role equals to manager. So with this particular constraint, you can define which service will execute on which node, right? So if I will put any constraint over here, you can put the any constraint over here before the resources and after the resources. So in last lecture we have seen how we can define the resources, and this is new thing what we are seeing today. And this is the new thing what we are getting today, the placements, right? So you can define the position of the service as well, where this particular service should be execute. Then we are using the same network webnet, and after this we are creating the webnet network, right? Now what we need to do, we need to edit our Docker YAML file which is executing on my Docker host. So what we will do, we will copy and paste it, and we will go to the terminal. Over here I will open the Docker YAML file, delete the old content, and paste the new content over here, right? So you can see the visualizer service is being over here, and something is still missing, the version is missing. So I will enter the complete stuff, like now I will save my file, right? Now what we need to do, we need to again execute the same command, right? The command which we will use for the deployment. So docker stack deploy -c, the same YAML file and service name, hit enter. So you can see it is updating the existing service, and it has created the new service, the visualizer. If I will open the Docker service ps and look for Docker Nginx start web, then you can see the containers, some containers are in the ready state, some containers are running, and some are going to shut down. If we will clear out the console and we will identify other service, Docker service ps nginx visualizer, then you can see this service is running on a single container. right? And this container running on my manager. See, Docker node ls, and this is my manager, and this is the same machine where this container is running, right? Now, what is the benefit of the visualizer, right? So if we will go to the digital ocean and we will copy the IP of any running machine, suppose I'm going to copy the icon of, IP of this machine, and I will try to access this on port 4000. So this should access this particular web page. We have seen this particular web page, right? Now if I will try to access the same on port 8080, then we will get an UI like this. See, this is the visualizer, and you can access the visualizer on any node because this is the property of Swarm. You can access your running service on any node which is the part of the Swarm. So you can access the visualizer on another node as well. Then what is this visualizer is defining? This visualizer is defining the number of containers running inside your machine, and how many services are running there. So you can see this is showing that this is the manager machine which have the 2 GB RAM. This is the worker machine which have 1 GB RAM, and this is again the worker machine which have the 1 GB RAM. This is my container. The image which is running over here is the friendly hello latest, right? The tag is latest updated at this particular time, and this is the hash of this particular container and the status as well. You are getting the status as well, right? So these five containers which are displaying in the border of green, this one, this one, this one, this one, and this one, they are the nginx container. They are the nginx web containers. And the another container which we are getting in the purple border, see, this is the another container which is running for the visualizer, right? This container is running for the visualizer, so we are getting the different color code for the different type of containers as well, right? So with the help of the visualizer, you can identify that how many containers are running inside your Docker Swarm. So this is the benefit of the visualizer. So we have seen how we can scale up the services. We have seen if we want to add a new service inside the stack, then how we can add a new service, right? So that's all for the day. In the next lecture, we will learn some more interesting points about the Docker Swarm and Docker Swarm stack. So thank you, team. Thanks for your time. Hello, team. Welcome back. In the last tutorial, we have seen how we can scale up the services and how we can add a new service in the Docker stack. Today, we will see how we can solve the persistent data problem in Docker stack, right? So let's start with. So in this particular lecture, we are going to resolve the persistent data issue with the Docker Swarm. Then first we need to understand why the persistent data is an issue with the Docker Swarm. This is an issue with the Docker Swarm because in the Docker Swarm, your container can execute on any of the node, right? And if you want to make the mount point with the persistent volume, then if you define any directory, then it may possible this time your container is running on node 1, and next time when you will spin up, the container will execute on node 3, right? So in that case, the persistent data volume will create an issue because first time when your container was running, that directory, that particular volume was created on node 1. Next time when you have started the container, it choose the directory container, choose the node randomly, and it created on node 3 or node n, right? And on that particular node, you don't have that particular directory structure, right? So your container will start from the blank database. So that's why the persistent data is an issue with the Docker Swarm. Now we need to understand how we can resolve this persistent data issue with the Docker Swarm. So for this, first user can use the volumes to define the mount point. We will mount the container directory with my local host directory, and I can restrict the service to execute on a specific node. So that when we are restricting the service to access a specific node, it means always that particular task container will start on a specific node, so that you will get the mount point data every time when you will restart your containers, right? So in this tutorial, we are going to add one more service, Redis, and we will see how Redis can perform the persistent data and how Redis can read the persistent data. So let's start with. So to extend the Redis in our service, I'm going to add one more service in my Docker YAML file, which is Redis. right? So I have added one more service Redis, which is using the image Redis. This is exposed on port 6379 to the external world and 6379 to the container. And this is the volume directory. This is the location which is defined on your host machine, and this is the location inside the container. So inside the container, the data location will access this particular data directory, home docker data, right? I'm deploying the Redis. The placement is constraint, and I have defined that this particular service must execute on manager only. Now over here I'm defining a command Redis server hyphen hyphen append only yes. This will, what this will do, this will basically maintain the AOF files, and always whenever your container will restart or create a new container, this will append the data inside the existing data instead of refreshing the data, right? And I'm defining this will use the same network webnet, right? Now what I need to do, I need to copy this, go to my terminal, and over here first I will check if any service is running. So docker service nginx ls, and yes, the services are running, right? Now what I will do, I will open the docker yaml file, remove the existing content, and add the new content. So over here you can see we have the Redis service, we have the visualizer, and we have the web service as well. I'm going to maintain the version, save this particular file, right? And again I need to execute the same command, right? Docker swarm deploy, docker stack deploy hyphen c, docker compose dot yaml, and my service name. Hit enter button. So this will update your existing service, and you can see it has created a new service nginx start redis. If you will execute a command docker service ls, then you can see it is trying to create the redis, but still it is not able to create it. Now if you will execute a command docker service ls, then you can see I have executed the same command 3 times, but every time I'm getting 0 container running on my host machine. Let me explain the reason for this. If we will vi the docker compose yaml file, then we have defined the mount point of redis is like home docker data, right? But somehow this directory is not present on our machine, on our host machine, so that the service is not able to start the redis on your host machine. In some cases you don't have the access to this particular directory because you are using some other user instead of the root, then you may not have the permission at this particular location. In that case what we need to do, we can update this location by this. Let me explain. I will remove everything, just go to insert mode and remove everything from here, and just keep dot data data colon data. What does it means? It means access the data from the current directory where I'm executing the command, right? Just save this program. Now if I will execute a command pwd, then you can see right now I'm inside the sample nginx. If I will put ls, then over here I don't have any data directory. So first I will create a data directory like mkdir data, right? Or you can mention like this, mkdir data, put ls, then you can see a data directory is being created over here. Now if we will again execute our service update command docker stack deploy hyphen c docker compose yaml nginx start, then you can see it is updating the visualizer, it has created the redis, and it is updating the service web. Now if I will execute a command docker service ps, sorry, docker service ls, then you can see one replica of redis is running, right? So the issue was with the mount location, so we have to take care that stuff as well, right? So when we are starting with the stack, or when we are dealing with the mount locations, then we need to take care actually it is creating that mounted location or not, or is that mounted location which we are trying to access is available on our host machine or not, right? So you can see the container of redis is running, which is running. If I will debug this like docker service ps nginx redis, then it must execute on your host machine. See, it is executing on my manager machine, right? Now If you will go to the browser, copy any IP of DigitalOcean. Suppose I'm copying the IP of this machine, which is my second machine. Go to your browser, type here, and try to access it on port 4000. So you will get the visits as well. Right here, earlier we was getting some kind of error over here, right? We was getting that Redis container is not present or something like that, right? Right now I'm getting some visits. If I will refresh this visit will update every time. See, this visit is updating every time, right? If we will go to the port 8080 to open the visualizer, then you can see one more container is being added. Right now all nginx 5 containers are in dark green border, the visualizer in purple border, and the Redis in light green border, right? And these two containers are running on my manager machine. Right now let's go to terminal again and stop your service. Docker service rm nginx Redis, right? If you will see, that container which was running on my machine 2 should have stopped. If I will go to the visualizer again and refresh this, then you can see the Redis container is gone, right? So we have stopped the Redis container. It means all the visits which I have done on my web application should be lost when I will restart it, because I have removed the container, but we have mounted the location. So ideally these visits should be remain, right? Over here, if you will go to the data location, let me try to open this. If I have something over here, so over here you have a file append only AOF. I don't know I would be able to access it or not, but let's try and see. It have some data, right? One counter, then we have the another counter, right? Have the three counters. So this file have some data right now. We are not trying to understand this. What is this, right? So leave it as it is and go back to our location nginx, right? Clear out the console and let's start the service again. So this is the command we can execute to start the service. But before starting the service, let's go to the web application as well. So instead of the visualizer, let's go to the web application. In our previous visits, the visit number was 4. Let me refresh it. So see, you are getting the error message cannot connect to the Redis counter disabled, right? If I will again start the Redis, so this time Redis should start in a new container because I have removed the service, right? But as it is reading the data from the mounted location, so it should retain the visits. See, it is retaining the visits. So this is the solution of the persistent data volume with the swarm, right? If you have the persistent data volume issue with the swarm, you can define the nodes as well. So team, that's all for the day. In the coming lecture, we will learn few interesting things about the Docker Swarm and Docker Swarm stacks. So thank you team, thanks for your time. Hello team, welcome back. In the last lecture, we have solved the persistent data issue with the Docker Swarm. Today we will see how we can deploy a complete stack in Docker Swarm. So we are going to deploy the distributed voting app, which we have already deployed in some of our assignment, right? But over there we have deployed the voting app in multiple commands. Today we will see how we can deploy the complete distributing voting app with a single command, right? So let's start with. So to distribute any stack, the basic thing you need is the YAML file, right? It could be the compose YAML file or it could be the stack YAML file, right? In the YAML file, we have already seen in the YAML file we have different kind of services and the application which is related to that particular service, right? So to deploy a complete stack in the Docker Swarm, you just need to get or prepare the YAML file and you need to deploy your stack with the help of that particular YAML file, right? So over here I have mentioned the GitHub code location of the distributed voting app, right? I will attach this particular PDF as a resource of this particular lecture so that you can also get it, right? Now once we will deploy the stack, if we need to find out that how many stacks are running, then you can execute a command docker swarm ls, right? If you want to know that how many tasks are running in a single stack, then you can execute a command docker stack ps, then you can define the stack name. If you want to know that how many services and how many replicas of a particular service is running, then you can execute a command docker services, then your stack name. So let's go to the terminal and let's see all these things in a practical way. So first I'm opening the GitHub location of that particular project on which we was working, right? This is the distributed voting app project, right, which we have already used in the assignment, right? So this is the GitHub location, and if you will see, then you will get an Docker stack YAML file. See, Docker stack YAML is here. Let's open this particular file in new tab, and you can see this is the YAML file. So what we will do, we will copy this YAML file. So let's click on the row and let's copy all the text which is present over here, right? Now let's go to the Visual Studio tool and create another file, docker stack.yaml, right? And let's paste it over here. So first, before starting this, let's try to understand this. So this has the version 3, right? Over here we are defining the different services. So first service I'm defining is the Redis, right? The Redis is using the Redis Alpine image, right? And which network this Redis is going to use? This will use the front end network. Then we have the deploy, right? So we are going to create the single replica of this particular Redis. Now we have the update configuration. Over here I'm defining the parallelism. Now next tag is parallelism and the count is 2. You can see this is defined inside the update configuration, right? So it means if you want to update this particular YAML and redeploy this service, then this service can execute 2 containers in a parallel, right? It means this particular service can update 2 containers in a parallel, and the delay between the 2 and 2 set. Suppose we want to update the 4 containers, right? So it will update the 2 containers, then take 10-second delay, right? And next update the, and after the 10-second it will pick up the update of next 2 containers, right? Then we have the restart policy and condition is on failure, right? So it means if any container will fail in this particular task, then a new container will be spinned up, right? The next service we have the DB. We are going to use the Postgres 9.4. These are the volumes which we are going to use, and network it will use the backend. We have the deploy placement constraint, right? That DB will execute on the manager node only, right? Why? Because we are attaching the volumes, right? So we don't want to distribute this particular volume across the swarm nodes which are running inside the swarm. Then we have the next vote app, right? And this vote app is taking the image from the Docker samples example voting app before, right? We have already seen this. The voting app is published on port 5000 to the external world and 80 to the container. It will use the front end network, depends on the Redis. So before starting this voting app, Redis container should be in the running mode. Then we have the deploy policy. We are going to create 2 replicas of this particular service. Update configuration, again the parallelism is 2, and restart policy is on failure. After this we have the another service result, right? This will also take the image from the Docker samples, right? The port on which the result is published is 5001, and container will communicate on port 80. This will use the backend network and depends on the DB. So until the DB will be started, this service will not start, right? This has the deploy policy, and replica is 1, update configuration 2, delay 10-second, restart on condition. Then next we have the worker, right? In the worker we have the Docker compose example voting app worker. Network it will use the front end and back end network both. Then we have the mode replicated, the replicas are 1, right? Then we have the label, that app voting, so we can also define the label of a particular service, right? Then we have the restart policy 10 on failures, delay 10-second, max attempt 3, and window is 120-second, right? So it will take max 3 attempts if this particular worker will fail to deploy, right? And the maximum window to and a maximum window of the retry is 120-second. The placement is role node manager. So this will also execute on the manager node. Then we have the visualizer, right? Inside the visualizer we again using the Docker sample visualizer stable. It is published on port 8080. Container will also continue on port 8080. Stop grace period. Grace period means if something went wrong, then this should be stopped within this particular defined time, right? These are the volumes, right? The deploy placement constraint. So we have seen all these things, right? So right now we don't have any code on our machine. We don't have anything on our machine. To deploy a complete stack of the services, what we need, we just need this particular YAML file, right? So I will copy this file, go to my terminal, Now you can see I'm inside my root directory. Suppose over here we are going to create a directory like sample service stack, right? Put ls, you can see sample service stack is created. We will go to this sample service stack, right? Over here we will create the docker compose yaml file, vi docker hyphen stack dot yaml. Hit enter and paste the complete file in this particular file, right? The complete data. You can see the version is not pasted, right? So we have defined the version 3. Escape, press colon wq to save your file, put ls, then you can see the file is here. Now to start up the service, we will execute a command docker stack deploy hyphen c my docker file name, then stack name. So suppose I'm going to take the stack name like voting stack, right? Hit enter button. So you will see it is creating the services, right? So over here we are getting the message like creating the services voting stack redis, creating the services voting stack db vote result worker, like this. But actually a scheduler is working in the background, right? So we are getting the message quickly, but actually if we are creating a number of replicas, then this may take some time, right? Because the same scheduler is working, which is checking the resources configuration and starting the services as well. This may take few seconds to few minutes. It all depends on the number of replicas what you are defining, right? Now if you want to check that how many stack are running, then you can execute a command docker stack ls. So you can see only one stack is running, and in this particular stack 6 services are running as well. So if you want to check that how many tasks are running, then you can execute a command docker stack ps, then your stack name. So it will show you all the tasks which are running. Here is the current state and the id of the task, right? Please remember this is not your container id, right? Because container name is much bigger than this name, right? If you will put docker container ls on my master node, then we will see that how many containers are running, and you can see the containers name are much bigger. See, because of the unique name, this is taking the complete image name, then tag, then it is taking the task name, then defining a random generated id over here, right? So container name is not as task name. Task is running inside the container, but task name and container name is not a similar kind of thing. Let's clear out the console. Now if you want to see that how many services are running and what is the replication status of these services, so you can execute a command docker stack services, then your stack name. Hit enter. So you can see 2 services of the both are running. One service of worker is running, one service of db is running, one service of visualizer is running, one service of redis, and one service of result is running over here. Team, sometimes it may happen that worker application will not execute, and if you will open the log of the worker services, then you may get an error like this: system aggregation exception, one more record occurred, no such device or address, system dot internal socket exception, right? Every time this error will not reproduce every time, but sometimes this worker app will not execute, and you may get this particular error when you will execute a command docker service log, docker service logs, and define your service name, right? Now this is the, now this is not an error with your code, this is not an error with the docker, right? This error is basically related to the .NET framework which is running inside the worker, right? So sometimes you may get that particular error, sometimes sometimes you may lucky that you will not get this error. Right now I'm not getting this error, but it may happen when I will stop this and again execute this, I may get this error. So so there's only one solution for this particular error. You need to modify your docker yaml file. We need to go to the worker, and instead of the single replica you can define n number of replicas. Suppose define 10 number of replicas or 20 number of replicas, right? So that it may possible that single server or single task may get the connection with your database. This error is just related that you will not get the connection with the database, and this is the Microsoft.NET framework error. This is not the code error, right? Sometimes your code will not able to find out the dns and you may face this particular error. Let me show you again, right? The error is one or more error occurs, no such device or address, right? And you will get the socket exception. This error specifically will come in this particular service, worker service, because worker service is using the .NET framework. So we have seen how we can deploy a complete stack in a single command. We don't need any code, we don't need anything. We just need that particular YAML file. We need to execute this particular YAML file, and all kind of work will automatically done, right? Now let's go to the digital ocean. Copy any IP whatever you want. Suppose I'm going to copy this IP, right? And paste it, and our services was running on port 5000, right? This was the voting, and result was running on 5001, right? And visualizer was running on 8080, right? These port was defined inside my YAML file. So see, if I will vote for dogs, then the result over here will change. See, the 100% vote are going for the dog, right? And inside the visualizer we are getting the different containers which is running inside my stack. So my manager is executing three containers: the visualizer itself, the DB, and the worker, right? Redis is basically executing in the node worker 1, and then vote container is, and single vote container is running in worker 1, second is running in worker 2, and result is running in worker 2, right? So we have defined that visualizer and DB will execute on the manager node, right? Let's see. We have defined that this is the worker node, this will define on manager, and this is the DB which is also defined on the manager, right? So same thing we are getting over here. So team, this is the way how can you deploy n number of service with a single command with a single YAML file. You just need to create your configuration YAML file, stack YAML file, and you need to just execute it, and rest of the work is the responsibility of the Docker Swarm and Docker itself, right? So thank you team, thanks for your time. Hello team, welcome back. In the last section we have discussed about the stacks. We have seen how we can create the multiple services with a single file. Today we have created a new section, and this is the first lecture of this section. So let's start with. So in this particular lecture, we are going to discuss what are the Docker secrets and how Docker Swarm secrets are being managed with the Docker Swarm. So first, let's discuss about the secrets. What are the secrets in the Docker, right? So secret could be anything. It could be a piece of information. It could be a piece of data, such as it could be the password. It could be your private key. It could be the SSL certificates. It could be another piece of data which is important from the application point of view. It may be your code as well, right? And the data which should not be transferred over the network unencrypted, right? And particular data which should not be unencrypted in the Docker file or in the source code of your application. So that all the things are covered in the secret data, right? Secret data can be your credential stores, where you are putting your different services credentials, where you're putting where you are putting the internal users of your services. Suppose you are putting the password and username of your database services, you are putting the password and username of your servers, right? So secret data is something which is important for the organization, which could not be exposed to the external world. So the question is how we can manage this sensitive data. Till now we have not seen that if we our application are using some password, our application is using some username, then they could be encrypted, or they could be encrypted, or they could be hide, right? So we have seen when we was creating the MySQL, we was defining the password in the run command, right? And that was exposed to the user, right? That was exposed to the all developers who are using that particular service. And also that same password is being transferred over the network. If your service is running on some cloud machine and you are executing these commands from your local machine, that particular password is transmitting over the network, which could be the security breach, and which could impact the organization security as well, right? So in the Docker Swarm, user can manage this kind of sensitive data with the help of Docker secrets. So in the Docker Swarm, Docker secrets are used to manage the sensitive data, right? Docker Swarm manage these secrets centrally and store them on their own disk in the encrypted form, right? And suppose some container want particular secret from the Docker Swarm, then that particular secret transmitted to that particular container over the network, right? And that transmission is also in the encrypted form. right? And only the granted container can access the granted secrets. It doesn't mean that if we have the 100 containers running in the Docker Swarm and we have the 5 secrets, then all 100 containers can access these 5 secrets. No, only the granted container can access the granted secrets. And this is the another important point, that Docker secrets is only available in the Docker Swarm mode. If you are not running your Docker engine in the Docker Swarm mode, then Docker secret is not available for you, right? They will not work with the standalone containers, right? As we have discussed, that only granted containers as well as only granted services can access the secrets over the network, and that secret when transmitting over the network, that should be in the encrypted form. Now let's discuss the another point of the secrets. So when we are basically using the secrets in the Docker Swarm, so we are creating an abstraction layer between the containers and the credential stores, right? And that will help us in many fronts. This can be understood with a simple example. If we have a three environment, we have the production environment, we have the development environment, and we have the testing environment, right? So we can define the different secrets for every environment. It doesn't necessary that all the containers which are running inside the development environment, in the testing environment, and in the production environment, they all can access the same credential store or same secrets. No, we can define the different secrets for the different environment. So we are creating an abstraction between the services, between the containers, and between the credentials, the secrets, right? Now let's discuss how Docker Swarm manage the secrets. So basically, we can use the commands to create the secrets, and when we are adding the secret on the Docker Swarm cluster, so this secret sent to the manager using the TLS connection. And what is the TLS connection? TLS is a cryptographic protocol that provides the communication security over the network by providing the communication encryption, privacy, and data integrity. So it means when we are creating a secret, that secret is basically sent to the Docker manager with the help of the TLS. And TLS is basically a very secure network protocol, right? Which encrypt your secret and transmit over the network. So it may also possible that we have the multiple managers available in our Docker Swarm, right? In that case, there is another mechanism which will be used, which is called Raft. So when we have the multiple managers, Raft manage the secrets on all the managers. So let's understand this with a simple example. So let's understand all the secret management with this with the help of this particular diagram. So over here we have the users which are available on the web UI, right? And they are sending some secrets. So in our application, in our Docker Swarm, we have the three managers, right? So when a secret will be transmitted to the manager, right? So Raft come into the picture, right? And Raft have their own internal distributed store. This particular secret will be stored inside the internal distributed store, and this internal distributed store have the 256 byte encryption, right? And all the managers which are available inside the Docker Swarm can access the secret from this particular internal distributed store, right? And the worker nodes, on the worker nodes we are running the containers, and suppose some container wants the secret, so container will access the secret with the help of a worker, and worker will send the request to the manager, so that manager will provide the secret to that particular container only. So this is the simple example. With this we can understand how the secrets are traveling inside the Docker Swarm. Now let's discuss how the containers are managing the secrets, right? So container works on a mounted decrypted secret. So why the container are using the decrypted secrets? Because when container need the secret, it need the actual string. Suppose you are set a password, right, and you are sending the password over the network, that is in the encrypted form, right? but but the application which is running on the container, that need that particular password, right? So container use the decrypted secrets which store at a location of run secrets, right, which is inside the containers. So you can see if you are using the secrets for a container, then so where these containers are basically storing these secrets. So secrets are quite flexible as well. User can anytime update the secret of a particular service and revoke the access of a given secret from a given service, right? So this is the another security point from the container point of view, that when container is stopped running, right, the decrypted secret which is stored inside the container directory, that flushed from the node memory, right? So when a container is basically stopping, it will flush out all the data which is mounted regarding the secret. So this is the introduction about the secret, like what is secret and how Docker Swarm is using the secret. In the coming lecture, we will generate the secret and we will see how service can use it, right? So thank you, team. Thanks for your time. Hello, team. Welcome back. In the last lecture, we have seen that what are the secrets and how Docker Swarm is processing the secret. Today we will see how today we will see how the secrets can be used in the services. So let's start with. So first we will try to understand the secret commands, that what are the options we have with the secret commands. For this we will go to the terminal and let's see docker info. Then over here you can see the swarm is in active mode, and I would like to show you one more thing, that over here you can see the raft, right? We was discussing about the raft in the last lecture, right? So raft is used to manage the secrets on the hard disk, right? So docker swarm is running. I will clear out the console, and to get the help command with the secrets I will execute a command docker secret hyphen hyphen help, hit enter. So we have these commands available with the secret. One, we have the create command, which will be used to create the secret, right? Then we have the inspect command, display detailed information about the secret. Then we have the ls to list out the secrets, and then we have the rm command to remove the secrets, right? So these are the commands which we can use with the secrets. So first we will see how we can create the secrets. So basically there are two ways to create the secret. The first way is with the help of a file, right? So suppose you have defined your secret within a file and you want to create that encrypted value, create a secret, the value which is present inside the file, then you can execute a command docker secret create, then define your secret name and define your file location. And the second way is by the command line input, by the CLI, right? So you can insert a command echo, then define the secret pipe docker secret create your secret name and define the hyphen. It means take the input from the command line, right? So let's see how we can create the secrets. So let's go to the terminal. So suppose you want to create the secret for the database, right? So first thing what I will do, I will create a separate directory and I will call it secrets example. I will go to this directory, and all the work what I'm going to do in this particular section, I will do that particular work in this particular directory, right? So first let's see how we can create the secret with the help of a file. So I will create a file like dbpassword.txt, right? And over here I will mention my db password, and suppose I'm going to provide the password like test at the rate 123, right? So suppose I'm going to provide this particular password to my db. I will save this particular file. If you want to see, then you can use the cat command dbpassword.txt. Then you can see this is the value which is mentioned in this particular file. Now suppose we want to create the secret of this particular password. So we will execute a command docker secret create, then we will define the secret name. So I'm going to define like db underscore password. This will be my secret name. And what is the value of the secret? This file contains the value of the secret. Hit enter button. So see, you are getting some reference value. It means the secret of the value which is present inside this file dbpass has been created, and the secret name is dbpassword. Now let's see the another command, how we can create the secret with the help of a command line argument. So suppose I will type a command echo, and suppose the second secret I would like to create for my user, right? So I'm creating is db underscore user. Suppose this is the value of my username. Then I will define the pipe, then say docker secret create. I will define the secret name like db underscore username and define a hyphen. It means take the input from the command line. Hit enter button, and you can see the secret is being created. If you want to list out the secrets which are present inside your system, you can execute a command docker secret ls. See, the two secrets which are present inside my machine, the first is db password and second is db username. They are created a minute ago and 14 seconds ago, right? So let's clear out the console. Now let's see how we can inspect the secret. So we can use the command docker secret inspect to inspect the secret. So suppose I want to inspect the db password secret, so I will execute a command docker secret inspect and define the secret name. Hit enter. So you can see you can only inspect the index, the ID of the secret and the creation date and updation date, right? You are not getting the value which is present inside the secret. So this is the beauty. If you are able to expose the value with the help of inspect, then definitely it's not a secret. So with the help of the inspect, we are not able to get the value of the secret. We just get the information about the secret. One more thing I would like to explain, that we have seen two ways to create the secret. The first way was with the help of a file and second way was with the help of a command line. And I would like to mention that both of the ways are not the correct way to create the secret, right? Let's discuss the drawback with the first approach. So suppose you are creating the secret with the help of a file, then that particular file is basically stored on your host machine, right? And anybody who know the credential of your host machine can access this particular file and view the passwords, right? View all your secrets. So this is not a preferred way to create the secret in the production. In the second command, we are creating the secret with the help of a CLI, right? So anyone who knows the credential of that particular system can enter a command history. See, if I will enter a command history, hit enter, so it will define me all the commands which I have executed on this particular machine. So you can see by this particular way I can expose the value of my secret, right? Because in the history command I am getting the value, right? So both of the ways we have tried to create the secret, they are not the ideal way, right? So we will see how we can create the secret ideally, right? Let's clear out the console. Now let's see how we can start the Postgres with the help of these particular secrets, right? So command is like this. So we want to create the Postgres service with the help of the secrets. So the command will be like this. The Docker service create hyphen hyphen name, define your service name, then hyphen hyphen secret, define any of the secrets. Suppose I'm going to define the username secret, hyphen hyphen secret, define the password secret. Then we need to provide the environment variables as well, right? So if we are defining the password on a command line, then the environment variable is postgres underscore password. But right here, we are not defining the value directly. We are getting the value from the secret. So we need to store this value at some location on the container and then mount that container location to the environment variable. So we are doing the same thing. We are defining the environment variable like postgres password file equals to run secrets and defining the secret name. Suppose first I'm defining the password secret, so I will define the secret name of the password, and in the similar way I will define the secret for the user, right? Then you need to define the image and the tag. So let's see how we can create the service. So we are on terminal. Over here we will execute a command docker service create, then hyphen hyphen name. I will define the name postgres, then hyphen hyphen secret, and I will define my first secret name, right, which is db underscore username, right? I will define my second secret, which is db underscore password. Then I will define an environment variable hyphen e equals to postgres underscore password underscore file, and over here I will define the file location, which is run secrets, then the secret name of my password, which is db underscore pass. In the similar way I will define the username. So postgres underscore user underscore file, and define the similar location like run secrets. We have discussed already in the previous lecture that container stores the secret at this particular location, right? Then define the db underscore username. Then we need to define the image. So I'm going to define the image postgres. Hit enter button. So you can see this will create your service shortly, right? So we have to wait until the service will be created. So it is taking some time. Now you can see the service is being created. If you will execute a command docker service ls, then you can see the Postgres service is executing. If to identify the task, we will execute a command docker service ps, then service name. Now we can see the task is running. Now suppose we want to SSH this particular container. So we can see the task is running. Now suppose we want to SSH my container. So we will execute a command docker exec -it, then define my container name, which is Postgres 1, Postgres 1, then some random ID, right? And bash, right? So we are inside my container. If we will execute a command cd run secrets, right, put ls, then we can see we have the both secrets over here. If we will execute the cat db underscore password, then we can see this is the password we have passed with the help of the secrets. In the similar way we can see the username as well, right? See the db underscore user. So we have seen how we can create the secret, how we can create the service with the help of the secrets, and how we can view the secrets inside the container only, right? So this is the way how the secrets are working. In the coming lecture we will see how we can upgrade the secret of a service. So that's all for the day. Thank you team, thanks for your time. Hello team, welcome back. In the last section, we have seen how we can use the secrets in services. Today we will see how we can use the secrets in Docker stack. So we are going to deploy a new stack, and in that stack we will use the secrets. So let's start with. So first we will see how we can deploy the stack using the file based secrets. And then we will see how we can deploy the stacks using the CLI based secrets, right? So we will deploy an Postgres stack using the file-based secrets. For this, we need to create the Docker Compose YAML file, and we need to create the files for the Docker secret. So let's see how we can deploy the Docker stack using the file-based secrets. So right now I have created a Docker Compose YAML file, right? You can see the file is here, and here I have defined few things, right? So now let's understand what these things and what is the meaning of each and every line which I mentioned over here, right? Later on we will see how we can deploy the complete stack with the help of the file based secrets. So we are using the Docker Compose YAML version. So we need to choose 3 or above 3 versions. So right now we are choosing 3.1, right? Then we need to define the services. What services we need to start in this particular stack. So I just defined a single service Postgres DB, right? This would be my service name, and this service is using the image. Which image it is using? It is using Postgres latest image, right? Then we have the commands to use the secrets, and command is secrets. And inside this secrets we need to define the secret name. So I'm using two secrets, db username and db password. You can define anything over here, right? So these all are the custom values. So if you want, you can choose db underscore postgres username, db underscore postgres password, or you can choose any name with which you are comfortable, right? So I just choose db underscore username and db underscore password. And we have seen in the last tutorial when we executed the Postgres with the help of the file-based secrets using the command line, then we was using the environment variable. So we need to define the environment variable as well, right? So first environment variable is Postgres password file, right? And this will extract the password from my container, and inside the container secrets always extracted at this particular location. Run secrets, and this is my variable name, right? In which I will keep my password. So this should be the same as secret name. Now I have the another environment variable Postgres user underscore file, and over here I need to define the secret value of my username, right? So till here we have completed the service part, right? Now at the same level of services, we can see this is the same level. We need to define the secrets, and we are using two secrets over here. First is db username. So I've defined the db username, and this is the file based secrets. So it will read the secret from this particular file, and file name would be postgres underscore user dot txt, right? And the second secret what I need to define is the db password, right? So I'm defining db password over here. This is again a file based secret, and file name would be postgres password dot txt. And you can see I am basically reading the file from my current directory, from my working directory. So what I need to do, first I need to create these two files in my current working directory. So I will copy this particular text file name, go to my terminal and execute a command docker secret ls. So let's see how many secrets do we have. So we already have the two secrets, db underscore password and db underscore username, right? So if you want, first you can remove them, right? So I'm going to remove them. So I have removed the both of the secrets. Now if I will again execute a command docker secret ls, then we can see no secrets is being present in my system, right? Now if I will execute pwd, then I'm inside the root and secret example directory, right? If I will put ls, then I have only one file over here, which is dbpass.txt. So what we need to do, first we need to create the text file which we have mentioned inside my YAML. So I will copy the file name, right, and create a text file with the same name, right? And inside this file I need to define my username. So I'm defining username like tkdbowner, right? Just save this particular file, put ls, then you can see the file is being created. I will go to the YAML file and copy the second file name, right, which is postgres password.txt. Again create this file, and inside this file I need to define the password. So I'm again defining tkdb password, right? Now put ls, then you can see both of the files are present over here. So what is my username? My username is tkdbowner and my password is tkdb password, right? Now what we need to do, we need to create the docker compose YAML file as well. So I will create the docker compose dot YAML file over here. And what I need to do, I need to copy the compose YAML file which I have created inside my Visual Studio and paste it over here, right? So I pasted the file. I just save this particular file, put ls. Now what I need to do, I need to deploy the stack with this particular compose YAML file, right? And to deploy the stack, we need to execute a command docker stack deploy -c. Then I need to define my file name, which is docker compose YAML, and then I need to define my stack name. So postgresdb is my stack name, right? So I'm executing a command docker stack deploy -c docker compose YAML file. This is the compose file which I need to deploy, and my stack name is postgresdb. Hit enter button. So you can see first it has created the network, right? Then it has created the secret, then it has created the another secret, then it has created the service. If you will execute a command docker stack ls, then you can see postgres stack is running and the mode is swarm. If we will execute a command docker service ls, then we can see the postgresdb service is running. This first name postgresdb is basically coming from here, right? And the second name postgresdb, this the second part is coming from my YAML file. This is my service name. See, now suppose I want to see that on which node my service is running. So we can execute a command docker stack ps, then I need to define my stack name, which is postgresdb. So you can see this is my service name, this is the image, and it is basically executing on node 1. See, the status is running and it has been created 2 minutes ago. In the same way, if I will execute a command docker service ps postgresdb, I mean to say my service name, then it will show you your service information as well, right? So this is the way how we can execute the docker stack with the help of the docker secret files, right?
Now let's see how we can add another service in the Docker stack, and we will see how we can use the CLI based Docker secret for the stack, right? So we are going to create the CentOS image in which we will use the user created secret. So we will again go to my YAML file, and over here we will add another service. So I'm adding another service. The service name will be CentOS. Image type is CentOS. I'm going to deploy only one replica. The entry point will be bin sh. The std open will be true, and it will use the tty. And I'm using the secrets, and secret name is my secret, right? So you can define the secret by this way as well. You can define the source, or you can directly define the secret, right? So this time we are using the secret, and secret name is my secret. And what we need to do, we need to read this particular secret from the CLI, right? So I will just copy this and add one more line over here. Now when we need to read the secret from the CLI base, we need to choose the external and keep the value true. It means we are getting the secrets from the external command, right? So now this is my new YAML file. I will copy the content, go to my terminal, right? And I will open the Docker Compose YAML file. Remove the remove the existing content and paste the new content over here. So you can see the version is missing in version, right? So I will enter the complete text, which is version, right? So we are using version 3.0. We have the services PostgreSDB and CentOS, right? PostgreSDB is using DB username and DB password, which is file base, right? And CentOS is using the my secret, which is external, right? So when you are using the CLI based secret, you need to use the external equals to true. I will save my file, right? So we know very well that already a service is running on my machine. So I will open Docker stack ls. Now first we need to remove this service. So Docker stack rm, then define your stack name, right? Again execute the Docker stack ls. Then you can see no stack is running. If we will execute Docker service ls, then no service is running because the Postgres service was running inside my stack, which was Docker stack. Now till now, if we will execute a command Docker secrets ls, this should be secret instead of service, then you can see no secret is present in my Docker swarm, right? If we will deploy the stack again, right? Till now we have not created the CLI based secret, and we are going to deploy this service. So Docker stack deploy -c Docker Compose YAML file, and I will name it Postgres underscore OS stack. This is my stack name. Hit enter. So you can see it is saying creating network Postgres DB password, DB username, and again you are getting the error sent to a service secret not found. And this is the secret name my secret. If I will execute a command Docker stack ls, then you can say the stack is not being created. So what I need to do, first I need to create this particular secret. Now to create the secret manually, we need to execute a command echo, put double quotes, define your secret value. Suppose I'm going to define secret value like my test value, right? Put pipe, then execute Docker secret, create, define your secret name. In my case, this is my secret, then put hyphen, hit enter. Then you can see a secret is being created. If you will execute a command Docker secret create, Docker secret ls, then you can see the secret are being present over here, right? Now let's deploy the stack again. So Docker stack deploy -c compose file name, which is docker compose YAML, then define your stack name. I'm going to define postgres underscore os underscore stc. Hit enter. So you can see, first it has created the network, then it has created the secret, then another secret which is password, then it has created the service postgresdb, then it has created the CentOS as well. If we will execute a command docker stack ls, then we can see this stack is running. If we will execute a command docker stack ps, then I will define my stack name, which is postgres underscore os underscore stc. Then you can see the two services are running, right? First is running on node 1 and second is running on node 2. So you can see is still the first service, the CentOS service is still in preparing mode. It is because the image of the CentOS is heavy and it will take some time to download the image. If I will again execute the same command, then it may possible this time this service will be up and running. So this service is still preparing, right? So we have to wait until the service will be prepared. If you want to see the logs, you can execute the command docker stack logs, then define your service name or ID. Let's clear out the console and identify the services which are running inside the docker. So docker services ls. Then you can see the two services running, right? One in CentOS latest and second is Postgres latest, right? So these are the same services which we have mentioned in our YAML file, right? So we are creating the stack with the help of the secrets. We have seen how we can use the file based secret. Also we have seen how we can use the CLI based secret. If you want to dig out any services, right, docker service ps, and I want to dig out the Postgres CentOS service, then you can see this is the service which is running about. It means it has just running about a minute ago. If I will again execute the docker stack ps and then define my stack name, then you can see the Postgres service is running from 2 minutes and the CentOS service is running from 1 minute, right? So this is the way how you can deploy a complete stack with the help of the docker secrets, right? So team, if you have any doubt, any question, then please let me know and I will happy to answer. So thank you team, thanks for your time.
Hello team, welcome back. And today we are going to start a new section, and in this particular section we will talk about the services. We will see how we can manage the services, we will see how we can scale up the services, and what are the good things we can do with the services. In this particular section, first we are going to discuss how we can upgrade the service in zero downtime. So team, as a DevOps engineer, this is my experience, and believe me, this is the most difficult and challenging task with the software companies. The zero downtime service upgrade is just a dream for many of the companies. Very few companies in IT industry got this milestone where they are upgrading their services with the zero downtime. As you can see, the many big companies have the maintenance window, right? They are upgrading their services, but they are taking the maintenance window. So there's a downtime involved in that particular service upgrade. So today we will see how we can upgrade the services in zero downtime if we are using Docker and Docker Swarm. So let's start with. So this is the another benefit and a big truth of the Swarm, that Swarm help us to limit the downtime of service update or service upgrade. With the help of the Swarm, we can do the rolling upgrade of the services. When we are saying the rolling upgrade, then what is the meaning of the rolling upgrade? What is this particular approach? So team, just take an use case. You are working on some application and that application is running on some version, right? Suppose we are working on XYZ application and that is running on version 5.5, right? Now what we need to do, we have some code changes in our application, we have some bug fixes, and we want to upgrade our service from 5.5 to 5.6, right? So there is a two kind of approach by this we can upgrade the service. The first approach is we can take the maintenance window, we can upgrade our service, perform the smoke and sanity test, and live the application in the production. And second thing is we can't take any maintenance window and we will do the rolling upgrade. So very first thing we need to take care, when we are saying the rolling upgrade, it means the same service is running on more than two servers, right? There are multiple servers involved in that particular service. on which that particular service is deployed, and they are serving the traffic to same service. So in general, in today, companies are taking the first path. They are taking the maintenance window and they are upgrading their services in the maintenance window, right? But when we are talking about the orchestration, we are talking about the Docker, we are talking about the Swarm, we are talking about the Kubernetes. So basically, we are automating the infrastructure. In that case, this is also a job of DevOps engineer to implement the zero downtime upgrade in services, right? How we can achieve this? So zero downtime is only possible when we have multiple servers that are running the same application, same version, and serving the traffic to the end user. When we are saying the rolling upgrade, then we can understand the rolling upgrade with this particular diagram on our screen. Suppose we have the user interface, which is a domain, like which is a www.facebook.com. So all the users are basically accessing the Facebook from the same domain. They are just hitting the URL and Facebook is on their laptop screens. But internally, Facebook have thousands of the servers. All the servers are executing maybe the same build, or they may using this different version of the Facebook, right? But we know very well that Facebook is accessible from a single point, which is the Facebook domain URL. But in the background, multiple thousands of the servers are running, which are serving the traffic to that particular domain, right? So this is called the infrastructure. This is called the cloud or IT infrastructure. And DevOps job is to upgrade the service with zero downtime. So when we are saying we are upgrading the service with the zero downtime, then we can say that up to n number of servers are running in any service, right? So we can say over we have the server 1, server 2, server 3, server n minus 1, and server n, right? When we are saying the rolling upgrade, so you can see some servers are in the blue state and single server is in the green state. So green state means this server is basically upgrading in that particular time, and this is not serving the traffic, right? All the blue servers, they are live and they are serving the traffic. So when we are saying the rolling upgrade, in the rolling upgrade, we will down a single server, upgrade the service on that particular server, and again attach that particular server in the production, right? Down the another server, upgrade the service, and again attach that particular server in the production. So by this way, we are not halting the user, we are not taking any maintenance window. Our service is running, some servers are serving the traffic, we are just picking one server, make it down, upgrade the service, plug in that server in the production. So by this way, we can upgrade all the servers one by one, and we don't need any downtime to upgrade the service. So this is called zero downtime upgrade or rolling upgrade approach, right? With the help of the Docker Swarm, this is possible. We will see how we can upgrade the services, scale the services with the help of the Swarm, right? So service upgrade provides the rolling upgrade of the replicas. As I have already mentioned that we need more than one servers, right? We need more than one replica of the service and containers with zero downtime. So basically when we are saying we are upgrading the service, in practical, we are basically replacing the old containers with the new containers, right? We are deploying our service in a new container and replacing the existing container with the new container. Let's talk about some example of the service upgrade. Suppose you want to enhance the version of your service. As we have already talked that XYZ service was running on 5.5 and we want to upgrade it on 5.6. So we simply update the service by command docker service update hyphen hyphen image and then image name and the service name. Suppose we want to update the complete stack. So when we are saying we are upgrading, we are updating, it means a service or a stack is already running. We are just adding some configuration, we are adding some more code, we are updating the build in that particular running stack or running service, right? In that case, we just need to edit the YAML and deploy the same YAML, right? All the things Docker Swarm will automatically handle, that how much container will be downed at a time and at what time the container will be again attached to the production. This is the complete job of the Docker Swarm. You don't need to bother about it, you don't need to do any extra stuff for this. So let's start with some nginx service, right? Let's start nginx service on port 8080, right? And start with some lower version. So let's go to the hub.docker.com. So you can see here we are on hub.docker.com, right? And this is my dashboard. Let's search for nginx. So nginx is a web server, and we can see the official image is here, and it have 10 million plus downloads. Let's open this image, and we can see we have a lot of versions available. So the older version we have 1.14.2, and the newer version we have 1.15.12. Let's do one thing. Let's deploy a service with this particular version 1.14.2. For this, we need to open the terminal and create the service. So here I'm on my terminal. Let's execute Docker service ls to identify is there any service running. So you can see the Postgres is running, right? What I will do first, I will remove this particular service. So I hope this service is running inside the stack. So I will put Docker stack rm, then my stack name, which is Postgres os.stc. So you can see it is removing all the services, right? We will again execute Docker service ls, and you can see nothing is running. Just clear out your console. Now create the nginx service. So we can create the service by command docker service create -p, define the port, suppose 80 for the container and 8080 for the outer world. Now we need to define the service name -name. Suppose we are going to define web underscore server, right? Then I need to define the image name, which is nginx 1.14.2, right? This is the image which we want to deploy. See 1.14.2, right? Hit enter button. So you can see it is creating the service. So it will take few seconds. Just wait. So we have to wait until the service will be ready, and it's done. If you will execute Docker service ls, then you can see the web server, right? nginx image 1.14.2 and single replica is running. So this service is running. Now we will play with this particular service. We will see how we can scale up the service, how we can upgrade the service, and all other stuff, right? So first we will see how we can scale up any service in horizontal. When we are saying the horizontal and vertical scale, so horizontal scale means we are increasing the number of replicas, we are increasing the number of containers. When we are saying we are upgrading the service vertically, it means we actually upgrading the resource in current service. We are increasing the number of CPUs on the server, we are increasing the RAM on the server, we are increasing the hard drive on the server, right? So today we will see how we can scale the service horizontally, right? For this, we need to add more replicas of this particular service. For this, you can execute the command docker service scale, then define your service name. In my case, it is web underscore server equals to define the number of replicas. So suppose I want to define the number of replicas 10. It means I want to execute 10 containers which will execute the nginx. Just hit enter, and you can see it is preparing all the replicas, right? So you can see the different stage of the replicas, like starting, running, and preparing, right? It will take some time, depend on your internet speed, and it will show you the result like verify service covered. Now if I will execute a command docker service ls, then we can see the 10 replicas are running, right? Earlier only one replica was running. It means 10 containers are running in this particular service. If you will clear out the console and execute a command docker service ps, then service name, then you can see the 10 replicas are running, right? One replica was started 2 minutes ago, and rest all 9 replicas started 40 to 30 seconds ago, right? Some are running on server 2, some are running on server 1, right? And they all are running with the nginx image 1.14.2, and this is the name of my services, or you can say the name of my task which is running inside my service, right? Let's clear out the console. So we have seen how we can scale up the services, right? Here we don't need to down the service, we can scale up the service with a single command, right? You can see I didn't stop the running container, I just added more containers in the existing swarm. So same command I have mentioned inside the slide, right? And I will attach this particular slide with this particular lecture so that you guys can get the help. Now let's see, we want to upgrade the service. We want to upgrade the nginx version in my production. Suppose we are running this service in the production and we are running 10 replicas. Now we want to shift my nginx from 1.14.2 to 1.15.12, which is the latest one, right? So this is the latest one, 1.15.12. So how we can upgrade the service in the Docker Swarm? How we can perform the rolling upgrade or the zero downtime upgrade in the Docker Swarm? For this, you need to execute a command, docker service update service name, which is web server. Then I need to define hyphen hyphen image, which image we want to deploy, which is nginx 1.15.12. Yes. And then we need to define the service name, which is web underscore server. So over here with this particular command, we are updating or upgrading the existing service. Which service? The web underscore server service. And what I'm upgrading? I'm upgrading the current nginx image, right? From version 1.14 to 1.15. Just hit enter. So you can see it will upgrade your service one by one. So over here you can see right now it is upgrading your service on task 1. It means on container 1. Now it is switching to the container 2. So this is called the rolling upgrade. Actually it is just picking one container at a time, upgrading your service and then picking the another container. So what is happening behind the picture? It will remove the one container from the production, right? Upgrade that particular container, then again plug in that particular container in the production. So by this particular way, your traffic will not get any impact, right? Your traffic is still working. Your users are still able to access your service. All the things are basically happening behind the picture. User don't feel any downtime. They don't get any outage. They don't get any 404 or 504, right? They will not get timeout or resource not found exception on the UI, because all the things happening behind the picture, and you can see all the servers has been upgraded. Now if I will execute the command docker service ps, then my service name, then you can see all the containers are basically upgraded on 1.15.12. And as I mentioned earlier that it will replace the container, so you can see it has already shut down the container which was working on the earlier version C, and it has plugged in the new containers, right? See, this is the scene with every case. All the 10 tasks basically have stopped the earlier container, the earlier version container upgraded to the new one, right? Let's clear out the console. Now suppose what you want to perform, you want to switch your nginx from 8080 to 9090. How can you do that, right? For this you need to execute the command docker service update hyphen hyphen publish hyphen rm, and your old port was 8080. Then again need to put hyphen hyphen publish hyphen add and the new port, and my new port is 89090 port 80. Hit enter. Oh, I need to provide the service name as well. Now hit enter. So you can see it is again upgrading container one by one, right? So it will not again impact your existing user base, it will not impact your running application. It is doing all the things behind the scene, right? Now some of the containers are serving the traffic on 8080 and some containers are serving the traffic on 9090, but your end user will not get any downtime, they will not get any outages, right? So this is the way how we can perform the rolling upgrade with the docker swarm. This is the simplest way, you can say the best example of the IT infrastructure or best example of the orchestration in the IT, right? So with the Docker Swarm, we can achieve the zero downtime with minimum impact. So you can see all the services are done. If we will execute the Docker service PS and my service name, now you can see the two servers is being stopped for every task. A new server is being attached because we are upgrading the port. Just clear out the console. Now if we will execute docker service ls, then you can see it is running on port 9090, right? If you want, you can access that particular service on any IP. if I will put the IP of my cloud machine over here and put 9090, then you can see I'm able to access the nginx, right? It means nginx is working in the Docker Swarm. Now let's go back to the terminal and stop this particular service. So how we can stop the service? Docker service rm and then the service name. Hit enter, right? Now again execute docker service ls. Then you can see no service is running. If we put docker service ps, then my service name, which was web underscore server, then I will not get anything, right? So all the services are being stopped, right? So we have seen how we can upgrade the services and how Docker Swarm help us to maintain the zero downtime during the upgrade. What we need to do, we just need to containerize my application. We just need to execute my application inside the Docker, and Docker Swarm will manage all the stuff for you on the production. So Docker Swarm is very helpful for the production, right? This is a really production tool, right? This will work like the Kubernetes and Ansible, right? When we will learn about the Kubernetes, we will see Kubernetes is much more advanced than the Docker Swarm. It has their own cookbooks, it has their own rules and own arms, right? So we will see when we will learn about the Kubernetes, right, in the coming lectures. Today we are discussing about the Docker Swarm, and you can see Docker Swarm is really a production tool, right? So thank you, team. Thanks for your time. If you have any question, any doubt, then please let me know and I will happy to help. Thank you, team. Thanks for your time. Hello, team. Welcome back. And today we are going to discuss about a new feature in Docker Swarm, which is health check. So today we will see how we can perform the health check of the Docker services in the Docker Swarm. But before starting with the health check, we need to understand what is the health check and what is the benefit or application of the health check in Docker Swarm. So let's start with. So basically, health checks are exactly what they should like a way of checking the health of some resources. So suppose you are executing some application in a production and you want to know then where is your application performing below the threshold or your application is down or not. So you want to put some monitoring, you want to put some health check on your service. So as soon as your service will go down, you will be notified, right? So basically in Docker Swarm as well, the health check implemented in the same way. Docker have their own inbuilt health check functionality in which the Docker check the health of the container, right? So we will see how we can implement the health check in the Docker containers, in the Docker services, and how Swarm will help us. If we will see the application of the health check, then in the Docker we can apply the health check with the Docker run command, we can apply the health check with the Docker file itself, and we can apply the health check in the Docker services and Docker stack. So there is no limitation as this is the part of the Docker toolkit, so we can use it anywhere in our Docker services. With the help of the Docker health check, we can identify whether the service is running or not, right? So when we are saying that the health check is basically applicable with the Docker containers and health check is basically applicable with the Docker service as well. Now suppose you want to put the health check in your Docker file, you want to put the health check in your Docker compose YAML file or Docker YAML file. So this is the command format which can be used to put the health check in the Docker file, Docker YAML file and Docker compose YAML file. So we need to define the health check, then we need to define the options. We will see what are the options available with the health check. Then we need to define the CMD, and outside the CMD in the braces of command, we need to define the command which will check the container health, right? Here you can put any command which will check your container health, which will check your application health, right? And this is the benefit of the health check in the Docker, that Docker health check apply on your container from the initialization of your container, right? So if your container is not coming up due to some errors, then it will fail your container, right? If your container will fail anytime during the process, then it will notify you or the health check started failing, right? So over here we have seen that health check have some options. So we will see what are the options available with the health check, right? So basically these options are available with the health check to modify the health check configurations. So by default, if you want to modify the interval of the health check, then you can choose hyphen hyphen interval, the time interval between two health checks, right? By default the value is 30 seconds. So if you're not choosing the interval, then by default the interval between the two consecutive health check is 30 seconds. If you want, you can specify these things in terms of a second. Then we second then the second one we have the timeout, right?
Then the second one, we have the timeout. So timeout for running the health check command. So basically you have executed the health check, then we need to define some time frame. After that particular time frame, the next health check will execute. So timeout of the health check basically defines, and the next is the timeout. So timeout for the health check is defined that when the user will notify, right? By default the timeout value is 30 seconds, but if you want you can decrease it. So timeout, basically timeout is a timeout of health check. Suppose if your health check is failing, then after 30 seconds the another health check is also failing, then you will get the notification. If you reduce this particular time, then you will get the notification in that particular time frame, right? So we have the interval, we have the timeout. There are two more properties. The first is the retries. The container status is regard to unhealthy if the health check fails continuously. So by default the value is 3. If 3 consecutive health check got failed, then you will get the notification, or Docker Swarm will take the appropriate action, right? And last configuration option is the start period, which will define that after which particular time the health check should start. By default, the value is 0. It means as soon as you will initialize your container, health check will apply on that particular container. If you want, you can configure that as well. Suppose you have containerized your application and by default your application uptime is 20 minutes, right? So in that case, if you are not modifying the start period, then your health check will start failing, right? A new container inside your Docker Swarm or Docker service being created. So to avoid these kind of situations, we have the start period. If we know that our application is taking a standard 25 minutes in a start, right? Then we can define the start period 25 minutes. That after 25 minutes, the health check will start, right? First, we will verify the health check of the Docker container. Then we will verify the health check of the Docker service. Now, before going with Docker containers and the Docker service, we need to understand what is the benefit of the health check in Docker Swarm. Although containers are also providing the health check, but how the containers health check is not beneficial as compared to the Docker Swarm. So basically, if you are putting the health check on your Docker container and somehow your health check will start failing, then container will not take any action. But if the same thing is happening inside the swarm, suppose you have put some health check on some stack on some services, and somehow some task inside that particular service start failing, it means some containers start failing, then Docker Swarm will take the appropriate action. It will down the unhealthy container and spin up a new container, right? So this is the benefit of the health check with the Docker Swarm. So we will see how we can apply the health check on the Docker containers and how we can apply the health check on the Docker services. For this, first we will go to the terminal. So you can see we are inside the terminal. If we will see the running directory, then I'm inside the root. If I will put ls, then these are the directories which are present over here, right? Suppose I'm creating a new directory, mkdir health check, right? Put ls, the health check directory is being created. See, now I will go inside this directory, put ls. So there is no file present over here. So we can see right now we are on terminal. So first let's execute an postgres image, right? So to start the postgres inside the container, we need to execute docker container run. And suppose I'm going to postgres like post g, like postgres 1. Then I'm going to define in the detach mode and define the image, which is postgres, right? Hit enter button. So this will start your postgres container. See, docker ps, then postgres container is running, image is the postgres, and this is the name of my postgres container, right? Now what we need to do, we need to set up an health check on the postgres, right? So how we can set up the health check on a postgres? So there could be multiple health checks on the postgres. Suppose we want to set up the easiest way, so we are going to set up that is my postgres db accepting the connection or not, right? If your database is not accepting the connection, then it means there is something wrong with your database, right? It is not ready to execute the queries because it is not accepting the connection, right? So in the Postgres, we already have an utility which is called pg underscore is ready, right? When we will execute the pg underscore is ready, it will show you the Postgres DB is actually accepting the connection or not, right? So now if I will go inside the Postgres container, see, I'm going into the Postgres container. So Docker container exec -it, my container name, then bash, right? pwd. So right now I'm inside my Postgres container. See, the root has been changed to the Postgres container location. Over here, if I will execute pg underscore is ready -u, then I will define the default username, which is Postgres. Then it should return some output. And see, it is returning where run PostgreSQL 5432 accepting connections, right? It means if your DB is healthy, if your DB is ready, then it will accept the connection. And this is the command which will tell me that is my DB in healthy state or not. Because by this command, we can identify is my DB accepting the connection or not, right? So let's exit out the container. Again, execute the command docker ps so that we can see only one Postgres container is running. Now let's start another container and put the health check on that particular container. So we need to execute a command docker container run -d for the detach mode --name, and I will name it Postgres 2, right? Now to define the health check, I need to define the --health -cmd, which means health check command equals to, put double quote, and inside these double quotes you need to put the command which will execute on your container to check the health check. So this is the command pg underscore ready -u postgres, right? I will copy this and put it inside my double quotes. Now I need to put pipe and then put exit 1. What does it means? If this particular command will fail, then exit out the container. It means return the 1. So in the Docker container, health check always return two value, either 1 or 0. If it is returning 0, it means everything is fine and we don't need to take care anything, right? If it is returning 1, then the health check is failing and we need to do something, right? And after this, I need to define my image name, which is Postgres. Hit enter. So you can see the container is running. Now put docker ps. As soon as you will put the docker ps, you are getting something new over here, and it is showing health colon starting. It means your container health is basically in the starting mode. The health defined in the three levels. The first level is the starting. It means whenever your health check is being starting or your container is being started, right? As we don't define the start period, so by default it will take the health check from the initialization, right? The second is healthy and the third is unhealthy, right? So right now we are in the first stage when the health check is just being started or the container is just being started. If I will again put the docker ps, then we can see the container is up from last 47 seconds and the state is healthy, right? Now let's execute one more container of the Postgres and name it Postgres 3. And instead of the Postgres user, suppose I am trying to access the Postgres DB with some other user like root. Let's see what it will return. So the container is starting. Now put docker ps. So you can see it is showing the health check is starting. The second container is already in the healthy state, and on the first one we didn't put any health check. So we have to wait for the 30-second because the default interval is the 30-second and we have not set any interval, right? Now clear out the console. I hope the 30-second is gone, and again put docker ps. So you can see it is showing healthy. It means we are able to access the particular Postgres DB with that particular user as well. So this is the way how you can put the health check on the containers, right? But there's a catch when we are putting the health check within the container and when we are putting the health check within the services. Now we need to understand why the health check with the containers is not useful, and why the containers and why the health check with the docker swarm is helpful, right? So whenever you are putting the health check on the container will not do anything if the health check will fail. But whenever you are putting the health check with the docker swarm and in somehow that particular stack or service or any task will fail, then it will spin up the new stack, new service or new task, right? So let's create the Postgres service in which we will put the health check. right? So Docker service create, then we need to define the service name. Suppose I'm defining Postgres or Postgres service 1, right? Then Postgres, just the image name. Hit enter and it will create the Postgres service. So you can see the service is running, right? It switched the status from starting to running in very few seconds. If I will put Docker service ls, oh, not l, it is ls, then you can see this service is running, right? The Postgres service is running, right? Clear out the console. Now what we need to do, we need to put the health check in my service, right? So for this I need to put the health check command over here. So I will put health hyphen cmd equals to double colon, then put pg underscore is ready hyphen capital U Postgres, put pipe exit 1, right? And suppose I'm going to rename my service with the Postgres service 2. So here we will see a new thing. Once we will starting the services, then you can see it is not coming in the running mode. It is still in the starting mode, and it will keep itself in the starting mode up to 30 seconds. So we have to wait. So you can see it is still in the starting mode, and after 30 seconds it will switch to the running mode and it will start your service. So let's see when it will start my service. So see, just after 30 seconds, the service mode is changed from starting to running. Now why it took 30 seconds? Because when we are running the health check inside the Docker Swarm, it will not accept the service as a running until the first health check will be passed, right? And by default, the interval time is 30 seconds. So at the time of initialization, the next health check will attempt on after 30 seconds. So for that particular time frame, the status was in the starting, right? Now, anyhow, if your Postgres DB will be down, right? Anyhow, if your Postgres DB will be down, then it will spin up a new container, right? So this is the benefit of the Docker Swarm, right? When we are putting the health check with the Docker Swarm, it is really beneficial. We don't need to take care about anything. As soon as your service will be unhealthy, Docker Swarm will automatically spin up a new container for you, right? And you will not get any outage in the production. So that's all for the day. In the coming lecture we will learn few interesting things about the Docker Swarm. So thank you team, thanks for your time. Hello team, welcome back. And today we will see how we can fix the container placement in services. So we are going to discuss how we can fix the container placement on a particular node in a particular service. So sometimes you have a need that you want to execute some specific task of a specific service on some specific nodes, right? Suppose you have mounted some location on some particular node and you want to execute that, my DB will execute on that particular node only. So in that case, we need to fix that these particular nodes will execute these tasks or the container only, right? So to resolve this particular problem, we have a way so that we can fix the container placement in Docker services. So let's start with. So basically we have seen we have set up a cluster of 3 nodes, right? Where one was the master and 2 was worker node. And Docker Swarm automatically try and place your containers across the master and worker nodes, right? When you will spin up a service with 15 or 10 replicas, Docker will not ask you to provide the nodes on which particular node the containers should be placed. It will automatically manage all the things by itself. So Docker Swarm have their own algorithm, they have their own parameters, like on which node which container should be executed, on which node which services should be executed, right? So till date we have seen that Docker automatically distributing the containers across the nodes, right? And today we will see how we can fix the container placement on a specific node. So there could be the multiple applications. When we are saying we want to fix the container for a specific node, there could be multiple applications. So let's take in some example. Suppose we have some monitoring app, right? And we want to monitor the health of my manager. So that monitor app must execute on the master node only, right? So this is the one application. Suppose you are executing your infrastructure in AWS, you are executing your infrastructure on Google Cloud or on Microsoft Azure Cloud, right? and you have created some deployments where in the Amazon you have deployed some RDS servers, in GCP you have deployed some database PPA servers, and you want to execute that, your Postgres DB or your MySQL DB container will execute on these particular nodes only, right? So in that case as well, you need to fix the DB container placement on these particular nodes, right? Which servers you have dedicatedly deployed for these containers. So there could be the multiple applications when we need to fix the container placement on a specific node. And today we are going to resolve that particular issue with different approach, right? So the first approach which we are going to take today, which is service constraint. So today we will see how service constraint will help us to fix the container placement on a specific node. So service constraints are basically used to control the nodes a service can be assigned to, right? So at the time of service creation, at the time of service updation, you can define the constraint and which will directly apply on that particular service and bound that particular service to the given node. Then we can define the constraint in multiple ways. So let's see what are the constraints we can define and what are the other applications. So as I told you, the service constraints can be added at the time of the service creation, could be added at the time of service removal or update, right? So suppose we are defining some hard-coded constraint and that constraint is not matching. In that case, your container placement will be failed, right? And your container will not start. It will always in the pending state. So suppose you are defining some constraint in the service that you want to execute a specific container on a Windows node, right? And in your Swarm, you don't have any Windows node. So in that case, that container will never execute. That container will always in the pending state, and after some time it will fail. We can define the multiple constraint to a single service, right? You can define the multiple constraints. Suppose you want to execute your container on the Linux box, and you want to execute your container on the Linux box which have 16 core CPU and 52 megabyte RAM. So in that case, you can define a particular constraint that this particular container should execute on the Linux box. And on which Linux box? On the box which have the 16 core CPU and 52 GB RAM, right? So we can define the multiple constraint to a single service as well. So when we are saying the constraint, so basically we are putting the key value pairs in the service command, right? So we are putting the key value pair in the service command, or we are putting the key value pair in the Docker YAML file, so that my service will be executed and it will assign to a specific container. So in the past few lectures, we have seen a specific application called visualizer, right? So visualizer is used in the Docker Swarm to monitor the Docker Swarm, right? How many containers are running on which node, right? So first, let's start the visualizer on the Docker Swarm mode, right? For this, we need to execute this particular command, docker run -it-d -p. We are going to expose the visualizer on port 8080. In your case, if the port 80 is busy, you can put any other port, right? Then we are defining the shock location, mounting the shock location, and Docker samples visualizer, right? So Docker samples visualizer, Docker samples is the official Docker repository, and visualizer is the build name, right? So let's execute this particular command on the terminal. So I am on my terminal. First, let's see, is there any Docker service running? So Docker service ls. So in my case, no service is running. In your case, if some services is running, then let's first clean these services. It's not mandatory, but it's good to clean the old services when we're starting something new, right? Now let's see some containers are running or not. So docker container ls, and no container is as well running. Now I will start the visualizer. So the command is docker run -it-d-p port, then define the mount location, then the image name. Hit enter. So you can see it is showing unable to find the image visualizer locally. Then it downloaded the image and started your container, right? If you put docker container ls, then it is starting. Then the visualizer is in the starting mode, right? So let's go to the browser, and over here let's put the IP of a machine where my docker container is running, right? And then put the 8080, because we have started the visualizer on port 8080, and hit enter button. So you will see a screen like this. So right now we can see we have the one manager which is live, we have the one worker which is live, and we have another worker which is down. The same thing we can reflect on the terminal as well. So if we will put docker node ls, then we can see this node is down, right? And two nodes are running. The same thing we are getting on the browser. See, and no container is running on my machine, right? Now let's move further. Now suppose first we want to see how we can execute a particular service on the manager node, right? So for this we need to define the service constraint. And how we can define the service constraint? We need to append hyphen hyphen constraint inside the service run command, right? If we are using the YAML file, then we need to define the constraint as a separate label. So we will see how we can use the constraint in the YAML as well. First, let's see if we are executing the service command, then how we can define the constraint, right? And over here we need to define the values in the key value pair, right? So first we need to define the key, and then we need to define the value. So in our case, we are going to execute a particular container on a master node or on the manager node, right? So we need to define the key. And what is the key? Node dot role, right? What is the key? Node dot role. And what is the value? Value is the manager. So this is the command which will help us if we want to execute a particular service on a manager, right? So docker service create hyphen hyphen constraint node dot role equals to manager. Then you need to define your image name. So let's start the postgres db on the master node. So we are on a terminal. Clear out the terminal, right? And execute docker service create, right? Hyphen hyphen name, and I will call it postgres db. Then we need to define hyphen hyphen constraint, then define node dot role equals to manager. Then we need to define the image name, which is postgres, right? So we are starting the postgres service on the manager node. So you can see the service is in the running mode, and we have to wait for 1 second only, and services start. If we will put docker service ls, then we can see the service is running. If we will go to the browser and we will refresh the visualizer, then you can see a postgres db is being started on the manager node, right? So this is the way how you can start something on a particular node. Suppose you want to start another service on the worker node, then let's see. So we will again put docker service create hyphen hyphen name, and we will call it nginx, or we will call it web server, right? Hyphen hyphen constraint node dot role equals to worker replicas hyphen hyphen replicas equals to 5 nginx. Hit enter button. So it will start. Oh, we need to define double equals over here. Node dot role equals manager. So it will start 5 replicas of the nginx server on the worker node. So you can see all 5 replicas are running, and service will start soon. So you can see the service is started. If I will put docker service ls, then we can see two services are running, the postgres db and nginx. 5 nginx container are running in the nginx service, and only one container is running in the postgres service. If we will go to the visualizer and we will refresh it, then we will see the 5 nginx container are running on the worker node, and only single container is running on the manager node. So if we did not define the constraint with the nginx, then docker swarm must distribute all the loads between the master and the worker, right? It may possible that 2 containers was running on the manager node and 3 containers was running on the worker node, or 3 was running on the manager or 2 was running on the worker. Docker swarm automatically manage that particular load. But as we have defined the constraints, so docker swarm basically started all the containers on the same machine, right? But in that case, this is harmful as well. Somehow your worker node or somehow your worker machine will go down in the cloud, then all your service will stop, and docker swarm will not start new web server or any new node. Why? Because we have bound the constraint with the node and cluster, right? So in some case this is helpful as well, but if we are using it roughly, then it is harmful as well. Now, some time ago, we was talking about if we want to execute some specific application on a specific node, like we was talking, we want to execute some application on a particular node which have 16 core CPU and 52 GB RAM. So how we will define it? How we will create the constraint for these particular conditions? So in that case, first we need to create these conditions, then we need to create the container on these conditions, right? So when we are saying we are creating these conditions, we are basically labeling these particular nodes, right? Inside the Docker Swarm you can label your node. That is something like a tag, right? So you can tag your nodes, you can tag your clusters in the Docker Swarm, and you can update your clusters as well, right? So how we can label or tag our node? For this you need to execute a command docker node update hyphen hyphen label hyphen add. Then you need to define the key, and then you need to define the value, right? And after then you need to define the node value as well, right? So for this, let's first execute docker node ls, right? And we are getting the node id, node host name, node status, availability, manager status, and engine versions, right? So to update the node label, we will execute a command docker node update hyphen hyphen label hyphen add. And suppose you want to define the region of my particular cloud machine, like my cloud machine is running in north region or east region 1D, right? So we will define the region, right? East hyphen 1 hyphen d. You can define anything over here. It's not like that you can't define anything. You can define equals to name equals to machine 1, or name equals to your name only, right? I'm just defining the reason because these seem some professional tags. When you're working on a stack, you need to know that which machine is running on which node, which machine has which configuration, and where that particular machine is associated, right? So I'm assuming that my master node is basically deployed in the east 1D region, right? Then I need to define, either you need to define the master node ID or the host name. So I'm defining the ID, hit enter. So label has been created, right? If you will put docker node ls, so we have defined the label, but if we want to identify that where this particular label is defined or not, right? So let's execute docker node ls, right? And we know that we have defined the label on the master node. For this we need to inspect the node. So docker node inspect, then define the id of your node, right? And once you scroll a bit, you will get the label as well. See, you are getting the specification, and in the specification you are getting the role, which is manager, and labels. We have defined the region east hyphen 1 hyphen d, right? Now what you need to do, you need to start some services on this particular node. So now suppose you want to execute a new service on the newly labeled node, right? For this I will execute a command docker service create hyphen hyphen name. Suppose we are going to start the another Postgres service, then hyphen hyphen constraint. Then we will define the node dot labels dot reason. This is the label name we defined, equals to east hyphen 1 hyphen d. Then I will define the Postgres. Hit enter. So it will create your Postgres service on the machine which have the label region east 1 hyphen d, and you can see the service is done. If you will put docker service ls, or we will directly go to the browser and refresh the browser, then you can see the Postgres DB is being started on the master node, and you can see this is the another service, so that we are getting it in a different color, right? So we have seen how we can define the label and how we can create the service on a particular labeled node. Now suppose we have a requirement where we need to remove some constraint and we need to add a new constraint over there, right? For this you can execute a command docker service update hyphen hyphen constraint hyphen rm to remove the constraint. Then you need to define the constraint name, and then you need to define the constraint add and define the new constraint, right? And then you need to define your service name. So let's go to the terminal and execute a command docker service update. Then we have hyphen hyphen constraint hyphen rm equals to, suppose we want to remove this particular service from this particular constraint. Then again define the hyphen hyphen constraint hyphen add. and define the new constraint, which is not dot uh, role equals to worker, and define the service name. So this was my service name. I will copy this and paste it over here and hit enter, and I'm getting some error. Okay, so here it is expecting two. So here it is expecting actually 2 equals role equals worker. Hit enter. So it is updating your service, right? Now if we will again go to the browser and we will refresh this, then you can see the pod gress. This was my service name is being started on the worker node, right? Right, so this is the way how you can define the constraint with the particular service, or how you can bind the containers with a particular node in the Docker swarm. So that's all for the team. If you have any question and doubt regarding the same, then please let me know and I will be happy to answer. So thank you team, thanks for your time. Hello team, welcome back. In the last lecture we have seen how we can create the Docker containers on a specific node with the help of service constraint. Today we will see, if you want to put the constraint in a stack file, then how we can do it, right? So we are going to create an stack file where we will put the constraint inside the stack file, and that particular service will deploy on that particular constraint, right? For this, I need to create an stack file. So here is a stack file which I have created, right, which has the version 3.1. Then I'm defining the services, and in this particular service I'm going to start the MySQL DB, right? This will take the MySQL official image, it will deploy the one replica, and over here we are getting two new tags, the placement and constraints, right? So to define the constraints, first we need to define the placement, where we are going to place that particular container, and then we are defining the constraint, and constraint keys node.labels.reason, and the value is east hyphen 1 hyphen d. If you remember, then in the last tutorial we have added this particular label with my master node, reason equals to east 1 d, right? If you want to check, you can go to the visualizer. So over here we are on the visualizer. You know, in the last lecture we have started the visualizer on port 8080, and on the manager we are getting the reason c, reason east 1d, right? Here we are getting the reason. So I'm going to start the service with the help of a stack file. On which node? The node which have the reason east 1d, right? So let's go to the terminal. So we are on a terminal. First let's check, is there any service running? So docker service ls, and no services is running. Now put ls, and over here we have different directories, right? So let's go to any directory. Suppose I'm going to the health check one. If you want, you can create your own, right? Okay, let's create the own mkdir and create service constraint, right? Put ls, a new directory called service constraint is being created over here. I will go inside this particular directory, put ls. So there is nothing. Now I will create the docker compose file, right? So docker compose.yml. If you want, you can name it anything, right? I prefer to take the name docker compose. Now I will go to the Visual Studio and I copy the complete content from here. I will go to my terminal and paste the content in this particular terminal, right? So in the version we have VIRSION 3.1, then we are defining the services, then we are defining the image, then deploy, we are deploying the one replica, and then we are defining the placement, and the constraint is not label reason east 1d. I will just save this particular file, put ls, then you can see docker compose YAML file is here, right? And to deploy the stack from a YAML file, what is the command we need to insert? We need to insert docker stack deploy hyphen c, then we need to define the docker file name, and then we need to define the stack name. So suppose I'm going to define MySQL, hit enter, and on this particular command we are getting this particular error, constraints additional property constraints is not allowed. So it means we have something misplacement in our docker compose YAML file, right? So team, I just place an indentation over here because earlier this was like this. I just put an extra space over here so that we can make the proper indentation, right? So we are defining the services. Inside the services
we have the service name MySQL DB, which has the image, and in the image we are deploying it one replicant, placement, and constraints, right? Just save this file, clear out your console, and again execute the Docker compose, right? So Docker stack deploy -c Docker compose YAML and then your stack name. Hit enter button. So you can see it is starting your service, right? So it is saying creating network MySQL underscore default and creating service MySQL DB, right? If I will put Docker stack ls, then you can see the MySQL stack is running. If I will put Docker services ls, it should be ls, then you can see one service named MySQL underscore MySQL DB is running. If we will go to the visualizer and refresh the visualizer, then we can see MySQL service is running on the region which have the node region 1D, right? But you can see this service is basically not starting properly. This is blinking, right? And why this is blinking? Because Docker is not able to start this particular service in a healthy mode, right? And why Docker is not able to start this particular service in a healthy mode? Because we have not defined any environment variable for the MySQL DB. So let's define the environment variable for the MySQL service first. So to define the environment variable inside the image, in parallel of the image, we will define the environment, right? So suppose we are defining the root password, which is my password, and we are defining the MySQL database, which is Drupal, or you can put it anything, or you can put the name anything like MySQL DB, right? Now I will again copy the file, go to the terminal, edit the Docker Compose YAML, and replace the existing YAML with the new one, right? Save the container. Now first what I need to do, I need to remove the existing stack. So rm, then I need to define the stack name, right? So you can see it is removing the service and the network. Docker, let's clear out the console, hit Docker stack ls, then you can see nothing is running. I will again deploy the same stack with the same file. So we need to execute the command docker stack deploy -c docker compose yaml mysql. Hit enter, then it will deploy the service. So let's go to the visualizer again, and now you can see the MySQL DB task is running on the master node which have the region east 1D, right? You can see over here, and this service is not blinking. The service indication is continuously green. It means this service is in the healthy state, right? So this is the way. If you want to put the constraint inside the Docker YAML file, you want to put the constraint into Docker stack or Docker service, then how can you put the constraint with the help of the YAML file, right? So if you have any doubt, any question, then please let me know. Thank you, team. Thanks for your time. Hello, team, and welcome back. Today we are starting with Kubernetes introduction. We will see why Kubernetes and what is the use of Kubernetes. As a lesson breakdown, we will discuss why Kubernetes, what is the impact of the Kubernetes, and few components of Kubernetes. Here I would like to mention we will follow the waterfall model. We will come from basic and then we will move to the advanced. So before we start with the Kubernetes lab, we will go with some theoretical aspects. So we will understand the Kubernetes and then we will jump to the Kubernetes hands-on labs. Let's start with Kubernetes introduction. Kubernetes is an open source orchestration system for Docker containers. So I'm assuming we all are familiar with the Docker container technology where we execute the application within containers. And Kubernetes is an orchestration system for those containers. In easy word, we can say Kubernetes will execute your Docker containers and it will manage your Docker containers. Although Kubernetes is an open source, but that is implemented by the Google. Google was using an internal tool called Borg, and in 2016, Google launched the Borg as a open source and named it Kubernetes. Kubernetes is platform that eliminates the manual process involving the deploying containers application. As I told you in layman terms, Kubernetes is a tool which will manage your complete containerized application. It will manage the deployment, monitoring, execution, and a lot of things. Shortly, we will discuss about it. Kubernetes is used to manage the state of containers. When we are saying the state of containers, we mean Kubernetes will decide that whether the container is going to start. Suppose you have the multiple nodes in Kubernetes, and nodes are specific to the application. Some of the nodes are dedicated to the database, some of the nodes are dedicated to the web servers, some of the nodes are dedicated to the middleware. So Kubernetes will maintain that whether that container is going to start. The DB container will start on the DB node, web server's container will start on the web server, and vice versa. Restarting the container is also a task of Kubernetes. Due to any reason, if your container application got crashed, then Kubernetes automatically identify it and restart it. We will see how Kubernetes can identify it, how Kubernetes manage the Docker health, and how we can apply the restart policy on the Docker systems. With the help of Kubernetes, you can easily move your containers from one node to another node. In your business, if you ever get a need that we need to move few containers from node A to node B, you can easily shift the containers from node A to node B with the help of Kubernetes. Let's discuss few problems which Kubernetes is solving. So suppose this is your production system and the multiple containers is running in your production system. What could be the impact of this multi-container execution if Kubernetes or any orchestration system is not in use? And first impact is a lot of human cost required to running the service. If you have 100 or 1000 containers in your production system and you are not using any orchestration application, you are not using the Docker Swarm or you are not using the Kubernetes, then the engineer who is managing the production, they need to manage the all containers manually. They need to manage the monitoring of these containers, they need to manage the upgrade of the application, they need to manage the health of these containers. There's a lot of things which can impact your environment. So slowly, we will learn about these limitations and we will see how Kubernetes minimize these limitations or completely remove these limitations. Another impact is increase the bills from cloud service provider. That is definitely a big question. Somehow it is hard to predict that how many hardware resources required to execute a specific number of containers. In lack of resources, you can manage the bill, but you will compromise on the performance of your application. And in excess of resources, you are not compromising on performance of your application, but you are paying a good amount of bill. Another factor is increased complexity of infrastructure. So as soon as the customer base will increase, your application size will increase. Today you may executing 1000 containers, and 1 year or 2 year down the line it may possible that you need to set up the multiple environments, right? And in that case, whenever you have the multiple environment, the number of containers, the number of application instance is also increasing. So the complexity of infrastructure is another factor. Scaling very difficult. Definitely whenever you are executing the application manually and you need to scale up the instances, right, that is quite difficult. And whenever you are doing that thing manually, you need to be very specific. Setting up service manually, that is the another thing. You need to set up the application manually. There is no system which can do that work for you, so you need to set up the application from scratch manually. And the last factor is manual fix if any node is crashed. That is the big problem. Due to any reason, if the execution node means the node where your containers are running, if that node got crashed, then you need to fix that manually. You need to build all the containers or all your application instance which was running on that node manually. So there is a lot of problems in absence of the orchestration system. That orchestration system may be the Docker Swarm or maybe the Kubernetes. But Kubernetes have a lot of advantage over the Docker Swarm, so that Kubernetes is capturing the market very rapidly. Let's discuss few features of the Kubernetes. Automated scheduling is a feature. So in Kubernetes, you will get the scheduler which will help you to schedule the resources automatically. Another feature is healing capabilities. As I told you that Kubernetes can automatically restart the crashed containers. So you can set up, you can put the rules in the Kubernetes, and with the help of that setup, with the help of these rules, and these rules are called liveness and readiness. With the help of these rules, these capabilities, Kubernetes can automatically heal your application. No human intervention required in that case. Another big plus is auto upgrade and auto rollback. If you are executing your system on Kubernetes, then you don't need to go manually increase the containers, decrease the containers, upgrade the application, roll back the application. No, there is nothing like that. You can Submit a job to Kubernetes engine, and Kubernetes engine will take the latest build and do the complete upgrade and complete rollback without any manual intervention. Few more features like horizontal scaling. If load on your application is increasing, then Kubernetes automatically scale your application. You just need to attach the auto scaling capability with your setup, and Kubernetes will automatically scale and descale your system. So in peak hours, no human intervention required to scale the application. That is the Kubernetes job to scale the application, and it will consume the resources accordingly. Storage orchestration. So Kubernetes provide the functionality. You can choose the storage of your choice. If you want to keep the data in your local box, you can do that. If you want to set up and mount some public cloud storage with your applications, you can do that. We have the features in Kubernetes to set up the storage as well. Then that is a very important and very weighted point, the secret and configuration management. Kubernetes can help you to manage the secret. You can keep your credentials within the Kubernetes, and Kubernetes will keep your secrets without any expose. You can update your credentials anytime. And regarding the configuration management, as I told you, if due to any reason your node got crashed, then Kubernetes have the information about all the containers, all the application instances and nodes. As soon as the node will crash, Kubernetes will recover the node, and it will start executing the containers or the application instances which was running on that node. Now the question comes in, where we can execute the Kubernetes. If you have an on-prem setup, you can execute your Kubernetes on your on-prem setup. If you want to execute the Kubernetes on any public cloud, right, you can execute the Kubernetes on the public cloud. Even Kubernetes is a quite famous application. So almost all of the famous cloud providers are providing Kubernetes as a service. I mean, you don't need to create the instance and set up Kubernetes externally on it. No, mostly all famous cloud providers, even Google, AWS, Azure, Alibaba, DigitalOcean, they are providing Kubernetes as a service. You just need to go and use that service. You can set up the Kubernetes on the hybrid cloud as well. It is possible that you can spin up the master node on the AWS, and you can spin up the slave nodes on the Google Cloud or Microsoft Azure or in some other cloud. So there could be the multiple combination, and you can execute the Kubernetes anywhere. That is an open source application with no limitation. So that is a very basic introduction. We will learn about the Kubernetes architecture, and then we will directly jump into the Kubernetes setup and labs. Thank you, team. See you later. Hello, team. Welcome back. And this lecture on Kubernetes architecture overview. We will learn the Kubernetes architecture and the component functions of Kubernetes. So in implementation, Kubernetes follow the master slave node architecture. In Kubernetes, you can have the single master or multiple master node, and single slave or multiple slave nodes. In general, the slave node called the worker node, and master node called the Kubernetes master node. Master node is responsible for the management of your Kubernetes cluster, and that is also the entry point in the cluster. So whenever the end user is submitting some task to Kubernetes cluster, that task or that job will received by the Kubernetes master, and then it will execute further. Kubernetes can have single master node, or in HA deployments, I mean high availability deployments, you can have the multiple Kubernetes master node. We will learn about the advantage and disadvantage of having single master node and multiple master nodes. At a high level, Kubernetes workflow will look like this. Here, the end user can submit the request to Kubernetes cluster either by the Kubernetes CLI, or you can submit the request or submit the job by the REST APIs or Kubernetes UI dashboard. That event will be accepted by the Kubernetes master node, which have the multiple components, and the combination of these components called the control plane. Within the control plane, you have the kube controller, kube API server, kube scheduler, and kube key value store, which is called etcd. Then that master node can connect with the worker nodes. You can have the multiple worker nodes connected with a single master or multiple master. And on the worker node, we have the kube proxy, we have the kubelet, we have the pods and services. So shortly, I will come to that point. What is the use of each component within master and worker nodes? First, we will discuss about the master node, and in master node, the controller is Kube API server. Kube API server is an entry point within the cluster, and that is a single destination for all the REST APIs, whatever you are submitting to your Kubernetes cluster. Within the Kubernetes cluster, please make sure all the requests accepted by the Kubernetes that is being done by the REST APIs. So Kube API server will manage the complete inflow and outflow for the Kubernetes cluster. Kube API server is the only interaction point with the Kubernetes. Apart from the Kube API server, the another component which we have on the control plane or on the master node, which is called etcd. Etcd is a key value, or you can say that is a distributed database for the Kubernetes. Etcd will contain the state of your Kubernetes cluster, and that is used as a backend service for your Kubernetes cluster. Etcd will provide the high availability of the data which is related to the cluster. The complete state of your Kubernetes cluster is saved in the etcd database. And due to any case, if you lost your cluster, then you can recover your cluster with the etcd database. So on production machines, it is very necessary to externalize the etcd database from Kubernetes cluster, because in any case, if my master node is going down, then I can recover the master node from the etcd database. But if my etcd is not externalized and that is present on the master node, then at the crash of master node, the etcd database will also crash and you will not be able to recover your Kubernetes cluster. Apart from the Kube API server and etcd database, there is a one more component in the control plane which is called scheduler. Kube scheduler is basically used to schedule and regulate the jobs on Kubernetes cluster. So Kube scheduler basically regulate the task on the slave node. Scheduler will get the information regarding the resources which are present on the slave node, and then it will schedule the node on a suitable slave. Then with the Kube API server, etcd, scheduler, we have the another component in the control plane which is called the controllers. Controller in Kubernetes will manage the bunch of jobs. Whenever you have a bunch of jobs, controller will execute these jobs or the controller utility as a single process. In Kubernetes cluster, there is a lot of automated task, there is a lot of automated process which cluster can execute, and all that particular thing is done by the Kube control manager or Kube controller. So that are the components for the Kubernetes master. Now let's discuss about the worker node. Worker node is a physical machine, or you can say that is a VM, where the application or the containers are actually executing, and these applications and the containers are being managed by the master node. Worker node contain the necessary service to manage the networking between the containers, the communication with the master node, and assign resources to the scheduled containers. So ideally, the worker node can have all the capability to manage the containers and manage the resources, the communication, networking between the containers. On each slave node or on each worker node, you will get a utility called kubelet. Kubelet is a Kubernetes agent that execute on the worker nodes. That agent will directly communicate with the Kube API server on the master node, and that will manage the state of your worker nodes. The execution of pods or execution of the services on the worker node is responsibility of the kubelet. Kubelet will get the instructions from the Kube API server that what is the service, what is the configuration of that service, and where it should need to execute on the worker node. Now we heard a new term which is called pods, right? What are the pods? Pods is basically a group of one or more container. Within the pod, within a single pod, which is a logical unit in Kubernetes, you can have the single container or the multiple containers. But all the containers which are running within a single pod, they must have the similar kind of configuration. You cannot execute cross configuration containers within a single pod. If you have the cross configuration containers, then you need to define the separate pods for these cross configuration containers. But in layman term, the pod is a logical unit where you can have the single container or multiple container with the similar configuration, which will share the storage, which will share the network, Another thing is that the containers within the pod can share the shared content and the same IP. It means IP is not associated with the containers. Within the Docker Swarm, IP is associated with the containers, but in Kubernetes, IP is associated with the pod, not with the containers. And the containers, which are a part of a single pod, they can communicate to each other via localhost. Single pod can run on the multiple machines, so you can execute a single pod on a multiple worker nodes, and a single machine can also execute the multiple pods. Generally, whenever you are going to execute your application in Kubernetes, the 90 to 95% structure will follow a single container in a single pod. There is another component which present on the worker node, which is called the kube proxy. So on worker node, we have the pods, we have the services, we have the kubelet, and we have the kube proxy. Kube proxy is a proxy which will deal with the individual host subnetting, right? And ensure that the service is available to the external parties. So whenever we are executing the container on the worker node, what is that container? That container is an instance of my application. And why I am executing my application? So that the end user can access that application and do their work. So proxy is a component which will provide the connectivity between the containers and the external world. So that is about the architecture of the Kubernetes. We have the master, we have the workers. Master have their own elements, own components, and worker have their own elements and own components. So in case if you have any doubt, you can ask your question. Thank you, team. See you in the coming lecture. So in previous lecture, we have created this machine, and now we will see how can we install the Minikube Kubernetes cluster. So the installation process have the definite steps, and let me share these steps. So to work with the Kubernetes Minikube, first we need to install the Docker CE edition, right? It means first we need to install the Docker Community Edition on this machine. After that, we need to install the kubectl. Kubectl or kubectl is an utility by which you can execute the Kubernetes command within the Minikube. Also, kubectl can be used to execute the Kubernetes command within the Kubernetes HA deployment. So kubectl or kubectl utility will be same, that will be used in both kind of clusters, either that is a Minikube Kubernetes cluster or that is a Kubernetes HA deployment. After that, we will install the Minikube and we will start the Minikube Kubernetes cluster. So these are the three things which we need to do. And here in this document, I have mentioned the complete steps. What I will do, I will attach this document as a file or as a resource within this lecture so that you can download this document and you can follow the same command to install or set up the Minikube in your own machine. So first we need to uninstall the old version. This is required. So I will uninstall the Docker first if that is installed on your machine. Docker is not installed on my machine so that I'm getting unable to locate package Docker engine. We need to execute the second command to update the apt package index on my box. So we will execute this command and this will update the apt package manager on my machine. This may take few seconds, we have to wait, and it's done. We will clear out the console. And now we need to install these packages. First, we need to install the apt transport HTTPS. HTTPS will be required for the REST API management within the Kubernetes. Then we need to install the CA certificate. That is also required to set up the Minikube certificate. We also need to install the curl. We need to install the GNU and we need to install the LSB release. So I will copy this and provide it here. This will install all the packages which we have mentioned. It will ask for the confirmation. We will put Y and hit enter. So you can see it is downloading the packages. The apt transport HTTPS is being done and all packages installed. Now I will clear out the console. After this, we need to add the Docker's official GPG key. So this is the command to add the GPG key. I simply provide it. I simply paste this command over here and it's done. After this, we need to follow this particular command to get the stable release of the Docker CE version. LSB release CS, this will provide the stable release of the Docker version. So whatever the latest stable release, you will get that release on your machine. You need to copy this and provide on your terminal. hit enter, and that's it. After this, you can install the Docker engine by these two commands. First, we again need to update the package manager. So I will update the package manager. And after this, we need to execute sudo apt install docker ce cli and containerd.io. These are the three things which will be installed on your machine: docker ce version, docker ce cli version, and containerd.io. I will copy this, paste it here, and hit enter button. This will ask for the confirmation. I will provide yes. This will download all the required things and it will install the all three things on my machine. And installation is finished. Now what I will do, I will clear out the console and I will check my Docker version. So I will install Docker space hyphen hyphen version. We need to check that which Docker is installed on my machine. So Docker version 20.10.6 is installed on my machine. Once we install the Docker CE version, we will clear out the console and we will install the kubectl or kubectl. To install the kubectl or kubectl, we need to download the latest release of the kubectl. I will copy this and provide the command over here. And from here, we will get the latest release of the kubectl. You can see we are reading the stable.txt from this URL. If you want, you can hit this URL in your browser as well. So if I will hit this URL in my browser, we can see we are getting the version 1.21.1. So same, it will resolve over here and it will download the version 1.21.1. Now after this, to install the kubectl, you need to execute a command sudo install -o root -g root, and we need to provide the executable permission to this kubectl, and we will install this within the location user local bin kubectl. Put the command over here and it's done. Now we can verify the installed kubectl version and we can execute this command for that. Kubectl version --client. I will hit enter and you can see we are getting major version 1, minor version 21 and git version 1.21.1, the same version we have seen on the browser. So Docker CE kubectl is installed. Now what? We need to install the minikube. To install the minikube, we need to download the binary. I will copy this, provide it here. This will download the minikube Linux AMD 64 binary from this location. I will hit enter, right, and it's done. The total size is 46.5 megabyte. Once you will download the binary, similarly you can install sudo install minikube, define your binary name and the installation location, which is user local bin minikube. I will copy this, provide it here and hit enter key. This is done. Now we can verify the minikube version. So we will execute the minikube version command, hit enter, and minikube version 1.20.0 is installed on my machine. Now we have installed all the prerequisites. We have installed the Docker CE, we have installed the kubectl for Kubernetes commands, and we have installed the minikube as well, which is a Kubernetes cluster for a single node. Now we need to start the minikube cluster. It means we need to start the minikube Kubernetes cluster. For that, first we need to install the contract, right? That is a package which is also required with the minikube. I will install it and we have to wait until it will done. Once it will done, you need to clear out your console and you need to execute a command sudo minikube start --vm -driver equals to none. I will copy this, paste it here and hit enter. So over here you can see we are getting the complete information. It is starting the control plane node minikube in the cluster minikube, running on localhost this. This is the OS release. This is the Kubernetes version which we are using, Kubernetes 1.20.2, and Docker version is Docker 20.10.6. Over here we are getting the other information regarding the kubelet, kubeadm, kubectl and kubectl. It is generating the certificate keys. Now it is starting the control plane. Control plane means the component which we have learned in the control plane, which was kube API server, kube control manager, etcd key value pair and scheduler. See, we are getting the other information. It is saying done. Kubectl is now configured to use minikube cluster and default namespace by the default. So the namespace which this particular cluster is using, that is a default, and the cluster name is Minikube. The Kubernetes cluster which is started on this box is a Minikube Kubernetes cluster, and the namespace what it is using is a default namespace. We will learn about the namespace shortly. Right now we are just explaining the terms which are coming in our way. After this, you will clear out the console, and if you want to verify your cluster status, you can execute this command kubectl config view. So we will enter kubectl or kubectl config view and see we are getting the complete information. The API version is v1. Here is the cluster detail. The cluster authority is root minikube ca.cert, which are the certificate got generated. The latest updated cluster updated on May 27, 2021. This is the Kubernetes version which I am using 1.21.0. This is the latest Kubernetes version as of date. Within the extension, we are getting the provider, version, name, namespace which is default, and user. Minikube is the user, right? This is the username and current context is the Minikube. Now let's clear out the console, and in the coming lecture we will see some commands and we will interact the Kubernetes cluster on this machine. So thank you team. See you in the coming lecture. So in previous lecture we have created this machine, and now we will see how can we install the Minikube Kubernetes cluster. So the installation process have the definite steps, and let me share these steps. So to work with the Kubernetes Minikube, first we need to install the Docker CE edition. Right? It means first we need to install the Docker Community Edition on this machine. After that, we need to install the kubectl. Kubectl or kubectl is an utility by which you can execute the Kubernetes command within the Minikube. Also, kubectl can be used to execute the Kubernetes command within the Kubernetes HA deployment. So kubectl or kubectl utility will be same, that will be used in both kind of clusters, either that is a Minikube Kubernetes cluster or that is a Kubernetes HA deployment. After that, we will install the Minikube and we will start the Minikube Kubernetes cluster. So these are the three things which we need to do. And here in this document, I have mentioned the complete steps. What I will do, I will attach this document as a file or as a resource within this lecture so that you can download this document and you can follow the same command to install or set up the Minikube in your own machine. So first we need to uninstall the old version. This is required. So I will uninstall the Docker first if that is installed on your machine. Docker is not installed on my machine, so that I'm getting unable to locate package Docker engine. We need to execute the second command to update the apt package index on my box. So we will execute this command and this will update the apt package manager on my machine. This may take few seconds, we have to wait, and it's done. We will clear out the console. And now we need to install these packages. First, we need to install the apt transport HTTPS. HTTPS will be required for the REST API management within the Kubernetes. Then we need to install the CA certificate. That is also required to set up the Minikube certificate. We also need to install the curl. We need to install the GNU, and we need to install the LSB release. So I will copy this and provide it here. This will install all the packages which we have mentioned. It will ask for the confirmation. We will put Y and hit enter. So you can see it is downloading the packages. The apt transport HTTPS is being done and all packages installed. Now I will clear out the console. After this, we need to add the Docker's official GPG key. So this is the command to add the GPG key. I simply provide it. I simply paste this command over here and it's done. After this, we need to follow this particular command to get the stable release of the Docker CE version. LSB release CS, this will provide the stable release of the Docker version. So whatever the latest stable release, you will get that release on your machine. You need to copy this and provide on your terminal. Hit enter and that's it. After this, you can install the Docker engine by these two commands. First, we again need to update the package manager. So I will update the package manager. And after this, we need to execute sudo apt install docker ce cli and containerd.io. These are the three things which will be installed on your machine: Docker CE version, Docker CE CLI version, and containerd.io. I will copy this paste it here and hit enter button. This will ask for the confirmation. I will provide yes. This will download all the required things and it will install the all three things on my machine. And installation is finished. Now what I will do, I will clear out the console and I will check my Docker version. So I will install Docker space hyphen hyphen version. We need to check that which Docker is installed on my machine. So Docker version 20.10.6 is installed on my machine. Once we install the Docker CE version, we will clear out the console and we will install the kubectl or kubectl. To install the kubectl or kubectl, we need to download the latest release of the kubectl. I will copy this and provide the command over here. And from here, we will get the latest release of the kubectl. You can see we are reading the stable.txt from this URL. If you want, you can hit this URL in your browser as well. So if I will hit this URL in my browser, we can see we are getting the version 1.21.1. So same, it will resolve over here and it will download the version 1.21.1. Now after this, to install the kubectl, you need to execute a command sudo install -o root -g root, and we need to provide the executable permission to this kubectl, and we will install this within the location user local bin kubectl. Put the command over here and it's done. Now we can verify the installed kubectl version and we can execute this command for that. Kubectl version --client. I will hit enter and you can see we are getting major version 1, minor version 21 and git version 1.21.1, the same version we have seen on the browser. So Docker CE kubectl is installed. Now what? We need to install the minikube. To install the minikube, we need to download the binary. I will copy this, provide it here. This will download the minikube Linux AMD 64 binary from this location. I will hit enter, right, and it's done. The total size is 46.5 megabyte. Once you will download the binary, similarly you can install sudo install minikube, define your binary name and the installation location, which is user local bin minikube. I will copy this, provide it here and hit enter key. This is done. Now we can verify the minikube version. So we will execute the minikube version command, hit enter, and minikube version 1.20.0 is installed on my machine. Now we have installed all the prerequisites. We have installed the Docker CE, we have installed the kubectl for Kubernetes commands, and we have installed the minikube as well, which is a Kubernetes cluster for a single node. Now we need to start the minikube cluster. It means we need to start the minikube Kubernetes cluster. For that, first we need to install the contract, right? That is a package which is also required with the minikube. I will install it and we have to wait until it will done. Once it will done, you need to clear out your console and you need to execute a command sudo minikube start --vm--driver equals to none. I will copy this, paste it here and hit enter. So over here you can see we are getting the complete information. It is starting the control plane node minikube in the cluster minikube, running on localhost this. This is the OS release. This is the Kubernetes version which we are using, Kubernetes 1.20.2, and Docker version is Docker 20.10.6. Over here we are getting the other information regarding the kubelet, kubeadm, kubectl and kubectl. It is generating the certificate keys. Now it is starting the control plane. Control plane means the component which we have learned in the control plane, which was kube API server, kube control manager, etcd key value pair and scheduler. See, we are getting the other information. It is saying done. Kubectl is now configured to use minikube cluster and default namespace by the default. So the namespace which this particular cluster is using, that is a default, and the cluster name is minikube. The Kubernetes cluster which is started on this box is a minikube Kubernetes cluster, and the namespace what it is using is a default namespace. We will learn about the namespace shortly. Right now we are just explaining the terms which are coming in our way. After this, you will clear out the console, and if you want to verify your cluster status, you can execute this command kubectl config view. So we will enter kubectl or kubectl config view and see, we are getting the complete information. The API version is v1. Here is the cluster detail. The cluster authority is root minikube ca.cert, which are the certificate got generated. The latest updated cluster updated on May 27, 2021. This is the Kubernetes version which I'm using 1.21.0. This is the latest Kubernetes version as of date. Within the extension, we are getting the provider, version, name, namespace, which is default, and user. Minikube is the user, right? This is the username, and current context is the Minikube. Now let's clear out the console, and in the coming lecture, we will see some commands and we will interact the Kubernetes cluster on this machine. So thank you, team. See you in the coming lecture. Hello and welcome back. Today we will learn the interaction with Kubernetes. We will see how we can interact with Kubernetes cluster and how we can execute the things in Kubernetes cluster. So we will open the terminal and we will log in the machine where we have executed the Kubernetes. Before starting with the Kubernetes, first we need to check the status of my Kubernetes cluster. So we will execute a command kubectl config view. Hit enter and see my cluster is running. Once we will verify the cluster status, we will start interacting with the cluster. But before this, you can see everything we are getting on this terminal that is in the black and white. So if you want some more color on your terminal, you can install a utility. You can execute sudo apt install fish. So this is a Python based utility which will provide a very interactive terminal. It's completely optional. If you want, you can install this utility. Otherwise, you can skip this command. To use the fish, we need to execute a command fish and see. We are now in the fish terminal and we are getting more interactive terminal over here. Let's clear out this and now we will see how we can interact with the Kubernetes cluster. So here we have documented few commands and with the use of these commands we can create few things on the Kubernetes. So first what we will do, we will use the kubectl to create a deployment in the Kubernetes. As I told you that all the things or all the interaction with the Kubernetes cluster will be done with the kubectl utility. So first we will do a deployment. That deployment will have the pods, right? We have discussed about the pod which is a logical entity and which can have the containers. We are not aware with the deployment. In coming lessons, we will also learn about the deployment. But right now we are just learning how we can interact with the Kubernetes cluster. So we will start a deployment with the help of a kubectl. So we will copy this command and provide it here. This command is used to create the deployment. Then we are providing the deployment name. My deployment name will be hello-node, and then we are providing the image name which is going to be deployed within a container. So my image is a eco server 1.4 that will be downloaded from kats.gcr.io repository. Hit enter button. It is saying deployment.apps hello node is created. Now if you want to see that deployment is created or not, you can execute a command kubectl get deployment and see we are getting a deployment name hello node. This is a ready state. First one define that how many containers are in the running state and second one define that how many containers are there. Up to date is 1, available is 1 and total age is 26 seconds. If I will execute this again, we can see the total age is increased. If you want to see that how many pods are running within your deployment, you can execute the same command kubectl get and instead of the deployment you can mention the pods. Hit enter and total 1 pods are running within my deployment and my pod name is this. You can see the prefix is my deployment name, then it have the random number. This is the same terminology. Status of my pod is running. Right here in layman term you can say that this pod is basically a container. Although it is a wrapper unit over the container, but right now you can assume this pod is a container. Now suppose you want to expose this deployment hello node or you want to expose this port hello node then some numeric number to the external world. External world means we can access that particular service or we can access the service which is running within this port from a internet. For that you need to create a service in Kubernetes. So please make sure whenever you want to open the connection of your application, of your pod, of your instance with the external world, you need to create the service within the Kubernetes. Service is something which will create the access point, the proxy point for your application. And using that access point, external user can access your service within the Kubernetes cluster. To create the service, you need to execute a command like this: kubectl expose deployment. Then you need to define your deployment name. Then you need to define type equal to load balancer. Basically, this is the service type. Whenever you want to open the connection with the external world, you need to define the type load balancer. And here you need to define the port, then on which particular port your service will listen. My service will listen on port 8080. It is saying service hello node exposed. If you want to check your service, you can execute the command kubectl get services. We can see two services are running. First is the hello node which we just created. The type is a load balancer. The cluster IP is 10.108.197.170. This is the private IP of this particular service. This service is accessible on port 8080 internally, and for the external world, this service will be accessible on a port 32734. And there is another service, Kubernetes service, which is a Kubernetes cluster itself. Now suppose we will clear out the console and we want to access my own service which we created. For this you can execute a command like minikube service and provide your service name. And here I am getting my service detail that the namespace of my service is default. This is the name of my service. The target port of my service is 8080. Please make sure 8080 is a port on which your service will listen internally, where your port will listen. And the URL which is exposed to the external world is this, which is the public IP of your machine, then a port. And please make sure whenever you are defining a load balancer type of service, you will get a port of 5 digit. And over here it is saying opening service default hello space node and default browser, and here is the access point. I will copy this, go to my browser, and within my browser I can copy this URL and hit enter. See, I'm able to access my service. You can see this is the client address is this. This is an Nginx server with Lua module. So we are able to access this service which are running within my Kubernetes cluster. You can delete this service, and to delete the service you can execute a command kubectl delete service and provide your service name. Hit enter. Service is deleted. Let's verify the service status again. So only one service is running. And if you want to verify my service status with minikube service hello node, and we can see that there is no service found with the hello node. If you want to delete your deployment as well, you can execute a command kubectl delete deployment and provide your deployment name. So we will provide kubectl delete deployment hello node, hit enter, and your deployment will also get deleted. If you want to verify, you can execute kubectl, hit enter, and we can see we are getting no resource found on the default namespace. It means no deployments are running within my Kubernetes cluster. So this is the first lecture, the first lab we have done on the Kubernetes. We have seen how we can start the application within the pods and deployment, and how we can expose that particular application to the external world. Right? So although there are a lot of things which was new for you, in the coming lecture we will discuss the services, deployments, pod in quite details. But this is the first interaction with the Kubernetes cluster. Thank you team. See you in the coming lecture. Hello team and welcome back. In this lecture, we will learn about the Kubernetes cluster namespaces. So before going deep in Kubernetes, we will understand the basic terminology. And understanding of namespace is very important in Kubernetes cluster. So namespace are basically virtual cluster on your Kubernetes cluster. Within a single Kubernetes cluster, you can divide your cluster in multiple virtual clusters. And in these virtual clusters, you can create these virtual cluster specific resources. So in Kubernetes, you can create the Kubernetes objects such as pods, containers, services, which will live in the namespace, and they will be limited to the namespace. So you can understand the namespace is like a workspace, and you can create a multiple namespace or workspace within a Kubernetes cluster. Ideally, the basic function of namespace is to separate and organize the object in Kubernetes cluster. Let's take an example. Your production is on Kubernetes, and as per your organization policy, you can have up to 10 clients on a single cluster. And for each client, you will create the different service structure. So in that case, for each customer, you can define the different namespace on a single Kubernetes cluster, and all the services which are executing for that customer, or the containers, ports which are executing for that specific for that specific customer, they will execute within that customer namespace. In that case, the resources specific to a customer will be bind within a logical unit. If you want to list out the existing namespace on your cluster, you can execute kubectl or kubectl command to get the namespace which are present on your cluster. The command which you need to execute is kubectl get namespaces. This command will return the all existing namespace on your cluster, and it doesn't matter that namespace is blank or some services are executing in that namespace. If you are not defining the namespace whenever you are creating the resource, then by default each cluster have the default namespace. And if user is not specifying the namespace explicitly, then cluster will take the default namespace and resource will be assigned to the default namespace. If you want to create some resource within a specific namespace, you can do that thing with the kubectl or kubectl command. Kubectl command is common for minikube cluster and the HA deployment cluster. So anywhere you are working on Kubernetes cluster, kubectl command can be used to execute anything within your cluster. And if you want to specify a specific namespace to the resources, we can specify like this. Suppose if we want to get the number of pods, what are the pods which are running in a specific namespace, we can execute command kubectl get pods, define hyphen hyphen namespace and your namespace name. This will return all the pods which are running in a specific namespace which you are defining in a command. You need to note that thing, if you are not defining any namespace explicitly, in that case command will return all the resources which are present within a default namespace. So namespace is a very good feature in Kubernetes cluster. Although you have a single cluster, but you can group your resources. You can define the namespace for the services as well. You can define all proxy containers will execute in proxy namespace, all the load balancer will execute in the load balancer namespace, all the web server will execute in the web server namespace. Use So you can use the namespace as a logical unit, as a logical bind, and you can define your own criteria for the namespace. If you want to create a namespace, then again we need to use the kubectl command, and the command which you need to execute is kubectl create namespace and define your namespace name. Let's open the Kubernetes cluster and demonstrate all the things we have discussed on namespace. And here we are within the machine. To list out all the namespace, we will execute command kubectl get namespaces. In my cluster, we have these four namespace. Default namespace, which is default in each cluster, kube node lease, kube public, and kube system. Now suppose you want to get the number of pods running in your system. So we will execute kubectl get pods, and it is saying no resource found in default namespace. Sometimes these statements are confusing because you know very well that you have executed the resources, but you are not getting the resources. In that case, if you are not getting the resources, and in that case you need to specify the specific namespace from which namespace you want to get the resource. So suppose we want to get the resource from the kube system namespace. We will execute command kubectl get pods, define hyphen hyphen namespace, and define your namespace name. Hit enter. Now you can see that these are the pods which are running within your kube system namespace. But whenever we are not defining the namespace, we were just executing the kubectl get pods, we was not getting any resources. Because if you are not explicitly defining the namespace, system will take the default namespace. But if you want to get the resources which are present within a specific namespace, then you need to define the namespace for which you want to get the resources. In case you want to get the resources of all the namespace, you can execute command kubectl get pods, then define hyphen hyphen all hyphen namespaces. Hit enter, and you will get the resources from all the namespaces. Here you will get the namespace name, the resource name, and the other information regarding the resources. Right now we just have the resources within the kube system, so that we are getting this. Let's clear out the console and create a namespace. For creation of the namespace, we will execute a command kubectl create namespace and define your namespace name. Suppose we are creating a namespace called level up 360. We are getting a success message namespace level up 360 created. If I will list out the namespace kubectl namespaces, you will get a new namespace created 18 seconds ago. So this is the way how you can deal with a namespace. Please make sure whenever you want to logically bind your unit, you want to keep your all the unit within a specific logical bind, or you can say within a specific, or you can say within a specific unit, you can use the namespace. And namespace is very essential in Kubernetes. Thank you team. See you in the coming lecture. Hello and welcome to this section where we will be discussing about Kubernetes management. This lesson is all about the overview of this section. And in Kubernetes management, first we will understand the Kubernetes high availability. We will understand what are the components which are required for high availability of Kubernetes. We will move to the Kubernetes management tools. We will also learn about Kubernetes management tools and what are the rule of these management tools. Shortly, we will set up the Kubernetes HA cluster, which will have single master and two worker nodes. From the cluster maintenance point, we will see that within the maintenance time, how we can drain the resources from Kubernetes cluster and how we can add up the resources in Kubernetes cluster. We will also learn about the upgrading of my Kubernetes cluster. What could be the approach we can take to upgrade the Kubernetes cluster without impacting the availability of the services. We will learn about backing up and restoring the etcd cluster, which is a database for Kubernetes cluster. This is an overview what we are going to cover in this section. Let's get started with Kubernetes high availability. Hello, and in this lesson, we will discuss the high availability of Kubernetes cluster. We will discuss about the what is high availability mean in Kubernetes cluster. We will also learn about the multiple HA control plane and how we will manage the etcd database for Kubernetes cluster. So first, let's discuss about what is high availability mean in a Kubernetes cluster. Here we need to understand the basic context of high availability in regard of Kubernetes cluster. Kubernetes is designed to facilitate the high availability in application. But whenever we are talking about the infrastructure high availability, we are talking about Kubernetes cluster high availability itself. Although Kubernetes as a tool is providing the execution environment for application. And as an environment, Kubernetes is providing the high availability to the application. But application will only be available if my cluster is available. What happens if your cluster will itself go down? In that case, the application availability will also be impacted. So application availability is another aspect and cluster availability is another aspect. Here we are talking about the high availability of Kubernetes cluster, and this can be achieved by the infra level. So infra high availability is very necessary for a production environments. And whenever I'm talking about infra, I mean the infrastructure on which the application is executing. In Kubernetes, we can achieve the high availability by supporting the multiple control plane. It means in production Kubernetes environment, we must have the multi-master and multi-worker node topology, where we are not just relying on a single Kubernetes master node, we are executing multiple Kubernetes master nodes. So as we mentioned that to facilitate the cluster high availability, we need multiple control planes. It means we need the multiple master node. And how that multiple master node model will look like. This is a single control plane and this is the another control plane. The both of my control plane will have their own kube API server and the other supported components. And they both are running on different nodes. So how we can achieve the communication between these kind of model? We need to be make sure that both of my nodes should get the traffic. So in that case, user will need a load balancer, and with the help of that particular load balancer, we can communicate to the Kubernetes cluster. So in that case, we have a load balancer and user will submit the request to that particular load balancer, and load balancer will further communicate to the multi-master node kube API server. In that case, my load balancer should be intelligent enough and it should identify that on which particular master node the request need to be sent. In that case, if due to any reasons, if one master node is going down, then another master node is live to serve the request. And that is called the high availability production like Kubernetes deployment. Here the worker node kubelet APIs will also communicate to the load balancer. It is not like that only the end user will communicate to the load balancer. All the traffic which is running on a worker node by a kubelet agent, that also need to be communicated with the master node via load balancer. So here load balancer is the middleware which is between the master node and the worker nodes. User is also submitting the request to the load balancer, and then load balancer is submitting the request to the master nodes, and all the communication between the master and worker node is also going through the load balancer. Now let's talk about the etcd management. As we earlier discussed that etcd or etcd is an key value pair database for Kubernetes cluster. So we need to make sure that how we are managing the etcd. So here multiple organizations are following multiple kind of models, but we will discuss about the two popular model, and first one is the stacked etcd. Whenever we are talking about the stacked etcd, in that case we can assume that we have the two master nodes. We have the two master node control plane 1, and we have the another master node control plane n, or you can have the n number of master nodes. Each master node will have their own kube API server and the other components like scheduler, controller, right? In the stacked etcd, the master node will also have the etcd database on the node itself. That is called the stacked etcd, where each master node have their own etcd database which is present on the master node itself, and these etcd will be communicated with each other so that they will be in the sync. That is called the stacked etcd. So what is the approach here? Approach is, although we have the n number of master nodes, but all the component which are related to a specific master node, they are present on that master node only, and etcd are getting synced with each other to share the resources data. This is called the stacked etcd. You can note this kube adm installation is follow the stacked etcd model. The another model is external etcd. In that case, we remove the etcd from the master node control plane, and control plane of each master node will only have the kube API server and the other components. And we will set up the another node or another cluster to keep the etcd database. And these etcd will communicate to each other. But right here, the difference is that this etcd component is not a part of the master node. That is basically maintained on a separate server. You can have a single server which will have the etcd of multiple master nodes, or you can create a separate server for each master node, and that server will only have the etcd which is configured, which are attached to a particular master node. This is called the external etcd. Both of the approaches have their own advantage and disadvantage, but most popular approach is a stacked etcd. So thank you team. This is an introduction of the high availability Kubernetes cluster. Hello, and in this lesson we will discuss management tools of Kubernetes. Whenever we are learning about Kubernetes management, this is very important to learn about the tools by which we can manage the Kubernetes cluster. The knowledge of Kubernetes management tool is very necessary because it will make your work very easy whenever you will start working on Kubernetes. And here we will discuss few tools in short. We will discuss about the kubectl, then we will move to the kubeadm. We will see how kubeadm is helpful in installation. We will also learn about the minikube and the purpose of minikube. We will try to understand the purpose of Helm and how Helm is helpful in Kubernetes. There is another tool called Compose. We will learn about the purpose of Compose and Customize. That is the another tool which will help in Kubernetes management. So let's start with the kubectl. So as we are already aware, Kubernetes is an open source. This have a multiple benefits because with open source tool you may have the multiple tools without any license. So we have the multiple tools associated with Kubernetes which provide the additional functionality in Kubernetes. However, if you are a Kubernetes administrator or you are a Kubernetes developer, it is very necessary to have the knowledge of Kubernetes tool, because with the help of Kubernetes tool you can work on Kubernetes cluster very easily. Otherwise, you need to implement the things from scratch, and that is quite challenging. So first we will discuss about the kubectl. We have already seen kubectl in last section. where we have executed few kubectl command. Kubectl is basically an official CLI, which means command line tool for the Kubernetes cluster. Whenever you are deploying the Kubernetes cluster, either that is for the development or either that is a HA deployment, kubectl is command line interface which you can use to interact or communicate with the Kubernetes cluster. What is the another interface by which you can communicate to the Kubernetes cluster? That is the REST API. REST API is the another interface by which you can communicate with the Kubernetes cluster. But if you are on a Kubernetes terminal and you want to communicate with your Kubernetes cluster, then you need to execute the commands with the help of kubectl utility. Kubectl is a utility which you will see throughout this course, because whenever we will try to execute something on a Kubernetes cluster, we will execute the command with the kubectl. The another component is a kubeadm. Kubeadm is used to build or creating the Kubernetes cluster. Kubeadm is a tool by which you can easily install the Kubernetes on your box and you can easily configure the Kubernetes cluster on your machine. Kubeadm provides a very simple interface, very simple commands by which you can execute, by which you can set up and execute your Kubernetes cluster. Then we have the Minikube. We have already learned about the Minikube in previous section and we have executed the Minikube. We have executed the Kubernetes cluster within a Minikube. Minikube is a developer's tool and Minikube have the advantage that it will set up the master and worker node in a single machine. So with the help of Minikube, you can set up the development environment very quickly, right? And you don't need the multi-node configuration. You don't need the multi-node setup. You can set up the complete Kubernetes cluster on a single node. It means you can also set up the Kubernetes on your local machine. If you are using a Linux box as a local, you can easily set up the Kubernetes on your local machine with the help of Minikube. Another component is a Helm. Helm is a very powerful tool and Helm will help us to create the template and package management for the Kubernetes. So with the help of Helm, what you can do, you can create the multiple object in Kubernetes and you can create a template of these object so that you can use that template multiple times to spin up a new objects on different Kubernetes cluster. Helm have the ability to convert the Kubernetes objects into a reusable template, which is a very good thing. Whenever you want to execute the similar kind of template across the environments, that is a prod testing, dev and production, so you can use the Helm to deploy these templates on the different Kubernetes environments. Helm also provide the ability to configure the complex template. It means where Kubernetes cluster have the interdependency. It means where Kubernetes objects have the interdependency. Interdependency means whenever the Kubernetes object like the deployment ports and services, they have the cross dependency, you can create the complex charts, you can create the complex templates of these objects with the help of the Helm. And after the Kubernetes hardware, after the Kubernetes labs, we will create 5 to 6 hours separate lectures on the Helm and we will see how Helm can work with the Kubernetes. Then we have the another tool called Compose, and that word is basically sounds similar to the Docker Compose, and that is the purpose of the Compose. Compose help to translate the Docker Compose file into the Kubernetes objects. So in your pipeline workflow, wherever you are using the Docker Compose and you want to ship that particular workflow in the Kubernetes, then you can easily do that thing with the help of the Compose. Compose is a tool which will translate the Docker Compose files into the Kubernetes cluster object. The Compose tool have the ability to ship the containers from Docker Compose to the Kubernetes cluster. Then in last, we will discuss about the Customize. Customize is used to manage the configuration of your Kubernetes cluster. That is somewhere similar to the Helm, but it have few things which are missing in the Helm, or you can say they are slightly different. But the main purpose of Customize and Helm is to manage the configuration of the Kubernetes cluster, because Customize is also provide the reusable template similar to Hemp, which will help us to create the objects in Kubernetes cluster. So these are the tools, and the knowledge of these tools are necessary whenever you are working with Kubernetes. So this is an overview, and very soon we will learn about these tools in details. Thank you. In coming lesson we will see how we can set up a Kubernetes HA cluster. Hello team, and today we will see how we can set up Kubernetes high availability cluster. We will set up a Kubernetes high availability cluster which will have 3 node deployment. We will have the one master node and 2 worker nodes. This installation we will done with the help of a kubeadm tool which we discussed in earlier lecture. And once the installation will done, we will verify the cluster status. So as I told that this will have the 3 machines. So before starting with the cluster setup, we need to create the 3 VMs on our cloud. So I am on my DigitalOcean account, and this is a machine which I created earlier on which the Minikube cluster is running. I will create 3 more machines to set up the HA deployment cluster. So I will go to the droplet and create 3 machines. We'll keep up the details similar to the earlier machine and choose the machine which will have at least 2 GB RAM and 2 core CPU. Here, whenever I'm getting one droplet, I will increase up to 3 and provide the machine name. So I am creating 3 machines, and the machine name will be K8 master, K8 worker 1, K8 worker 2. I will create the droplet, and I'm skipping this video until all of the machines will be ready. As we can see, our all 3 machines is ready. We'll copy the IP of my master, and first we will set up the Kubernetes on master node. So I am on my terminal. I will SSH my node. You can see I'm in my Kubernetes master node. We will clear out the console, and for the installation by kubeadm, we have created a handy document and mentioned all the commands which is required for the installation. Here is the document. First we will upgrade the package manager, and then we will install the Docker engine. So first we will execute this command, paste on my terminal. This will update the packages on my machine. After this, we will install the Docker engine. So we'll execute a command sudo apt-get install -y docker.io. Docker installation may take some time, and it is done. We will clear out the console. And after the Docker installation, what we will do, we will install few support packages. We are installing the apt transport HTTPS and curl package. We will copy this and install these packages. After this, we will retrieve the key for the Kubernetes repo and add that key in my key manager. For that, we will execute this command. This is done. And then what we will do, we will add the Kubernetes repo in my system. So I will copy this command and execute that particular command. This is done. Clear out the console. Now what we will do, we will install these 3 pieces. We will install the kubelet, kubeadm and kubectl. But before installation, we will update the package again. And after the package update, we will execute this command to install all 3 packages, kubelet, kubeadm and kubectl. Paste it and hit enter. This will install all 3 packages, and it's done. Clear out the console. After this, we will execute a command sudo apt mark hold and provide all 3 packages. What this command will do, this command will basically hold the current installed version of these packages, and it will not update the package version on the next upgrade. So we will hold it. It is saying all the packages set on hold. Now after this, what I will do, I will create the actual Kubernetes cluster. So we will provide this kubeadm command. That's all. Right? Let's understand this command. It is saying kubeadm init. It means initialize the kubeadm, and we need to provide the pod network CIDR block. So here we are providing an IP range 192.168.0.0 with a CIDR range 16. So what does it mean? It means all the pods which is going to be created within this particular cluster, they will follow this IP range. You can provide any suitable IP range over here, and let's hit enter. This command may take some time because it will set up the Kubernetes cluster and initialize the Kubernetes cluster and start the Kubernetes cluster on your machine. But that's the only installation we need to do. You can see over here, we just need to execute this command kubeadm init and provide the pod IP range. That's it. This will install, set up the complete Kubernetes cluster or Kubernetes master on this machine. We have to wait until it will set up the master node on my machine, and we will get the success message on my console. And it's done. It is saying your Kubernetes control plane has initialized successfully. To start your cluster, you need to run following as a regular user. So what I will do, I will copy all these commands, right? And I need to execute these commands, all 3 commands. Hit enter and it's done. Then it is saying you should now deploy a port network to the cluster, right? And run kubectl apply -f, and we need to provide the network YAML to deploy the network for my cluster. We can get the different network at this particular location. If you want, you can copy this, open the browser and paste it here. Here we can see we have the different network, and it is also providing some description of this network, and we are going to use this network, which is Calico, right? If you want to learn about this network, you can learn about the you can go through this document. I already have the handy command, and to install the Calico network plugin, you need to execute this command, kubectl apply -f. Why kubectl? Because right here we have installed the Kubernetes successfully. Now we can use the kubectl, which is a command line interface for the Kubernetes cluster. So we'll execute kubectl -apply, and this will apply this particular YAML file. So I will copy this and paste it here. Hit enter. You can see this has created the network and created few resources as well. Before clear out your console, you need to make sure that you need to copy this particular command. And this command is, you can join any number of worker nodes by running the following command as a root. So this command will be required whenever we will create the worker node, right? And the worker node will join the cluster by using this particular command. I will copy this and keep it somewhere on my machine. So I will paste it here. Now you can clear out the console, and if you want to check the health of your cluster, you can execute kubectl get pods hyphen all hyphen namespaces. So these are the pods which are running on your machine. You can see that Calico Kube controller, Calico node, core DNS, right? etcd, Kube API server, Kube controller manager, Kube proxy, and Kube scheduler. These all are the components of your master control plane, right? This is the network, and this is for the DNS proxy. And you can see that all these things are the master. So basically, with the help of Kube ADM right here, you have created the master. If you want to check, you can execute a command kubectl get nodes, hit enter, and it is saying that name is k8 master, ready status is ready, and role is control plane master. So right here it has not created the worker node, it has created only the master node, and this is the Kubernetes version which you are using, which is 1.21.1. Now what is my job? Next job is we need to set up the worker nodes. Let's go to the document. And to set up the worker node, although I have documented the steps over here, but the steps will be same. You need to execute all the steps from 1 to 6, right, up to the installation, and you don't need to execute the kubeadm, right? So these steps needs to be executed on the worker nodes. So what I will do, I will ssh my another two nodes and execute these steps, and until I will execute this, I am pausing this particular video. So you can see I have executed the command till holding the version of all three packages. Kubelet set hold, kubeadm set hold, and kubectl get set hold on worker 2. Same you can see over here, right, on worker 1. Clear out the console. Clear out the console over here as well. This is the master. Clear out the console and execute the get nodes command again. Until that point, we only have the master node in the cluster. These are the worker nodes. I have set up the kubeadm on all these worker nodes. Now what I need to do, I need to execute that command which I copied from the master, which is this, right? Kubeadm join, it is providing the IP, then a port, then it is providing the token, and then it is providing the certification hash. I will copy this, put it here, and hit enter. Same, put it on the another worker node and hit enter. This will start the kubelet and kube proxy on your machine, right? And it is saying that this node has joined the cluster. Certificate signing request was sent to the API server. Kubelet was informed to the new secure connection, and run kubectl get nodes on the control plane to see node joined the cluster. Let's go to the worker node 2. The same message over here. Let's go to the master and execute the command again. It is saying this is a master, this is a worker, worker 2, state is ready. If you are not getting the state ready over here, it is saying not ready, please wait for a few seconds, at least 60 to 70 seconds, and the state will change automatically. Right here you can see this is the role control plane master, and these are the worker nodes, right? This node is up since past 12 minutes and this is recently joined the cluster. Execute this command again and see we are getting the same status. Now you may have some concern over here that we have copied this command, but in future I want to add few more worker nodes. So how do I get that particular command? Do I need to copy this command and save this as a particular place, or I can generate the join command again? The answer is you can generate the join command again. Let me show you a command which you can use to generate the join command again. So you can use this command kubeadm token create hyphen hyphen print hyphen join hyphen command. Hit enter. It will generate a new token. See, it is generating a new token. You can use this particular command kubeadm join. This is a token and this is the certificate hash. Please make sure this token and this certificate hash is a new one. This is not the earlier one. You can see if you will copy this, this is CSLR. Earlier this was something 11BE3. So this is another join command, but you can use this command to join a new worker node in this master node. If you want to list out all the tokens, you need to execute a command kubectl token list. So over here you can see there are two tokens. This is a token which was generated by default whenever we have initialized the kubeadm, and this is the token we generated recently. And in the description as well we are getting the default bootstrap token generated by the kubeadm init. So team, this is the way how we can set up the Kubernetes HA deployment where we will have the master and worker node configuration. We will keep this setup running for next few lectures because I need to show you some upgrade and downgrade scenarios on Kubernetes cluster. Thank you team. See you in the coming lecture. Thank you team. See you in next lecture. Hello team, and in this lesson we will learn about the maintenance window in Kubernetes cluster. Maintenance window means due to some reasons if we need to remove some nodes from my cluster and after the recovery we again need to add that node in a cluster, then how can we do such activity gracefully? So here we will discuss how can we remove a node from a cluster. And we are going to discuss about these concepts. We will discuss what is node draining and how we can drain a node from a Kubernetes cluster. What are the daemon sets and how we can ignore the daemon sets while we are draining the nodes. What are the uncordoning of a node in Kubernetes cluster? And then we will go with demonstration. So let's start with what is node draining. Whenever we are talking about node draining, we means we want to drain out a worker node from the Kubernetes cluster. We need to remove a node from a Kubernetes cluster, and there could be the multiple reasons to removing a node from a Kubernetes cluster. Sometimes we need the maintenance window, and in that maintenance window we need to apply some patches on the worker nodes, or we need to add something within a worker node, like we want to increase the capacity of my worker node, or I need to attach some additional disk with my worker node, I need to apply some security patch. So there could be the multiple reasons whenever you need a maintenance window on your running cluster. And in that maintenance window, what we will do, we will remove the faulty node from a cluster, apply the patch or fix that node, and again add that particular node in a cluster. That all process is called the node draining. And whenever we are performing the node draining, we need to be make sure that the application which is running in a Kubernetes cluster, that should not be impacted. It means there should be no downtime in the application which is running on the Kubernetes cluster. It doesn't matter that we are in the maintenance window or we are draining out the nodes. So draining a node in Kubernetes is a process, and whenever we are draining a node from Kubernetes, we need to make sure that the containers which are running on that particular node, they will be gracefully terminated and they will be rescheduled on the another available worker nodes. That is called the draining or node draining in Kubernetes. There are standard process to drain a node in Kubernetes. You can use the kubectl, or you can use the kubectl utility to drain node in Kubernetes. And there is a simple command kubectl drain, then you need to provide your node name. But whenever we are draining a node, we need to make sure that no daemon set is executing on that particular node. And if daemon set is executing in that particular node, then we need to pass ignore daemon set parameter with the drain command. What is the daemon set? Daemon set means there are the pods that are tightly coupled to that node. It means sometimes we have a requirement that I need to execute a particular process on all of my worker nodes. That could be the monitoring, that could be the health check, that could be the performance check. So these kind of pods which are running on each node in the Kubernetes cluster, they are called the daemon set. And in any case, if any daemon set is running on your Kubernetes cluster node, then you cannot drain the node easily. For that, you need to execute a command kubectl drain, provide your node name hyphen hyphen ignore hyphen daemon sets. Now once you drain the node, you put the fix on that node. And if that node is still a part of the cluster and you want to allow the pods on that particular node, you want to allow that master can schedule the additional resources or additional pod in that particular node, then you need to uncordon that particular node. And you can do that with the command kubectl uncordon, then provide your node name. Let's demonstrate all the things we have discussed about the node draining. So we will create a SSH connection with my master node. We have already set up a HA Kubernetes cluster in last lecture. So this is my master node IP. Here you can see I am on my Kubernetes master node. Let's get the number of nodes which are part of my cluster. We'll execute kubectl get nodes, and these are the nodes which are part of my cluster. Now let's execute a command kubectl get pods -o white. What this will display? This command will display all the pods which are running within my cluster. Also, it will display on which particular nodes the pods are running. Hit enter, and it is saying no resource found in the default namespace. It means nothing is executing in my default namespace. What we will do, we will execute few pods and deployments on this node. So we will create a directory mkdir node draining. Now we will go to this directory, put ll. So we don't have any file over here. Let's create some file over here, and I will call this file pods.yaml. Within this file, I will paste this content. And what is this content? So right now I'm not explaining much about it because this is the YAML file to create a pod, right? Once we will learn about the pod, I will explain each and everything in quite details. Right now I will just copy this and paste it here. Let's save your file. And to execute that particular YAML file, you need to execute command kubectl apply -f and define your file name, which is pods.yaml. So there is some error within my YAML. I need to correct that error. Now we have corrected the YAML file. I will execute this again, kubectl apply -f pods.yaml. And you can see the new pod got created, draining nodes test pod. This is the same name we have provided to my pod. See, draining node test pod. If you want to execute the get pods provide again, you can execute that command. And you can see one pod is running, and that pod is running on worker node 2. Now what I will do, I will create one more file and I will call it deployment.yaml. Here I will create the deployment content. Let's see what is the content we are going to push over here. So here I have created the deployment content. So this is the content. Here we are creating a deployment. The deployment name will be training node test deployment. This is going to create the two replicas, right? And again it is executing the nginx latest image. Team, again once I will execute the deployment, I will explain each and everything in detail. Also we need to explain few more concept about the deployment, but right now what you need to do, you just need to copy this file and paste within your terminal. So I will paste it here, save the file. Now again I will execute kubectl apply -f and define my deployment YAML file. Hit enter, and you can see the deployment got created. We have created a pod and we have created a deployment. This kind of setup is intentional. This kind of setup is intentional because I want to show you that how draining will treat, because I want to show you that how node draining will treat deployment and pods in a different manner. I will clear out the console and execute the get pods command again, kubectl get pods -o white. Now you can see my deployment pods are these two pods are my deployment pod, and this is a pod which I executed. The deployment pods are running on worker node 1 and worker node 2, and my pod is running on worker node 2. Now what we will do, we will drain out this node 2. So I will copy my node name and execute a command kubectl drain and provide your node name. Let's hit enter and we are getting an error. It is saying unable to drain the node, aborting command. What is the reason we are getting? We are getting two reasons over here. Cannot delete pods not managed by the replication controller, replica set, job, daemon set and stateful set. And it is talking about the pod which we created. It is saying that this pod which is running on this particular node, that is not connected with any of these objects. What are these objects? I will explain these things in the coming lectures. But right here it is saying that this is a pod and this is not connected with any of these objects. And what is the second error? Second error is about the daemon set. What is the daemon set? Daemon set is a process where pods are running on each node. Here we can see these two pods which are the part of same deployment and they are running on each node. First pod is running on worker node 1, another is running on worker node 2. This is a daemon set. So it is saying that daemon set that cannot delete the daemon set managed by the pod. And these are the daemon sets, right? Kube system Calico network is the another daemon set and kube proxy is another daemon set. These are also the pod which are running on worker node 2, right? So how we can drain out the node in this situation? We will execute the same command and plus this time I will provide this argument. Ignore daemon sets. Let's enter and we will get the error again. Yes. Why we are getting error this time? The second error is gone. But we are still getting the error for my first reason. It is showing the error for this pod, right, which we executing explicitly on this particular node. So does it mean we cannot drain this node? No. How we can do that? After this we will append hyphen hyphen force. Hit enter and see it is saying node 2 is already called on and it is evicting the pods. This is the pod which is got evicted. This is the another pod which is got evicted and these are the two pods again. Right here it is saying node k2 cluster worker evicted. Let's clear out the console and execute a command kubectl get nodes. Hit enter. See, we are getting that this is the master node status is ready. Worker node 1 status is ready. Worker node 2 which we just trained, it is saying ready, scheduling disabled. It means no new resource will be scheduled on this particular worker node. Let's execute the get pods command again and you can see the pod which we executed explicitly that is being removed, but the pods which was the part of my deployment that is rescheduled. This is the pod which was originally working on the node 1 and this is the another pod which newly created on the node 1. See, the age is just 64 seconds. So as I told you, once you will drain the node, the pods which are running on that particular node, they will terminate gracefully and rescheduled on the available worker node. So that is the case which happened over here. But the pod which we executed explicitly on that particular node, that is removed. So it will just manage the pod which are the part of replica set, replication controller, stateful set and the jobs. And each and every component which I just mentioned, I will explain each and every component in quite details in the coming lectures. Now suppose I want to rejoin that particular node which I removed from my cluster. So how we can do that? We will execute a command kubectl and we will mention uncordon and provide my node name which is this. Hit enter button and it is saying node to uncordon. Execute the get nodes command again and see this is ready, right? The node is again joined the cluster. Let's execute the command again which was getting the pod. And you can see there is no change in the state of the pods. So it means you can remove the nodes from a cluster, rejoin the node within a cluster, but it does not guarantee that the existing pods which has been rescheduled to the another node, they will again execute on the fixed node, right? The only way to move these pod from this particular node, you need to remove the first node this time and fix your problem and rejoin the first node. So this all process is called the node draining in Kubernetes, where we can easily drain the node from the Kubernetes cluster, fix the thing whatever we want to fix, either that is a reboot or any other thing, right? And then we can again join that particular node within the cluster. So thank you team. See you in the coming lecture. Hello and welcome back. In this lesson, we are going to discuss upgrading the Kubernetes cluster. We will see the upgrade process for control plane, which is master node and worker node. Here is a high level overview of this lecture. First, we will see how we can upgrade the Kubernetes cluster with kubeadm command. We will execute the master node upgrade and we will see what are the steps required for the master node upgrade. Then we will upgrade the worker nodes and we will see all the steps to upgrade the worker node. And in last, we will see hands-on demonstration upgrade the master node and worker node. First, we need to understand why upgrade is necessary in Kubernetes cluster. So Kubernetes is an open source tool and Kubernetes community is adding the functionality in cluster. They are improving the Kubernetes functionality and keep releasing the latest version of Kubernetes. So we can understand that Kubernetes cluster upgrade is a periodic task, and to keep your cluster in sync with latest Kubernetes release, you need to upgrade your cluster. We will see how we can upgrade the Kubernetes cluster with kubeadm, and believe me, the upgrade process with kubeadm is a very easy. Kubeadm utility will provide a very seamless Kubernetes cluster upgrade either on master node or control plane or on the worker nodes. First, we will understand how we can upgrade the master node and what are the master node upgrade process. So in the master node upgrade process, first we need to drain the control plane nodes. We have seen earlier in the maintenance lecture that how we can drain the nodes and what are the benefit of draining the nodes. Once we will drain the node, we will plan the upgrade. We will execute the kubeadm upgrade plan command and it will create the upgrade plan. Once we will create the upgrade plan, we will apply that plan with the help of kubeadm command. Once the kubeadm will be upgraded, we will upgrade the kubectl and kubelet on the control plane nodes. And after that, we will uncordon the node and join the node back to cluster. So this is the process of the master node upgrade. The worker node upgrade process is similar to this, but few steps are different. So here is the worker node process. So very first we need to drain the node, which is same. Then we need to upgrade the kubeadm. Here we don't need to execute the upgrade plan and upgrade apply. Once we will upgrade the kubeadm, we need to upgrade the utility like kubelet config, and after that we need to upgrade the kubectl and kubelet packages on my worker node, and then we will uncordon the nodes. So let's go and upgrade the Kubernetes cluster. So I have created the SSH connection with my Kubernetes master node. Team, for this lecture I have created a fresh Kubernetes cluster with the lower version so that I can show you the upgrade process of the Kubernetes. We also created a handy document which will help you to identify the commands which is required on the master node and worker node. So very first we need to get the running node version, and for that we will execute a command kubectl get nodes. So first let's execute kubectl get nodes. Here we can see this is my master node and these are the two worker nodes. The version on master node and worker node is version 1.20.1. The latest version of Kubernetes which is available in the market is 1.21.0. So as we discussed, we need to drain the master node. So we will execute this command and we will replace this stub with the master node name. We will execute kubectl drain create as master node, which is the name of my master node, hyphen ignore daemon set. Why I'm executing ignore daemon set? Because there is a lot of daemon pods which are running on my master node. Hit enter and you can see it is evicting the pods which are running on your master node. And here we need to wait until all the pods will be evicted. Right? We can see that all the pods are evicted. If you will execute the get nodes again, you can see that scheduling is disabled on this master node. Although this is not impacting your application, the application which is running on Kubernetes cluster, they are still functional, but the worker nodes are not able to communicate with the master node. In this particular state, while the scheduling is disabled on my master node, if any of the worker node will be corrupted, then Kubernetes master won't have the information about that worker node. Also, if you are going to schedule the new things or you are going to execute the new deployment or pod on the master node, then that will also not work. So what we need to do next? Next we need to upgrade the kubeadm package. So we will execute sudo apt-get update, and after that we will upgrade the kubeadm. This is the command which we are executing. So we are executing sudo apt-get install -y. What is this parameter? Allow change held packages. We are passing this parameter because whenever we install the kubeadm, kubelet and kubectl, we mark the version hold, right? So that we are passing this parameter. What is the latest kubeadm which I'm downloading? I'm downloading 1.21.1. Let's hit enter. Okay, it is not able to find. Let's define 1.21.1 hyphen 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 00. See, it is downloading the package. The kubeadm version 1.21.1 hyphen 00 is basically installed. You can check your kubeadm version on the master node and see the version is 1.21.1. It means my kubeadm is basically updated to this version 1.21.1. Clear out the console. After this, what I need to do, I need to execute the kubeadm upgrade plan, right? So I will execute this command sudo kubeadm upgrade plan version 1.21.1 hyphen 00. Hit enter. So you can see kubeadm is basically executing few things, and here it has mentioned that what is the current version and what is the upgraded version. You can see cluster version is 1.20.7 and the kubeadm version is 1.21.1. Here it is also defining that what are the components is going to be upgraded. Kube API server will be upgraded from this version to this. These are the components which are going to upgrade from these version to these version. Now it is saying you can apply the upgrade by executing the following command kubeadm upgrade apply, and I will execute this command. Now it will ask for the confirmation. Provide your confirmation, hit enter button. This will upgrade your Kubernetes master node. We have to wait until the upgrade process will be done. It will upgrade the Kubernetes master node, plus it will upgrade all the pods which are running on this master node. So we can see the upgrade process is in progress and upgrade is done. It is saying upgrade successful and your cluster was upgraded to version 2.1.1. Let's clear out the console and we will execute the further commands, which is sudo apt update. After that we will download the latest. After that we will update the kubelet and kubectl as well. So I will copy this and execute these commands. It will update my kubelet and kubectl packages. It's done. Clear out your console. Now we need to restart the kubelet. We also need to restart the daemon because it may possible that this latest update in the kubelet has updated something in the unit file. So I will restart the daemon, then I will restart the kubelet. After this, we will verify the nodes again. kubectl get nodes, and you can see your master is basically on the latest version. My master node is running on version 1.21.1 and my worker nodes are running on the version 1.20.1. What is next? My master node is still in the scheduling disabled state, so I need to uncordon my node. For this we will execute a command kubectl uncordon and provide your node name. And what is my node name? My node name is this. I will provide it here, hit enter. The execution is done. Get the kubectl get nodes again and see my control plane master is ready state and it is on the latest version. So at this particular point of time we have updated my master node. So we will get the cluster status again, and team over here we have the two worker node 1 and worker node 2. So whenever you are upgrading the worker node, so you need to make sure that you will upgrade the worker node in the rolling upgrade manner. It means we will upgrade only one node at a time. If we are upgrading all the worker nodes at the same time, it will impact your application in production and your application will face the downtime. So that we need to make sure that whenever we are upgrading the worker nodes, some of the worker nodes will be available to serve the traffic. Now we will see how we can upgrade the worker node. To upgrade the worker node, first we need to drain the worker node. So we will copy this command kubectl drain hyphen hyphen ignore daemon set hyphen hyphen force. And over here we need to provide the node name. Let's suppose we are going to execute the draining or upgrade for the second node. So we will provide it from here And also we are executing this command from the master. We are not executing the kubectl drain from the worker node. This command we are executing from the master node. Hit enter and it will evicting the pods which are running on the worker node 2. We have to wait until this process will be done. Now the process is done and a lot of pods are basically evicted from my worker node 2. Let's get the status again. Kubectl get nodes, and you can see on worker node 2 the scheduling is disabled. Now we will execute the other commands. After the drain, we will upgrade the kubeadm, and these commands we need to execute on my worker node because the package installation will be done locally on the worker node. So we will execute sudo apt-get update on worker node 2. The package update is done. After that, we need to update the kubeadm. We will copy this, execute this command. This is also done. As we are on the worker node, so we don't need to execute the plan and apply. What we need to do, we directly check the kubeadm version, which is on the latest version c1.21.1, and we will execute the command kubeadm upgrade node. That will update the kubectl configuration on that particular node, and it's done. After this, we will update the package again, right? And we will update the 1.21.1 version of the kubelet and kubectl on the worker node. Hit enter. This is done. Clear out the console. Now again we need to restart the daemon and the kubelet. So I will copy both of the command and execute them. Clear out the console. After this we will get the kubectl get nodes. So let's go to the master and execute the get nodes again. You can see the worker node is basically updated to the latest version 1.21.1. Now to join back the node into the cluster, we need to execute a command kubectl uncordon and provide my node name, which is worker node 2. Hit enter and get the status again. So you can see the node is ready and it is upgraded to the version 1.21.1. So this is the way how we can upgrade the Kubernetes cluster with the help of kubeadm. In the background, I will update that node as well. But now you are aware that how we can upgrade the Kubernetes cluster with the help of kubeadm, right? And in that upgrade process, we don't have any downtime. So thank you team. See you in the coming lecture. Hello team and welcome to this section. Earlier we discussed about the Kubernetes cluster management, and in this section we will learn about the Kubernetes object management. Till this section and in next few 2 to 3 section I will explain the building blocks of Kubernetes. Before, whenever we will start with the hardware of Kubernetes, whenever we will start with the complex application design and Kubernetes complex implementation, at that time the Kubernetes basics will be very much required. Because if we are not about the Kubernetes basics, then definitely there is no point to move on the advanced sections. So let's see how we can manage the objects in Kubernetes. And today we will start with the kubectl, which is a command line tool for Kubernetes cluster. Today in this lecture we will go with the Kubernetes command line tool, which is kubectl. We will understand the need of kubectl and what is kubectl, and then we will try a few commands on kubectl. We will understand the kubectl get command, kubectl describe, kubectl create, kubectl apply, kubectl delete, and in last we will discuss about the kubectl exec command. First, understand with the kubectl introduction. We have already discussed a bit about the kubectl in the Kubernetes management tool. Kubectl is a command line tool for the Kubernetes cluster. Whenever you are on Kubernetes cluster and if you want to execute anything on the Kubernetes cluster command line, kubectl will help you in that execution because kubectl is a command line utility for the Kubernetes cluster. Internally, kubectl uses the Kubernetes APIs and carry out the commands. So whenever you are hitting some kubectl command from the command line, kubectl basically internally hit the Kubernetes REST API and it will carry out the command via REST API and do the required work, and processing will be, and then command will process. First command we can discuss on kubectl get. Kubectl get command is used to get the object which are present on your Kubernetes cluster. In the Kubernetes cluster, you can have the multiple object. Shortly, we will see that how many objects do you have on the Kubernetes cluster. And if you want to get any information about that object in Kubernetes command prompt, you can get that information with the help of kubectl get command. Here is a sample of the kubectl get command, where you need to execute the kubectl get and you need to define the object type, that which object type you want to get. After the object type, you need to define the object name. That is one command, kubectl get object type and object name. If you will hit that particular command, that will work seamlessly and you will get the required information about that object. But if you want to get the object in a some output format, suppose you want to get the object information so that you can use that information in the further processing, then you need to execute the kubectl get command with the option -o output. Here in the output, you need to define the output type. By default, kubectl get command support two kind of output. First is JSON and second is YAML. And additionally, you can use the selector. Selector will basically work on the tagging basis. So whenever you are using the selector, you need to use the tag key and tag value. So as I told you, -o is set output format. You can get the output in YAML and JSON. Short by will basically short output using the JSON path expression. And with the help of the selector, you can filter out the result by label. The next command is kubectl describe command. Whenever you want a detailed information about any Kubernetes object, you can use the kubectl describe command. And the command is very simple: kubectl describe, define your object type and your object name. By this command, you will get all the detailed information about that object, and that detail will be specific to the Kubernetes cluster. If you want to create any object in Kubernetes by a command prompt, you need to use the kubectl create command. The command format is very simple. You need to execute the command kubectl create and then you need to define the file. That file will basically a YAML descriptor which will have the object information. The complete command will look like kubectl create -f, which is for the file symbol, and then you need to define your file name. Please make sure whenever we are defining the file, that file must be the YAML file, and we have the object information within that YAML file what we are going to create within the Kubernetes cluster. Then we have the kubectl apply. The kubectl create command and kubectl apply command, they both do the same kind of work. Both are the command to use the create the object within the Kubernetes cluster. But there's a difference between the apply and create. Whenever you are executing the kubectl create, and if the resource for which you are executing the kubectl create, if that resource already exists in your cluster, then your kubectl create will be failed and you will get the error message on your console. But if you are using the kubectl apply and if the resources already exist, kubectl apply won't fail, right? You will not get the error message. Plus, if there is some kind of update in your resource file, kubectl apply will apply that particular change on your Kubernetes object. So that is the difference between the kubectl create and kubectl apply. You need to make sure that which command you want to use. I personally prefer the kubectl apply. That is the question which you may face in the interview as well. Then we have the kubectl delete command, which is straightforward. Whenever you want to delete any kind of object from your Kubernetes cluster, you can execute a command kubectl delete, define the object type and the object name. Then we have the last command, which is kubectl exec. Kubectl exec is a very necessary command and that is used to execute any command inside the running container. I am repeating the statement: kubectl exec command will be used to execute any command within the running container. Whenever we have the pods running on my Kubernetes, that pod is basically internally running a container. And if you want to execute any command within that running container, you need to execute the command kubectl exec. That is similar to the Docker exec command if you are familiar with the Docker. The only precondition for this command is the resource on which we are executing that command, that must be in the running state. If that resource is not exist or that is in the stopped state or crashed state, then definitely this command will be failed. The command format will be like this: kubectl exec, define your port name, then define -c for the container name and define your container name. Let's open Kubernetes cluster and do some hands-on demonstration on the Kubernetes object and kubectl commands. So we are on our Kubernetes cluster, and here I'm on my single node cluster which I'm executing with the help of Minikube. I have terminated my multi-node deployment because the running cost was very high. So over here what we will do, first we will start with the Kubernetes create command, because if we want to perform some operation on object, first the object must be exist. So I will create a directory called create as object management and go to this directory. Over here we need to create the YAML file. So what I will do, I will create a file pod.yaml. You can name this anything. I'm just putting pod.yaml. Go to the insert mode, and if you remember in earlier lectures, we have basically used this particular pod.yaml. Here you can see the container name is nginx, and we are basically using the nginx latest image which is executing on port 80. I will simply copy this and paste it here. Now I will save this. Now we will see my file is present over here. The file name is pod.yaml. Now we will execute our first kubectl command, kubectl create -f, and provide my file name which is pod.yaml. If your file exists in some other location, you need to provide the complete path of your file. Hit enter, and it is saying that pod name draining node test pod is being created. We have seen the first command, and if that pod is created and we want to get the information about that pod, how we can get it? We can get it with the command kubectl get. Then we need to define the object type and we need to define the object name. But suppose if we just execute this command, what will happen? So there was a spelling mistake. Let's hit this, and we are getting the error. It is saying you must specify the type of resources, and it is saying to get the complete list of the supported resources, we can execute this command. So let's execute this. I will copy this and execute this command, kubectl API resources. And you can see these are the resources which basically Kubernetes supports, right? Here we are getting the resource name, and these are all the resources which Kubernetes support. If you want to get the number of resources, then there is total 57 object type which Kubernetes support. And here we are getting the resource name and the short name as well. So if we will go to the pods, you can see pod is here and the short name is PO. So if we will execute like kubectl get PO, just the short name of my object, hit enter, you can see we are getting the pods. This is the only pod which is running on my Kubernetes cluster. If we will execute the pods, the complete command, then we will get the same result because this is the only pod which is running on my cluster. If we will provide the pod name as well, so we need to provide my pod name. This is my pod name. Then again we will get the same result. And every time we are getting the same result because only one pod is running on my cluster. If there's a multiple pod running on your cluster, then these two command will basically print all the pods running on your cluster, and this command will only print the running node test pod. If you want to check, let's clear out the console and we will execute the command get pods or get PO, define the -n for the namespace, and we will define the namespace like cube system. Hit enter and see these are the pods which are running in a namespace cube system. So you can use the short name as well. If you don't want to put the complete name of your object, you can use the short name as well. Now let's go to the next command, which was defining the object. So we will defining the object of this pod, and we are starting with the -o white. This command we want to use to get the information about this pod. So you can see this is the pod, this is the state, the running, restart is 0, the age, IP of the pod, and on which particular node this pod is running. Right here we are working with the single node cluster, so every time each of my pod will execute on this node. But if you are in the HA deployment, the node may differ, right? It may possible that multiple pods are running on the multiple nodes. If you want to get the output in a JSON format, you can execute -o JSON, hit enter and see we are getting the output in a JSON format. Although this format is not quite readable, But that kind of format is very helpful whenever you want to use this information for the next resources. So for example, you have some dashboard, you have some visualization tool, or you want to supply the information of this particular port to some other port, then this kind of formatted data is very helpful, which you can easily parse with the help of a programming language. If you want, you can print the output in the YAML as well. So I will provide -o YAML, and see, over here it is printing the output in a YAML format, which is a bit readable as compared to the JSON. Here we are getting the complete information about my pod. Now clear out the console and print the information in JSON again. Right, so we have seen the get command, we have seen the create command. Let's go with the describe command. So in my command, I will just replace the get with describe. Right, I'm describing my pod which have a name draining node test pod. Hit enter and see, over here we are getting the complete information of that pod, the namespace which this pod is using, the node and the node IP on which the pod is running, the start time, label of my pod, which is a tier equals to front end, the IP of my pod, the container which is running, the container name which is nginx, the Docker image ID, and the image ID complete resources from where the ID pulled. And here you can see we are getting the steps as well which was executed. It has successfully assigned the pod, then after the pod it pulled the image, then it created the nginx container and started the nginx container. So this is the describe command, right? And now we will execute the another command which is exec. So instead of describe, I will define exec. And what we want to exec, after my pod I need to define my container name -c, my container name is nginx, then put hyphen, and we need to define the command. So suppose I want to print my nginx.conf from my running container. So I will define cat etc nginx, and in nginx we will get the nginx.conf. That is the default path of the nginx configuration file. And you can see on my node I don't have this configuration file. So once I will execute this command, okay, so it is saying the server pods not found. I need to remove this pods from here and just provide exec, then my port name, then -c and container name and the command. Hit enter and see, it is printing my nginx file. This data is basically pulled from within the containers. If you want to see, I can show you. I will copy this. I will put cat and this path on my node, and see, this file doesn't exist. And that is true. That file is not exist on my machine. That file is basically exist within the container which have a name nginx. So over here, whatever the data we are getting that data from the running container. So by this way, you can execute any command within your container, and you can update if you want to update few things. Let's clear out the console. So we have seen almost all the commands. Now, if you want to delete the object, we can execute kubectl, delete, define the object, which is pod, or we can see po, and name, which is draining. Let me copy the name. The pod name is draining node test pod. Hit enter, and you can see it is basically deleting the pod. It will take few seconds, and it's done. After the object deletion, execute kubectl get po to get the pod, and you can see no resource found in the default namespace. It means no pod is running over here. So this is the way how we can manage the objects with the help of kubectl command or command line interface in Kubernetes cluster. Thank you team. See you in the coming lecture. Hello team. Today we will discuss on Kubernetes access management. In Kubernetes access management, we will discuss Kubernetes role-based access management, because role-based access management is most popular and stable access management in Kubernetes. Here is the overview what we are going to discuss in Kubernetes RBAC. It means role-based access management. We will discuss about what is role-based access management in Kubernetes. We will discuss about the role-based access management object in the Kubernetes cluster, and then we will go on the hands-on demonstration on role-based access management. So first start what is role-based access management in Kubernetes. So till date, we have seen we established the Kubernetes cluster and we were creating SSH connection with my Kubernetes cluster and we was doing our job. And whenever we are not doing the things with a specific user, it means we was using the admin account. But ideally, we cannot provide the admin account access to multiple users or every engineer in your organization. So what is the approach to limited the access? The approach is role-based access management, and using the RBAC or role-based access management, Kubernetes allow manage the user access in the Kubernetes cluster. With the help of RBAC, you can define the roles and you can limit the user access management in Kubernetes cluster. In Kubernetes cluster, the Kubernetes administrator or the admin account can restrict the user read-write access in the Kubernetes cluster. Kubernetes administrator have all the rights to allow and revoke the access from the Kubernetes object. In simple word, we can understand if you want to provide some access on the deployment and pods, then you can define the access on the deployment and pods object only. That user who have the only access on the deployment and pods, they will not be able to view or put any operation on the services or any other Kubernetes object. They will be limited to the deployments and pods only. And to apply the role-based access, Kubernetes create few role-based access object. And these objects are the roles and cluster roles. Roles and cluster roles are the object which will define the set of permissions. Within the roles, you can define set of permission that what are the permission and on which particular object that permission is allowed. Within the cluster role as well, you can define the set of permissions that what are permission you are going to allow to that particular cluster role and on which object that permission will be applicable. Roles define the permission within the namespace. So over here you can see we have a cluster and within that cluster we have the namespace. Roles are basically limited to the namespace. It means whenever we are defining the roles, we need to define the role for a particular namespace and that role scope will only limited to that particular namespace. You cannot define the role and roles cannot communicate across the namespace. The another is cluster roles. Cluster role are defined the permission across the cluster. The cluster roles are not limited to any namespace. All the objects which are not limited to the namespace, you can define the cluster role on these particular object and they are not limited to a specific namespace. After defining the roles, you need to bind these roles to the user and that is being done by the role binding objects in Kubernetes cluster. So here we have the cluster, we have the namespace. Within the namespace, we have roles, and these roles can be bind by the role binding to the user. Role binding is the another object which will connect the role to a specific user. Similarly, to bind the cluster roles, we have the another binding object in Kubernetes cluster, which is called cluster binding. With the with these bindings, you can bind the role with the user. There's a one more thing here you can bind single role with the multiple users. There is no one-to-one mapping. If you want, you can bind a single role with the multiple users and you can also assign multiple roles to a single user, right? That term is vice versa and relationship is many to many. So that is about the RBAC and RBAC objects. Now let's go and we will see some hands-on demonstration on Kubernetes role-based access management. But the demonstration we are going to cover in a next lecture because it will be a bit lengthy. So thank you team. See you in the coming lecture. Hello and welcome back. Today we will see the hands-on demonstration on Kubernetes RBAC, which is role-based access management. So execute this lab, we will go to the Kubernetes cluster. So here we are on our Kubernetes cluster K8 as single node cluster. Now, to execute this lab, we have created a handy document. Let me show you that document. We will go through the commands what we created and then we will execute all these commands one by one. So here is a document I got created for you. First, what we need to do, we need to add the user. So first we need to add the user in Kubernetes cluster. After adding the user, we will create the role for that user and after that we will create the role binding for that user and we will see if user is able to access the things which is defined within the role. So that is the complete document. which I will also attach as a PDF within the same lecture, so you can download this document and execute your commands. So very first, as I told you that role is limited to a namespace. So very first, what we will do, we will create a namespace called development. But before this, I will install this package on my machine, which is OpenSSL. So we will execute sudo apt-get install OpenSSL. This is done, and it is saying OpenSSL is already the newest version. It means OpenSSL is already present on my machine. Now we will see how many namespace we have in my project. We will execute kubectl get namespace. So we have these namespace default, and these are the other namespace cube node, cube public, cube system, and level up 360, which we created earlier. We will create another namespace, and that namespace is name development. I will copy this and we will create this namespace. Let's get the namespace, and we have the development namespace created. After this, what I will do, we will create the private key and the certificate signing request for user. My username is going to be a dev user. For this, we will go to the .cube directory. Now we will execute cd $home.cube. So we are inside the .cube directory, and after this, we will basically generate the private key. So we will generate the private key over here, that is being generated, and after this, we will generate the certificate. So we will execute this command, which is OpenSSL request new key. This is the key which we just generated. Then we are defining the dev user CSR, and these are the subject. The CN is dev user, the CN is dev user, CN means common name, and organization is development. Hit enter and it's done. So basically here the common name is the subject, which will be used as a username for the authentication request, and the organization field, which will define the group of that particular user. After that, we will provide the certificate key for the Kubernetes cluster to generate the certificate. So we will execute this command, and the command is, we are defining OpenSSL request, we are defining the CSR, and we are putting that certificate inside the minikube CA certificate, right? Then we are putting out as a dev user certificate, so that certificate is being added within the minikube CA certificates. Hit enter and see, it is done, getting CA private key. The subject is dev user and organization is development. After this, we will execute this command kubectl config view. By this, you will get the config of this minikube Kubernetes cluster. So here we can see this is the API version and these are the cluster. We have the authority root minikube CSRT. Over here we are getting the cluster name, we are getting the users as well. So we have the minikube user, and current context is the minikube. So here the context is minikube, and we have the certificate for the minikube, and the client key is the minikube client key. Team, please make sure whatever the command we are executing on the minikube cluster, they are also eligible for the Kubernetes HA deployment. So if you have the Kubernetes HA deployment, same set of command will execute on your setup. After this, you can see we are not getting any information about the dev user. So what we will do, we will add that particular dev user in the kube config. For this, you need to execute this command. So we will execute this command where we are setting the credential for dev user. We are providing the correct path. We are providing the path for the client certificate and for the client key. Please make sure the path which you are providing for the certificate and for the key, they must be the correct path. Hit enter and see, it is saying dev user is set. Now we will again check the kubectl config view. And right here you can see within the users you are getting one more entry. And that entry for the dev user, we are getting the certificate and we are getting the client key. Similarly, we have the another user minikube, right? So we have created one more user dev user, but the context is still on the minikube. So what we will do, we will add the context for the dev user. For that, we will execute this command kubectl config set context dev user hyphen hyphen cluster. We will define the cluster name, hyphen hyphen namespace. We will define the namespace, and hyphen hyphen user. We will define the user. Please make sure over here we are setting this context only for the development namespace, right? That context will not be allowed outside the development namespace. So we will clear out the console and execute that command and hit enter. The context is done. We will again get the config, and right here you can see we are getting one more context, which is the dev user context, and over here the user is dev user and the namespace is development, and the cluster on that context is applicable is the minikube, right? In your case, if you are using HA deployment, a cluster name may be different. So in your case, if you are using HA deployment, you need to define your cluster name over here. What is your Kubernetes cluster name, and you can get that cluster name from kube config, and in this property name your cluster name will be printed. So if you are using the minikube, then that's fine, the same command will execute perfectly. But if you are using the Kubernetes HA deployment, you need to provide your cluster name over here within this command. So the user setup is done. Now what we will do, we will try to test that particular user context. So let's try to read some pod information from the development namespace for this particular user. For this, you can execute this command kubectl get pods context dev user context. And right here in this particular command, you can see I am not defining any namespace. And why I'm not defining the namespace? Because I already have defined this particular context for the development namespace. So this directly try to read the things from the development namespace. And as this particular user dev user don't have any permission, so whenever I'm executing a command kubectl get pods context dev user context, we are getting an error, right? Error is error from server forbidden, ports is forbidden, user dev user cannot list resources pods in API group, and the namespace is development. As I already set that particular context, the dev user context, to the development namespace, so that I don't need to define the namespace again and again. I can directly define the context, and that will read the user information and the namespace information from the context only. But we don't have that permission. So what I need to do next, I need to provide the roles and create the role binding for this particular user. For this, what I will do, I will create a file vi podreader role.yaml, and before executing that command, let's create some directory, and I'm creating a directory k8s object management. Go to this directory, and over here I will create the yaml file podreader role. Go to the insert mode, and here in this file I will provide this manifest, right? This is the pod reader manifest. Let's go through this manifest. Here we are defining the API version, which is an RBAC API. We are defining the kind, so this is going to be a role. We are defining a metadata about this role, that the namespace for which this particular role will be applicable, and the name of that particular role. Here we are defining the groups, and here we are defining the rules for that particular role. API group will be null. The resources, on which resource that particular role will have the access. So it will have the access on the pods and pods logs. What kind of access we are providing on the pods? Get, watch, list, and update. These are the permission we are providing on these objects to this particular role. The syntax for the role and cluster role is not much different. In case of cluster role, you need to define cluster role over here, and you need to remove this namespace, because cluster role is a global, value, and that is not limited to any particular namespace. I will copy this and paste it here. Now save this, and to apply this role, we will execute kubectl apply -f and define this file name. Hit enter, and we are getting some error. So let's see what is the error. I will open my file, and basically error is this. Over here you can see this is a dot, and this should be comma, right? Let's save this, execute again, right? And role is created. Although we are getting the warning, but role is created. So for the better one, we can do this thing, we can remove this beta, and we will use this API, right? The same file will be available within this lecture, so you can download it. Once the role got created, what we will do, we will check this role kubectl get roles -n development. So you can see we are getting one role pod reader, and this is the created time. Now once we created the role, we can verify the role, and after this what we need to do, we need to create the role binding. So for the role binding, we again need to create the YAML file. So we are creating another YAML file, call it pod reader role binding.yaml. Go to the insert mode, and over here we have the binding file. Here you can see the API is this is the kind of this particular manifest, which is role binding. What we are doing, we are defining the metadata. This is a pod reader, the namespace is development, and then the subject we are defining the user is dev user. We are providing the API group, and then in the role reference we are providing the role and the name of my role. That should must match with the role which you got created earlier, right? I will copy this, paste it here, save this, and execute kubectl apply -f pod reader role binding. This will create the role binding as well. You can see the role binding got created. If you want to check, instead of the role we can define role binding, hit enter, and see we are getting the role binding name pod reader. And on which particular role this role binding got created? The role is pod reader role. So we have the pod reader role and we have the pod reader role binding. Now let's execute that command again which we executed and we was getting the error. What was that command? That command was the read command, and what we was reading the pods. So execute it again, and this time we are not getting the error, but this time we are getting the actual information that no resource found in the development namespace. Earlier we was getting the error, the access forbidden error on the development namespace. It means my roles and role binding is basically executed perfectly fine. If you want to create some pod, you can create the pod over here within the development namespace, and again you can access it. So let's try to create some pod with the context dev user context. And for that you can execute command kubectl run nginx, define your image and execute, and try to execute from the dev user context. And once we will hit this command, we will get the error. Why we are getting this error? Because as per my role, dev user don't have the create access. If you will go with your rules, that we only have the access to get, watch, list and update. We don't have the create access. So let's try to execute that pod with the root user. I will define name development. It means namespace development. You can see pod nginx got created. Now let's try to get the pod information again. So we are getting the pod information with the context dev user context, and see we are getting the pod information. The nginx pod is running within this particular context. So this is the way how you can define the roles and role bindings and how role based access work within Kubernetes cluster. So by the access management system, you can limit the resources which will open to the end user, right? Or which will open to the cluster users. Only admin have all the access, all the permissions, but for rest of the users, you can limit the access. So thank you team. See you in the coming lecture. Hello team. Today we will learn about service account in Kubernetes. In today's lecture, we will see how we can create service account in Kubernetes and what is use of service account in Kubernetes cluster. Here is an overview of this lab. First, we will understand the service account overview. We will understand what is the use of service account. Then we will see how user can create service accounts in Kubernetes cluster. How service account can be bind with the roles so that the service account can be useful in Kubernetes cluster. And at the end, we will go with the hands-on demonstration on service account labs. So let's start with the service account introduction. So in earlier lecture, we have seen how we can create the users and how we can create the roles and bind the roles with the users. So like user is entity in Kubernetes cluster, service account is another entity in Kubernetes cluster. And service account is used by the container process to authenticate with the Kubernetes cluster APIs. Whenever you are executing some container within a pod and that container need to communicate with the Kubernetes API, you need to use the service account. For an example, suppose you are putting some monitoring tool on your Kubernetes cluster, and to get the Kubernetes cluster status, that monitoring tool needs to hit some Kubernetes API. In that case, first you need to create a service account and you need to assign that service account to these pods where that monitoring service tool process will execute. As I told you, if pods needs to communicate with the Kubernetes APIs, then user need to set up the service account to control the access of Kubernetes API. Otherwise, pods will not be able to communicate with the Kubernetes server. We can create the service account using the other Kubernetes objects. There's no different way to create the Kubernetes service account. You can define a simple YAML format and you can execute kubectl apply -f, then that YAML file. The service account YAML format will look like this. We need to define API version, the kind we are defining the service account, and metadata. We need to define the service account name. Here, one more thing you can mention, you need to mention the namespace, because sometimes you want to create service account at a namespace level and sometimes you want to create service account at a cluster level. Once you will create the service account, we need to define the role binding with the service account. And why we need to define the role binding with the service account? Because like the user authentication, service account authentication or access management is also managed by the role based access control system in Kubernetes. We can bind the accounts with cluster role or cluster binding roles to provide the access to Kubernetes APIs. So there is no restrictions. If you want, you can bind your service account with the cluster role, or if you want, you can bind your service account with the roles only. Here is the sample YAML format. How can you bind your service account with a particular role? We need to define the API version, then you need to define the kind, that could be the cluster role binding or the role binding. Then within the metadata, you need to define your service account name, the namespace. Then within the subject, we need to define the kind, and which is a service account. And here we need to define my service account name. Within the role reference, we need to define the role and the role name. So this is a sample YAML which you can use to create the role based binding for a service account. Let's go to the Kubernetes cluster and get some hands-on demonstration on service accounts. So we are in my Kubernetes cluster, and here first we will identify that how many service account do we have in the default namespace. For this, you will execute a command kubectl get service account. So it is saying we have the default service account within the default namespace. If you want to get the service account within a specific namespace, you need to define the namespace. In earlier lecture, we created the development namespace. Let's see how many service account do we have in the development namespace. So in the development namespace as well, we have the default service account. And if we go with the kube system, then here we have a lot of service accounts. You can see a lot of service account are basically present within the kube system. But one thing you can notice, that default is also present within the kube system. It means the default service account is always present within a namespace. Now clear out the console and we will go to the directory which we got created, K8 object management. Here we will create a file and we will call it my service account.yaml. And here we need to define the service account YAML manifest. Here I have created the manifest which you need to define. We need to define the API version, the kind, metadata. You need to define your service account name and namespace. I will copy this, provide it here. Save your file and execute kubectl apply -f and your file name. Hit enter and see service account got created. Let's get the service account again. So we are getting the service account present within the development namespace. And you can see we have the service account, my service account present, and it got created 12 seconds before. Let's see how many roles do we have within this namespace. So we just put roles and we have the pod reader role, right? So we created the service account. Now what we need to do, we need to create the binding. So we will create one more file and we will call it service account binding.yaml, and here we need to provide this content. So basically we are defining the binding, we are defining the API version, then role is role binding. This is going to be my binding name as a pod reader. The namespace will be development, and within the subject we are defining this binding for this particular service account. The kind is service account and this is my service account name. Within the role reference, I am providing the role name, so which is pod reader. So I am providing my service account this particular role. I will copy this, paste it here, save this and execute kubectl apply -f and the service account binding YAML. See, it is creating role binding RBAC authorization API IO as a pod reader got created. If you want to see, you can execute a command kubectl. We need to define the role binding -n development. Hit enter And C, we are getting the another role binding as a pod reader. The pod reader binding we created earlier in the last lab, which is 12 hours ago, and this is 29 seconds ago we created for this particular by this particular file. So this is the way how we can create the service account and how we can create the role binding for the service account. So thank you team. See you in the coming lecture. Hello team and welcome to this section. Earlier we discussed about the object management in Kubernetes. Now in current section we will discuss about the basic building blocks of Kubernetes, which is pods and containers. Pods and containers are basic execution blocks in Kubernetes, and execution of pods and container is the only purpose of Kubernetes. And the complete knowledge of pods and container is very necessary. So there is a possibility that this section may be a bit lengthy. Today we will discuss about the things what we are going to cover in this section. We will see the complete management of application configuration, how we can manage the application configuration in a Kubernetes. Whenever we are executing some application that must have some kind of configuration which make the application function unique. We will see in Kubernetes execution engine how we can manage the application configuration of pods and containers. We will also learn how to manage the container resources in Kubernetes. There are the multiple things whenever we are saying the container management, and we will learn about each and every aspect about the container management in Kubernetes. We will also learn the container health check monitoring in Kubernetes so that we can perform the actions on the container. That could be the auto restart, and the possible actions are the scaling, descaling, auto restart, auto recovery. So we will see how we can manage the container health. We will also learn how to build the self-healing pods. It means if due to any reason my pods or container is going to crash, then they should have the capability of the self-healing, and it will destroy the earlier instance and create new instance to support the application functionality. So this is a basic overview of this section. Thank you team. See you in the coming lecture. Hello team and welcome back. Let's start with our first item, which is application configuration in Kubernetes. We will see how we can manage the application configuration in Kubernetes and how we can supply the dynamic application configuration to container and pod in Kubernetes. Here in this lecture, we will discuss about the application configuration, what is application configuration and what is the use of application configuration. Then we will discuss about the config maps. Config maps is an object in Kubernetes which will help us to make the application config dynamically. Another, we will see how we can use the secrets. Secret is the another object in Kubernetes and which can also help us to supply the dynamic configuration to my application. Then we will see how we can use these things, the config map and secret, with the help of environment variables. And then we will see how we can use the config maps and secret with the help of the configuration volumes. After that, we will go with the hands-on lab and we will see the implementation of config map and secret and the use of config map and secret in Kubernetes to supply the dynamic configuration to pods and containers. Let's try to understand the app configuration. Whenever we are working on any application, there are some configuration which is externalized. I mean to say, in your project, whatever the project you are working, you may have some properties file, you may have some external data set, and in that properties file or external data set, you will need the values dynamically. That could be something like the resource path is externalized, the log locations are externalized, the database paths are externalized, the username and password they are externalized. So it all depends application to application, but 99% application have the dynamic configuration, and on the basis of that dynamic configuration application behaves. Kubernetes allow user to pass the dynamic configuration values to application at runtime. It means within the Kubernetes, we can execute the containers, and to containers, we can pass the dynamic configuration values at runtime whenever we are starting the containers. These dynamic configuration which we can pass in a Kubernetes help user to control the application flow. Definitely it will help the user to control the application flow. Let's take a very simple example. Suppose you have a application which supports the backend and front end, and front end needs the backend configuration, and that backend configuration may be dynamic. I mean to say, within the development, you may have the different configuration. Within the performance, you may have the different configuration. And within the production environment, you may have the different configuration. So within the Kubernetes, we have the facility to pass the configuration dynamically so that Kubernetes can support the application flow. There are two ways to supply the configuration dynamically, and first way is config map. Config map is an object in Kubernetes which can contain the known sensitive data. Within the config map, you can contain the known sensitive data and which can be further passed to the container application. Whenever I am saying the known sensitive data, it means we are not saving the tokens, authorization keys, username, password within the config map. In the config map, we can simply keep the data which is not sensitive to my application. Config map store the data in key value format. You need to define the key and the corresponding value. And whenever you are reading the data from config map in the container, you need to read the key. Config map support this functionality that it will allow you to separate your configuration from your ports and component. It means you can define multiple config map for the multiple containers. It is not necessary that all the containers, all the pods which are running on my Kubernetes cluster, they need to refer the single config map. No, we can separate out the configuration from pod to pod or container to container. It may also possible you can create one-to-one mapping between the containers and the config map. Config map also help us to make the configuration very easy to change, manage and prevent hard coding configuration data to the pod specification. Definitely whenever we have the flexibility to keep the data dynamic, right, then we are not going to hard code the data within the pods. And in any time if I need to refresh my pod, what I will do, I will update the config map and refresh my pod with the new data. Here we have mentioned few config map commands which you can use to work with the config map. So like the other Kubernetes object, config map also support the YAML file. And in any case, if we want to get the config map data anytime, we can get that data from the CLI. So first let's see how we can create the config map with the config map file. So here is the command. We need to execute kubectl create config map. You need to define the name of your config map. Then you need to define hyphen hyphen from file and the path of your file. Over here you can define the multiple files as well. It is not necessary that we are going to define a single file. You can create the multiple files and you can use the multiple files within a single config map. Instead of the file, if you want to provide a directory path, then you can use that thing as well. The command will be same, and instead of the specific file name, you can provide the path of your directory. If some config map is already running on your system and what you want to get the data or file format of that particular config map, then you can execute a command kubectl get config map, define your config map name -o and define the output format. That could be the YAML or JSON. Whatever the format you will define, you will get that data, you will get the config map data in that particular format. To manage the data dynamically apart from the config map, the another object we have the secret. The end goal of config map and secret is similar, but within the config map we cannot contain the sensitive data, but the implementation of secret can support the storage of sensitive data. So secrets are similar to the config map but designed to keep the sensitive data. Like the config map and the other Kubernetes object, we can create the secret from a file, and we need to make sure that whenever we are creating the sensitive data, then my secret don't have the dollar backslash asterisk and the exclamation character in it. If we have these four characters, then we need to require the escaping. If you want to create a secret from a file, you can use a command kubectl create secret, then define your secret name, and from the files you can read your secret. So over here we have mentioned a command that it will generate a secret for the username and the password, and my username.txt contains my username and password.txt contain my password. Once you will generate the secret of the username and password, you can delete this file from your server and you can directly use your secret. Secret will contain the encoded value of your username and password. If you want to get some secret or you want to describe the secret, you can use these commands. To get the secret, we can execute a command kubectl get secrets. It will list out all the secrets available on your cluster within the default namespace. If we want to see the secret of a particular namespace, we need to define hyphen and then namespace name within the same command. If we want to describe the secret, we can execute a command kubectl describe secrets and provide the secret name. And here is the sample secret YAML file. We need to define the API version, the kind which is secret, define your secret name. And over here, if you are defining the username and password, these are the encode 64 values of your username and password. And this will create my secret manifest for your username and password secret. Now we have seen that how we can keep the data within a config map or within a secret. But the question is still open, how we can supply that data to containers. And to supply the data to a container at runtime, we need to read the config map and secret, and then we need to supply that read value to the containers. And that can be done with the help of the environment variable. User can pass the secret and config map to containers using the environment variable. So first we can read the data from config map and secret into the environment variable, and then we will supply that environment variable to the container process, right? So this is the flow. So over here you can see within the container specification, we will define the environment and the variable name. So over here the variable name is special underscore label key, and here we are reading that particular environment variable from this particular config map. My config map name is special hyphen config, and this is my key. My key is special dot how. So from this config map, this key will be read at runtime, and that value will be assigned in this particular environment variable, and that environment variable will be passed to the containers. Within the container process, we will read the environment variable that will be a dynamic for my configuration. Apart from the environment variable, the another way is mount volumes. Mount volume is the another way to pass the config data to the containers, and within the mount volume what we will have the config data available in the files, and at runtime we will mount these file within my container system. The syntax of the volume or the mount volume will look like this. We will define the volumes, define my volume name, and then we will define the config map, which config map we want to read. Here, this particular mount volume will read the complete config map and put that config map in a file. And that file will be mounted within my container at runtime, and container can read any value from that particular config map. Now in the coming lectures, we will see some hands-on demonstration on the config map and secrets, and we will explain how we can read the value and pass the value to a container, and what are the other use cases of config map and secrets. So thank you team. See you in the coming lecture. Hello team and welcome back. Today we will see the hands-on demonstration on manage application configuration. So in today's lab, we will cover these few things. First, we will create the config map object in Kubernetes, and that object we will create from a YAML file. Then we will describe that config map object, and we will see the definition of config map. After that, we will create the secret object using the YAML file again, and then we will pass the config map and secret to a container as a environment variable. So let's go to the Kubernetes cluster to start the lab. So we are on Kubernetes cluster, and first we will create a directory and call it pods and containers. Let's go to this directory, and within this directory we will create our YAML files. So over here we don't have any YAML file. Let's go through the YAML file documentation for the config map first. So team, here in Visual Studio we created few YAML files, and first we will go through the config map. I have created a file named example-configmap.yaml, and here is the content of my config map. We are providing the API version, the kind which is a config map. This is the object type in Kubernetes. Then in metadata, we are providing config map name, and then within the data, we will provide the data of my config map. So first two things are the key value pair. This is the key, player lives, and this is the value. This is the another key, properties file name, and this is the value. Then we are providing another property, base properties, and over here you can see we are providing the multiple value. So whenever you want to supply the key value like a file, you can use this kind of syntax. Here the key is one, but value can be multiple, and you need to define this pipe first, right? After this pipe, Kubernetes will identify that this key have the multiple values. This is my first config map YAML. I will go to my terminal and create a file example-configmap.yaml. Go to the insert mode in this file, and we will copy this content, paste it here. Now we will save the file. To create the config map, we will again execute the kubectl apply -f and my file name. Hit enter and see a config map is created. If you want to get the list, you can execute kubectl config maps. Hit enter and it will list out all the config maps. We have the two config map. This is created by the Kubernetes cluster itself and this is created by us. If you want to describe this config map, you need to execute a command kubectl describe config map and the config map name. Describe config map and provide the config map name. Once you will describe the config map, you will get a data like this. Here the name of your config map, the namespace on which config map got created, and the data. We have the keys player lives, this is the value, another key property file name, and this is the value. Another key is user interface properties, these are the values. Another key base properties, these are the values. We don't have any event over here, right? So this is the way how we can create the config map. Next, we will create the secrets. So in Visual Studio, we created one more file called example-secrets, and over here we are defining the secret. So the API version is v1, then we are defining the Kubernetes object type, which is a secret. Within the metadata, we are defining the secret name, and here we are defining the type. Secret have the multiple types. We will discuss about it in the coming lecture. Then we are defining the secret data. Over here, we are providing the username and password. But whenever you are creating the secret from a YAML file, you need to make sure that you cannot define the direct value over here within the YAML. Over here within the YAML, if you are creating the secret from a YAML file, you need to provide it the base 64 encoded value over here. So we need to encode this admin and admin password value into a base 64. For that, we can convert it like echo -n, define the value which you want to convert, put pipe and define base 64. Hit enter and this is the base 64 value of the admin. I will copy this and provide it here within my secret. The next is admin password. So I will execute the same command again and define password. So complete is admin password. Hit enter and this is the base 64 encoded value for the admin password. Copy this, provide it here. Now create a file vi example -secret.yml. Go to the insert mode and provide this secret. You can save this. Now to create the secret, you can execute kubectl apply -f and define the file name, which is example secret.yml. Hit enter and this will create the secret. This is my secret name. If you want to get the list of your secret, execute kubectl get secrets. And these are the secret which are present in the default namespace. This is created by the Kubernetes itself and this is created by us. Now if you want to describe your secret, you can execute kubectl describe secret and define your secret name. Hit enter. Uh-oh, there is a spelling mistake. So you can see, although we are getting the data of my secret, but it is not exposing the data. It is not exposing what is the data available in the secret. So that is the difference between the secret and config map. Within the config map, it will expose the data, but with secret, it will not expose the data. Now you may have the concern that anyone can read the YAML file and decode that file. So after creating your secret, you can delete your YAML file and now only Kubernetes have the encoded value which you have defined at the time of creation, right? You can use this secret further. So let's clear out the console and we will see how we can use the config map and secret with the help of a environment variable. So again, we have created a pod definition in the Visual Studio Code and here is the pod definition for the environment variable demo. Here I'm creating a pod and my pod name will be config map environment demo. Here I'm creating a container will be a config map hyphen demo and I'm using the Linux Alpine image. That is the smallest Linux image which may be in 5 megabyte or 6 megabyte in size. Then we are providing the command and in the command we are just sleeping my container for an hour. Now to define the environment variable in a container, we are defining the env, right? And define the environment variable name. So first name is player underscore lives. Now we will define that from which particular thing we need to read the value. So we are providing value from And if you want to read the value from a config map, you need to define config map key reference. Here you need to define your config map name. In my case, my config map name is player-pro-demo, and you need to define the key, which particular key you want to read. So let me show you the config map. This is my config map and this is the key which I am reading. Right now I will go to the demo. In the same way, I am creating another environment variable, properties file name, reading that properties file name from the config map, the same config map, and I'm reading the another key which is properties file name, which is this. Now we have defined another environment variable, secret underscore username. To read the value, we are using value from, but over here, whenever we are reading the value from the secret, we are using the secret key reference instead of the config map key reference. Here we are providing the secret name, right? This is the name of your secret and the key which we want to read. So my secret name is example hyphen secret. I'm reading the username. Similarly, defining the another environment variable, reading from the secret name and the value. So what I will do, I will create another YAML. We will put vi config map hyphen env hyphen demo dot yaml. Go to the insert mode, copy the code from Visual Studio Code and provide it here. So we are defining 4 environment variable: player lives, properties file name, secret username and secret password. I will close this. I will save the file. Now after save your file, you will execute a command kubectl, apply -f and provide your file name. Hit enter key and you can see the pod is created. Now after executing the pod, we will execute a command kubectl get pods and we can see my pod is running and it is in the running state and it is in the ready state. Now what we will do, we need to go inside my pod. For that we will execute a command kubectl exec, define your pod name, define -it which is for the interactive mode, hyphen and as this is Alpine, so we will open the sh. If you are using a CentOS or if you are using a CentOS or Linux other version, you can go with the bin bash. I will hit enter and you can see right here I'm inside my pod. If you will put ls, then these are the directories bin dev etc home lib and they all directories are present within my container, right? The container which is executing within this particular pod. Now what we want to do, if you remember, we have assigned 4 values in an environment variable. So let's try to print these variables. So we have the environment variables like properties file name. I will copy and paste it here. See, it is printing the properties file name user hyphen interface dot properties. Let's go to the config map and see this is the correct. Another we have the player lives. So I will copy this player lives echo dollar player lives and see we are getting the 5. Another we have the username or user underscore name. Let's check what is the value, secret underscore username. I will provide this and see we are getting the base 64 value. If you want to print all the environment variables, you can execute print env and it is printing all the environment variables, player lives, secret password and what others we provided, properties file name, and here is the secret username. Right, let's put exit to exit back to the Kubernetes cluster. So this is the way how we can pass the config map and secret at runtime with the help of the environment variables. And in the coming lecture, we will see how we can pass all these things with the help of the mount volumes. So thank you team. See you in the coming lecture. Hello team, welcome to this session. In previous lab, we have seen how we can pass the config map and secret with the help of environment variable. Today we will see how we can do the same kind of thing with the help of a mount volumes. So we are not going to use the environment variables, but we will use the mount volume option to pass the dynamic configuration to my container and pods. So we open the Kubernetes machine, we will execute kubectl get pods, and here is the pod we executed earlier. We will go to the directory which we created for this, and over here we have created few files. Now we will create another YAML file for a new pod which will use the mount volume instead of the environment variable. So first let's go through the definition. So here in my Visual Studio Code, I created another config map file, config map volume demo. We will open it, and you can see this is a pod kind of object. The name of my pod will be config map hyphen volume hyphen demo. I'm defining my container specification, the name of my container, image of my container, the command which I'm executing on my container, and over here we have the few other commands. Let's discuss it later. Apart from this, you can see instead of the environment volumes, what I'm using the volumes, right? I'm not using the environment key over here. Instead, I'm using the volumes. With the environment key, if you will go with the environment variable, it was using the environment key with the container, but right here we are using the volumes. So over here we are defining the volumes, and in a volume we are defining the name of my volume, which is a player hyphen map, and I'm reading my volume from a config map. So here we need to provide the name of my config map which I want to mount. So this is the config map which we created earlier. So here we are providing the name of my Kubernetes object config map, which is player pro demo. If you will go to this example, you can see this is the name of my config map which we executed earlier. Similarly, we are using another volume. The name is player secret. And here I'm reading that particular volume from a secret. So we are defining the secret instead of the config map and the secret name. Secret name is this, which is this we created earlier. Now, these are the two volumes we created. Now within the container specification, we are defining the volume mounts. And over here, we are basically defining the first volume mount. That first volume mount is player map, which I'm mounting at a particular path within my container etc config map. The second volume, the name is player secret, which I'm mounting within my container at a specific path etc config secrets. Right. What I will do, I will copy this, and here within my container, I will create a new file config map hyphen volume hyphen demo.yml. Go to the insert mode and paste your configuration file over here. So you can see I'm creating a pod named config map hyphen volume hyphen demo. What I will do, I will save this file, execute command kubectl hyphen f, kubectl apply hyphen f, and define my file name. Hit enter, and this will create a pod. The pod is created. Now what we will do, we need to go to the pod. So we will execute the command kubectl exec, define my pod name, which is config map volume demo hyphen it for the interactive mode hyphen hyphen sh. Hit enter, and we are inside the pod. So what is the mount location we declared? We declared the mount location etc config map. So first let's go to the etc config map within my container. So I will go etc config, and over here we have the config map. So you can see the directory path exists, and we are inside the etc config map. Put ls, and see here we have the few properties: base dot property, player lives property, file name, and user interface dot properties. What are those things? If you will go to your YAML and you will open the config map, you can see these are the keys. Player life is a key, property file is a key, base dot property is a key, user interface dot property is a key. If you want to get some value, you can execute like this: cat user interface dot properties. The value is color dot good purple, color dot bad yellow, color dot text mode true. The same thing we mentioned over here. Similarly, if we will define the base property, cat base dot property, will get the value of my base property. So this is the way how we can mount the volume within a container. So right now all the key value pairs which are declared within this particular config map, they all are mounted within my container, and they are mounted at this particular location. And how that particular location is created, because I defined that location when I created my pod. Similarly, if you will go to the secret, so I will go to a upper directory. Right now, if you will execute pwd, you can see I'm inside my etc config, and over here we created two directories, config map and secret. Let's go to the secret, put ls, or and here we have the username and password. The only two keys we have inside my secret, the username and password. If you want to get the value, get username, we are getting the username, which is this, and get password, we are getting the password, which is this. And this is the way how we can mount the secrets or the config map within a container or within a pod. Now you can execute your container, you can execute any shell script that will read the values from etc config map or etc config secret, and they can place the value within the container. Although this is possible that you can declare complete properties file within the config map and replace your properties file at runtime from this particular properties file. So there could be the multiple possible combination, but this is the way how we can work with the config map and secret, and how we can pass the dynamic data to containers, either by environment variable or either by mount volumes. So thank you team. I hope you got the concept that how we can pass the application configuration dynamically within a pod or container. Thank you team. See you in the coming lecture. Hello team and welcome to this session. We have the one more way to read the data from config map, and that way is called the config map pos9. So we will open the Visual Studio Code, and here whenever we was creating the config map, and that is the data we kept in the config map, and here is the pod where we was reading the config map. And over here you can see that for each and every property we have in the config map, we was creating the environment variable. Suppose we don't want to do such kind of stuff. We don't want to create the environment variable for each and every property which is available in my config map. And what I want that for each property, I mean to say for each key value pair which I mentioned within my config map, automatically one environment variable will be declared within my container. So how can we achieve this? To achieve this, you need to create another config map which is called pos9 config map. And syntax will look like this. Here you can see we have the API version, the kind is a config map, you need to define the metadata, but within the data, the key format will be changed. Over here, you have one-to-one mapping, right? You cannot define the multiple values over here. Plus, another thing is the key name should be in capital case, and you can use the separator underscore to separate out the words. No small case letter should be allowed in this kind of config map. This is called the POSIX config map. Over here, all the properties which you will define in a POSIX config map, container will automatically create one environment variable for that property. And this is going to be your environment variable name, and this is going to be your environment variable values. Similarly, environment variable name and value, name and value, name and value. Now, earlier we was using like this, but this time whenever we are creating the config map like this, we also need to change the pod definition. And new pod definition will look like this. You need to define the pod, you need to define your pod name, you need to define the container, your container name. We will talk about the image later. Then instead of the environment, you can see over here we was defining the environment, then name of the variable, then value from config map reference, and the config map name and config map value which we want to read in this particular environment variable. We don't need this kind of stuff. What we need, we just need to define env from, we need to define config map reference and define your config map name. In this case, whenever I will create the pos9 config map, I will name my config map player POSIX demo, so that same I'm using over here. One more change I did over here that is not related to the POSIX configuration, but I just want to show you that you can also consume your own image. So over here you can see I'm using an image Anshul DevOps Kubernetes-web 1.10.6. What is that image? Let me show you. I will open my browser. Here I'm on my browser, and here in my browser I will search for Docker Hub. Docker Hub is a registry, or you can say Docker Hub is a repository for the Docker images. You can create your own account on Docker Hub. I'm assuming most of you are familiar with the Docker Hub, but if you are not familiar with the Docker Hub, then that is the repository for the Docker images. On the Docker Hub, I have my account, and my account name is Anshul DevOps, and I also have few public images. You can see these are my public images, and in this particular lecture, I'm using this particular image. Right, the image name is Anshul DevOps / Kubernetes Web, and the version or tag is 1.10.6. So this is the same image what I'm using in my file. As this is a public image, so I don't need to provide any kind of credential. You can also use the same image within your containers and for your practice. That image will execute on port 8080, so that I'm defining ports and container port. So what we will do, we will go to the Kubernetes machine. In Kubernetes machine, we will go to the directory pods and containers where we have all the other files of this section. And here I will create one more file example hyphen POSIX hyphen config map dot YAML. Go to the insert mode and I will copy this config map data. Copy it and provide it here. Let's save this. Now we will create the config map kubectl apply hyphen f example POSIX config map.yml. You can see the config map got created. Clear out the console, list out the config map kubectl get config map, hit enter key. This is the config map we created, player POSIX demo. Copy this. For describe, we will execute the describe command and define your config map name. Hit enter and see. Over here we have the key value, key value, key value and key value. Now we will create another file called vi config map hyphen POSIX hyphen demo dot YAML. Hit enter. Go to the insert mode. I will copy my pod file and paste it here. And the only difference in this pod manifest that we are not defining each and every environment variable separately, but we are using environment from. And we are reading that environment variable from this particular config map. We will save it. Now we will create the pod with this particular YAML file. And you can see the pod is created. If you will describe it, kubectl describe pod and define your pod name, which is config map POSIX demo. And see, it is saying successfully assigned config map POSIX demo and using the image Anshul DevOps Kubernetes Web 1.10.6. If we will clear out the console and we will execute a command kubectl get pods, we can see that POSIX demo pod is running at present in the ready state. Now what we will do? We will go to my container kubectl exec pods, define my pod name hyphen it hyphen hyphen and bin slash bash. Hit enter. Okay, there should be the pod name directly. Hit enter and see we are inside the user src app. Put ll or ls. We have the Docker file, node modules, package log and package JSON. So this is, so you can see right now I'm inside my pod with the root user. See, the user is root and I'm inside my pod. Over here, if I will clear out the console and I will print all the environment variable, print env, you can use this command to print all the environment variables, hit enter. Then you can see all the things which we defined within my config map, they are present over here. User interface property is dark. See, user interface property is here, base property is here, player lives is here, and property file name is here. So automatically my configure map key value pairs. See, my config map key value pairs are defined as an environment variable within my pod. So this is the another way how you can pass dynamic application configuration within your container. Team, I have a request. Whatever the things we are performing over here within the labs, you also need to practice these things. You need to do some changes within the definition file, within the config file, and you need to practice these things. It will help you to get the concept more clearly and more thoroughly. So thank you team, see you in the coming lecture. Hello team, welcome to this lab, and today again we will discuss the config map and secret. And this time we will read the config map and secret from a file, and we will set up a practical engine export. So as a part of this lecture, we will create a secret from a file. Then we will create a config map from a file. In the secret from a file, we will create a secret of st password. And in the create config from a file, we will create a custom nginx file. Then we will set up a nginx pod, and we will set up a pod that will authenticate from a htaccess password. So let's open the Kubernetes cluster and see the hands-on demonstration on it. So we are on Kubernetes cluster and we will go to the directory which we created for this session, pods and containers. So here first we need to update the packages on my Kubernetes cluster. Once package update will be done, we need to install the Apache utils. So we will execute a command apt install apache2 -utils. Provide your confirmation, click on OK. Click on OK. Now clear out your console. After this, to create the htaccess file, you need to execute a command, and command will be like htpassword-z dot htpassword user. Here .htpassword, this is a file which will contain your password, and user is your username. Hit enter. It will ask for the password. Please enter some value which you will remember, because we need that value later in this session. So I have entered the password test123. If you will put ll, or you can see ls-a, you can see the .st password file is being created. If you will get the content of this file, you can see this is the username and this is the encrypted password. The value of this password is which you provided over here. In my case, I provided test123. Now we have the files, and as per my lecture, we need to create the secret from reading this particular file. So we will execute a command kubectl create secret generic. Provide your secret name like nginx -st password. Define hyphen hyphen from hyphen file. It means we are reading the secret from a file, and define your file name, in my case, which is .ht password. Hit enter, and you can see the secret got created. If you will execute a command kubectl get secret, you will get the nginx -st password secret. If you want to describe it, you can describe it as well. Kubectl describe secret and provide your secret name. Here is the secret, and you can see in the data I have a .st password 43 bytes. Once you will create the secret, as I told you that we don't need the file in that case. So what I can do, I can remove that file .staccess, because there is no point to create the secret in a plain text on your disk. Once we created the Kubernetes secret, we don't need the secret file anymore. I will clear out the console. So we created the secret. Now after this, we need to create the config map, and we need to create a config map for a file. So let me show you the file first. So over here in the pod and container directory, I have created a config file nginx.conf, and here is the config file. This is the basic config file. If you are aware with the nginx, then you can understand this particular file. I'm just going to explain few things. So over here you can see within the HTTP server, we have mentioned the basic authentication, and that authentication is basically being done from the conf/st password file. What I will do, I will copy this file, and on my terminal I will create nginx.conf. I will paste that file over here and save my file. Now to create the config map, we need to execute a command kubectl create config map generic. Define your config map name. In my case, I am defining nginx-config-file. Define hyphen hyphen from hyphen file and define your file name. Okay, so error is because related to this generic. I need to remove this generic from here and hit enter. This will create the secret for you. If you want to describe that secret, you can execute kubectl describe, and this will create the config map named nginx-config-file. If you want to describe that particular config map, you can enter kubectl describe config map and define your config map name. Hit enter and see. The name is nginx.conf, and within the data we are getting the complete file. Right. So this is the another way to create the config map. We have seen three ways to create the secret and config map. So first way was the by YAML file, second was the by pos9, and third is by a file. So we have created the configs and we have created the secret. Now what is next? Next we need to create a pod. So we will create a file vi nginx-pod .yaml. Hit enter, and we will copy the pod YAML from my Visual Studio Code. So over here you can see API version is v1, kind is a pod. The name of my pod will be nginx-pod, and name of my container will be nginx-container. Here I'm using the nginx image 1.19.1. The container port will be 80, and see, we are getting the two volume mounts. First volume mount name is nginx-config-volume, which is this, and this is reading the config map which we just created for the configuration file, and it is binding that particular volume at a location etc nginx. etc nginx is a default location for the nginx.configuration file. The second volume name is st-password-volume, which I'm creating over here, and that volume I'm creating from a secret. And what is the secret name? Secret name is nginx-st-password, which we created for the st-password file, and that volume I am mounting at a location etc nginx conf. Right? Same thing we mentioned within my configuration file. See, the location of the password is conf st-password, and we are mentioning the volume at the same location etc nginx conf. I will copy this, go to the insert mode, and provide my file over here. Save your pod.yaml. Now once you will save the file, you need to create the nginx pod. For that, we will execute a command kubectl apply -f and define your YAML file name. Hit enter key. Now let's get the pods. We can see the pod is in the ready state, and we are also getting the IP of my pod. Right? Let's execute a command curl and define your IP, which is this. Hit enter button, and we can see we are getting 401 authorized required message. Why we are getting 401 authorized required message? And you can see over here this IP is listening on the nginx 1.19.1, which is my pod, right? We are getting the unauthorized message because we have configured the username and password with the help of staccess password file. And now whenever we are going to access that particular pod or access that particular nginx which is running in this pod, we need to provide the username and password. And for that you need to execute a command curl -u for the user, define the username which is user, colon define the password which you entered while you was creating the staccess password file. I entered the password test123, and now define your IP. Hit enter and see, we are getting the nginx welcome page, and this is the page which is redirecting from the nginx.html which is present at the nginx share location. So this is the way how we can create the secret and how we can create the config map from a file, and how we can use the config map and a secret directly into my pods. So we have seen a very practical example of the secrets and the config map because we have covered the topic in multiple labs. So I believe you don't have any doubt, but if still you have any doubt, any question, please let me know. I will try to help you. Thank you, team. See you in the coming lecture. Hello, team, and welcome back. Today we will learn how we can manage the resource uses of container in Kubernetes. We will see how we can limit the resource uses on containers and how we can limit the resource uses on Kubernetes nodes. So here we will learn about few terminology, and first we will learn about the resource request. Resource request is something which will define that how much resource a particular container can request from Kubernetes cluster. Then we will go with the resource limit. That is a basically limit on a container which you can define in Kubernetes. And then we will see a hands-on demonstration on resource request and resource limit in a Kubernetes cluster. First, let's discuss about the resource request. So as I just mentioned, that resource request is something that how many resource a particular container can claim. Resource request allow user to define the resource limit user can expect a container to use. So whenever we are scheduling a container, we can define the resource request limit with that container, that what is the expected use of CPU and what is the expected use of memory of that particular container. The kube scheduler, which is responsible for scheduling the containers, will manage the resource request and avoid the scheduling of container on nodes which don't have the enough resources. So we can assume we are executing a setup with two worker and one master node, and we want to spin up a new container which need 2 gig of memory and 2 core CPU. If my worker node don't have that much resources available, then kube scheduler will not schedule my container or any of my worker node until I will add one more worker node which will fulfill the resource demand. Here whenever we are talking about the resource request, and we are defining the requested resource within the container, we actually defining that resource data just for the kube scheduler. We are not limiting the containers, or we are not defining that containers are allowed to use more or less than the defined limit. No, if you have defined that a particular container resource request is 2 core CPU and 2 GB RAM, it doesn't mean that container will only use that much of memory and that much of CPU. No, container can use the less and container can use the more as well. But that limit what we are defining, that is just a expected value we are expecting a particular container will use, and that parameter is a benchmark for the kube scheduler. Kube scheduler will identify the resource request, and it will only spin up the container on Kubernetes if that much of resource is available. So that is a parameter for the kube scheduler, that is not a limit of resources which container can use on your Kubernetes cluster. Whenever we are defining the resource request, we can define the value for CPU and memory. The memory is basically measured in a byte. User can also define the memory in a megabyte. The CPU request is only measured in the CPU unit. It means one virtual core CPU have the 1000 CPU unit. So if we are defining 250 unit, it means we want to use a quarter of CPU. If we are defining 500 CPU unit, it means we want to use half core CPU. Here is the sample which we can use to define the request limit. So you can see we are defining the pod name is front end. Here we are defining the app, which is a container name, the image is nginx, and within the resources we are defining the request. We are defining memory 64 MI. It means that particular container is expected to use 64 megabyte memory and 250 M CPU. It means quarter of one core CPU. The resource limit is actually a limit on the resources which a container is allowed to use. Whenever we are defining the resource limit, we are basically limiting our container to use only that much of resources. Limit are imposed at a runtime on container. So limit is something which will be imposed at a runtime on a container, because we can only measure the uses of CPU and memory whenever container is running. Similar to the resource request, the limit is same. We just need to change this particular value here. Instead of the request, we need to define the limits, and memory and CPU will be same. It means if we are defining that particular definition for my pod, then my nginx container will only use maximum 128 megabyte of memory and maximum 500 M CPU. It means 500 unit CPU, which is half of a virtual CPU. Now you may ask a question, what happened with the container process if that limit will be reached? So there are two things. If container is reaching the CPU limit, it means my container is reaching the half of CPU or 500 CPU unit, then Kubernetes will throttle the process and it will keep the container running. But if my container is using that much of memory and it will try to exceed, in that case, Kubernetes will kill that container and restart that container as per your restart policy. Let's go to the Kubernetes cluster and see a hands-on demonstration on resource request and resource limit. So we are on Kubernetes cluster, and here we will go to the directory which we created for this section, which is pods and containers. And here we will create a file vi request underscore limit.yaml. Now over here we need to define the definition. Let's go to the Visual Studio Code to get the definition of this particular file. So here in the Visual Studio we have defined the request limit, and you can see in the metadata we are defining the pod name frontend -1. This is executing a container and container image is alpine. We are putting this particular command sleep command on my container, and within the resources I'm defining the request, and within the request what I'm defining, and I'm defining this particular pod will use 64 megabyte memory and 250 unit CPU. It means quarter of a CPU. Similar to this pod, I'm defining one more pod over here which have the same values, just name is different, which is -2. Similar pod, just name is different with the similar value, and similar pod with similar resources, just name is different. So what we are doing basically, let's copy this and paste it here. Now save your file. over here what we are doing, we are basically executing 4 pods, and each pod will use 250 CPU unit and 64 megabyte memory. If we will go to the Kubernetes cluster and we will execute a command top and you will press 1, then you can see we have only 2 CPU, and we have defined the CPU limit 250 in each of my pod, and we have defined the 4 pods. It means we are trying to consume our 1 core CPU, which is 250 multiplied by 4000 CPU unit. So let's see if we can do it. Let's press Ctrl C, clear out the console and execute the file kubectl apply -f request limit yaml. Hit enter and see all 4 pods got created. Let's get the status kubectl get pods -o white, and we can see all of my 4 pods are running. Let's do some changes in my file. I will open the request again and I will update the CPU limit, and I will update the CPU limit for my 2 pods. So over here, instead of the 250, I'm updating it with the 750, right? This will use the 750M CPU, and I'm updating the front end pod 3 as well with 750. Save it and again execute the kubectl apply, and again execute the kubectl apply -f and my YAML file. Hit enter and see we are getting an error. And why we are getting the error? Because we don't have the enough resources. So what I will do, if I will execute kubectl delete -f and define my file name, which is request limit yaml, it will delete all 4 pods. We have to wait until the pod will be deleted. One more thing, by this particular YAML file, we can also understand how we can execute multiple resources from a single YAML file. You just need to put a separator and define your resources. And using this separator, we are defining multiple resources, and by only a single YAML file, I'm able to execute 4 objects or 4 Kubernetes objects in my Kubernetes cluster. So this is the way, if you want to define multiple resources in a single YAML file, you can keep them separate by a separator and you can use them as well. My pods are deleted. Let's execute get pod again. So we only have the nginx-pod. If you will cat your file, which is request.limit.yaml, you can see last 2 pods are using 750 CPU, and starting 2 pods, pod 2, front end 2 and front end 1 are using 750, 250M and 250M. So basically we are trying to consume all of my CPU which is present on my cluster. Let's clear out the console and again execute kubectl apply -f request.yaml. Hit enter and see it has created all 4 pods. Let's get the pods again. Kubectl get pods -o white, and over here you can see now we are getting a difference. Earlier all 4 pods was in the running state, but right here you can see front end 3 and front end 4 are in the pending state. Kubernetes is not scheduling these pods, which requires 750 and 750 CPU unit. Why Kubernetes is not scheduling these pods? Because Kubernetes don't have that much of CPU available, right? So in that case, until the CPU will be available for these pods, the pod will always in a pending state and never be scheduled on your Kubernetes cluster. So this is an example of the request resources in Kubernetes. Let's delete these pods so that we can go through the another lab. And another lab is about the resource limit. So here is the YAML file which I have created. Here the API version is v1, kind is pod. Metadata, we are creating a pod name frontend -limit. Container, the image is same, the command is same. Inside the resources, you can see I'm defining the request. And in the request, I need 64 megabyte memory and 250 CPU cycle. And I'm also defining this pod limit, that the limit of this pod will be 128 megabyte in memory and 500 CPU cycle. So this is the limit of this particular pod. If my pod will try to consume more than 500 CPU cycle, then Kubernetes will throttle the process. But if my pod try to consume more than 128 megabyte in memory, then Kubernetes will definitely terminate my pod. Let's go to your Kubernetes cluster and create one more file, resource underscore limit dot YAML. Go to the insert mode, copy the file from here and paste it here. Now you can save this and you can execute kubectl apply -f resource limit.yaml. Hit enter. You can see the pod is created. Let's get the pods by this command and you can see the pod is running. So this is the way how we can enforce the request resource and resource limit in Kubernetes cluster. So thank you team. See you in the coming lecture. Hello team and welcome back. Today we will see how we can monitor the containers health check in Kubernetes. We will see what are the health check options available for the containers in Kubernetes and how we can use these health check options within our container and what are the benefits of health check monitoring. So first we will understand what is the container health check and why container health check is required in Kubernetes. Then we will discuss a component which is a feature in Kubernetes called liveness probe. After the liveness, we will also discuss about the startup probe, and along with the startup, we will discuss about the readiness probe. So these are the three components, or we can say three features available in Kubernetes: liveness, startup, and readiness probe, which will help us to manage or monitor the container health check efficiently. Once we will discuss about all these probes, we will go with the hands-on demonstration and we will see a lab on each of the probe which we discussed in this lecture. First, let's discuss the container health check. Health check in any application is very necessary because health check notify the user that application is ready to consume the traffic or not. Kubernetes is a very feature rich and provide a number of features to monitor the container's health check. In the Kubernetes, we can do the active monitoring and which will help the Kubernetes to decide whether the container state, and if the container state is not as per the Kubernetes health check, then Kubernetes simply auto restart your container to minimize the downtime. Let's take an example. Suppose your application is running within a container and due to any reasons, if the main process of your container malfunction, in that case it will impact the traffic which that container was serving. So if we don't have any health check on the containers, then Kubernetes don't know that what is the state of that container and it will not take any action on that container. But if we have the active monitoring or the health check on the container and due to any reasons if container state is not matching with your health check status, then definitely Kubernetes will auto restart the container. No manual intervention, no human intervention required to recover the application. Kubernetes will automatically restart the application and it will try to recover the failures. The first health check type available in the Kubernetes is called liveness probe. And the liveness probe will help to determine the state of your container. It will make sure that the container is running or not. By default, the Kubernetes only consider the container to be down if container process stop. It means if due to any reasons your container process stop working, then only Kubernetes will take it down and it will restart the container, but that also depend on the restart policy which you have used within your Kubernetes cluster. But liveness probe is a active health check, right? By a liveness probe, Kubernetes will actively monitor your container, and if the liveness probe started failing, then it will auto restart your container. So liveness probe help the user to improve and customize the container monitoring mechanism, because we are putting an extra health check on my container to verify that the container is running or not. User can execute two types of the liveness probe. One is you can execute a command within a container, and if that command status is successful, then Kubernetes makes sure that the container is in the running state. But if your container is some kind of web application, then you can also put the HTTP health check within your container, which will hit the health check HTTP API and verify the status. If that health check HTTP API is throwing 200 status code, then liveness is success. Otherwise, liveness will be failed and Kubernetes automatically restart your container. Here is the sample manifest of the liveness probe. You can execute liveness exec command and you can define your bash command over here. It is accepting the two parameters, initial delay seconds and period seconds. What is initial delay second? Initial delay second means how long to wait before sending a probe after a container starts. Once your container will start first time, then initial delay second will define that for how long we need to wait before sending the first liveness probe on my container. And that is a very good feature because sometimes containers start very quickly, but the process which you are trying to access, that may take some time. So initial delay second will define that how long we need to wait before sending the first probe once the container will start. Period second, that is the interval time. It means how often a probe will be sent. So if you are defining a period seconds like 5 seconds as we have defined over here, then this liveness probe will hit the container in each 5 seconds, and as soon as the liveness probe will be failed, container will be restarted. Similarly, if you want to use the HTTP GET probe, you can use like this. We have the liveness probe, then instead of the command we will use the HTTP GET. We will define the path on which particular path we need to hit the request. We need to define the port as well, and if the headers are required, then we will define the headers in a form of key value pair. Then we will define the initial delay second, we will define the time seconds, and here's one more parameter which is optional, which is timeout seconds. So initial delay second we have discussed about it, time period we know that is the interval. The timeout second is how long a request can take to respond before it's considered as a failure. After the liveness, we have the another probe which is called startup probe, right? So setting up the liveness prompt is a very tricky with application which have a long startup time. Sometimes we have some application that could be the DB application, that could be the data analytics application, or that could be some heavy software which have a very long startup time. Generally the legacy software have a very long startup time, and if you are going to put the liveness probe on that kind of container which have the long startup time, then you should be very precise about the initial time delay, because you don't know that the container will start in 10 minutes, it will start in 5 minutes or 20 minutes or 30 minutes. So you need to be very precise about the initial time delay. Sometimes that prediction is not work, so we need some another probe which will help us to execute with the legacy application or the application which have the long startup time, and that probe is the startup probe. Startup probe run at a container startup and stop running once container success. So once you are starting the container, and if startup probe is a part of your container definition or container manifest, then very first only and only startup probe will execute on that container, and startup probe will only execute once your container is starting, right? As soon as the first startup probe will be success, it will exit out and it will never execute on your container. So startup probe is something which will only work during the startup of your container, and which will make sure that it will not send the liveness probe until unless the startup probe will get the success. If the startup probe and liveness probe is defined within your container manifest, then very first is the startup probe which will execute on your container, because that will execute on a startup time, right? So as soon as the first startup probe will get success, it will exit out and liveness probe will be live on your container, and it will continuously monitoring the health of your container. Once your container will restart again, the very first time startup probe will execute. Once startup probe will exit out, the liveness will take place and it will monitor your container health check. So to avoid the unnecessary failures in your liveness probe, you can define the startup probe if you have a long startup time of your application. The definition of the startup probe is same, you just need to replace the liveness probe with the startup probe. Rest all the other element will be same, right? There's no change between the liveness and startup probe, all the manifest will be same. Here we are getting the another parameter which is failure threshold, which will define a threshold for the failure. If the probe is failing, then Kubernetes will try failure threshold times before giving up. It means the period is 10 seconds, which is the interval, and failure threshold time is 30. Failure threshold time you can also define with the liveness as well, right? If you're not defining the failure threshold, by default that is 1. So if we are defining the failure threshold and the period as well, then application will have maximum 5 minutes, right? In my case, the application will have maximum 5 minutes, because failure threshold is defining the number of failures in the startup probe. If the period is 10 and the failure threshold is 30, then it means my startup probe will exit out after the 300 second, which is 30 multiplied by 10 second. Similarly, we have the readiness probe. So startup prob is something which is basically managing the long startup time. The liveness prob is something which will ensure that the container is in the running state. Then what is the readiness prob? Readiness prob is something which will ensure that my application is ready to consume the traffic or accept the traffic. The running state of your container doesn't guarantee that your application is ready to accept the traffic. Let's take an example. Suppose you are executing your application and your application is a combination of the backend and front end. So we have the containers for the backend application, we have the containers for the front end application. Generally, the front end application containers come up very quickly because there's nothing much to execute. Either they are executing the Node.js or they are executing the Nginx or Tomcat. But it may possible that backend engine may take some time to come up. And in that case, when in a combination of the container, some container are coming up very quickly and the backend container are not coming up very quickly. If we will start sending the traffic on the front end container, then user will start getting the errors because the front end application is accepting the traffic, but front end application will try to talk to the back end application that is still down. So although my container is up, that is ready to accept the traffic, but my complete application, my application as a whole is not ready to consume the traffic. In that case, we need another prob which is called readiness. And in the readiness prob, you can define end-to-end health check status, which will verify your application end-to-end health check, and which will ensure if that health check is passing, then it means my application is completely ready to accept the traffic. So whenever we have the combination of the containers, the readiness health check or readiness prob is very helpful. As I told you, there is the another example that sometimes application might need to load large data set or configuration file during the startup, or it depend on the external service after the startup. So in that case, readiness prob is very necessary, which will avoid the unnecessary traffic failure on your application. If readiness prob is a part of your manifest, then no traffic will be sent to a pod or container until the first readiness prob will be success. Here is the manifest of the readiness prob. So the manifest is same. The supporting parameter like initial delay and the parameter and the period seconds and the failure threshold, they are also the same. Just the basic syntax is different. Instead of the liveness prob or startup prob, you will change it to readiness prob and you will define your command or you will define your HTTP health check. The configuration of HTTP readiness prob will also remain identical to the liveness prob. One more thing I would like to explain, and that is very necessary to define the readiness and liveness prob together on a same manifest, because liveness prob will just ensure the state of your container, but readiness prob will ensure the state of your complete application. So we have discussed about the concept of startup, liveness, and readiness prob. Now it's time to go some labs. So first we will get a lab on the liveness and startup, and then we will get a lab on the readiness prob. Thank you, team. See you in the coming lecture. Hello, team, and welcome back. We have discussed the concept of liveness, startup, and readiness prob. Today, let's go and see how we can use liveness and startup prob in Kubernetes. So here we are on Kubernetes cluster. We will go to the directory which we created for this section, pods and containers. And here we will create a file called liveness -hc means healthcheck.yaml. Hit enter, press I and go to insert mode. In my Visual Studio Code, I created a file for the liveness prob. So first, let's discuss the liveness prob over here. So here we are creating a pod. The pod name will be liveness-prob. Then I'm defining the container name, which is liveness, and we are defining the image. Over here, we are choosing the image busybox, which we will download from the gcr.io. And here is the startup command for the busybox. We will go to the shell and execute a command, -c means command. And this is the command what we are going to execute. We will execute touch temp health check. It means it will create this file, the health check file, within the temp directory. Then we will sleep for 60 seconds. And then we will execute another command rm-rf and remove that health check. And then sleep for the 600 second. Over here, we are defining liveness prob, exec, and that is a command type. Here, what we are executing cat temp health check. This is my command. Initial delay is 5 seconds, period second is 5 seconds. So what is the prob? Prob is something which will check that file exists or not. So over here we can see in the startup command we are creating this file. We will wait for 60 seconds and then we will remove this file. So what will happen over here? Once you will execute this particular container or this particular pod, it will start the container, and at the starting it will create this file. Then it will execute the liveness probe, and that liveness probe will be live for few seconds, for at least 60 seconds. After 60 seconds that file will be deleted. See over here we have the command, and then liveness probe will start failing. Why? Because that file which liveness probe is accessing, that is deleted. So by this example we are validating the success case, plus we are validating the failure case as well. I will copy this and paste over here. Once you will paste it, save your file, and now execute kubectl apply -f liveness hc.yml. Hit enter, and it is saying created kubectl get pods. Hit enter, and see liveness pod is in the ready state, right? Restart count is 0. Let's describe it. Kubectl describe and define my pod name, which is liveness prob. Hit enter, hit enter, and see here we are getting the description. Executed the image and created container liveness, started container liveness. Clear out the console, and after 60 seconds we will check the pod status again. Now we will check the status again, and over here you can see the liveness pod that is in the ready state, and we are getting the restart count. Restart count is 1. And why we are getting the restart over here? That we are getting because after 60 seconds that file is removed, and on that particular file we have the dependency of the liveness probe, because my liveness probe is checking that particular file. That liveness probe failed, and Kubernetes has restarted the container. Let's get the status again. If you want, let's describe your pod. Once we are describing the pod, we are getting few new messages. See, successfully pulled this image. Earlier we was getting these messages only. Then it is saying successfully pulled this image, liveness probe failed, and we are getting container liveness failed, liveness probe will be restarted. So that my container is basically restarted. And here we are getting the reason as well: scheduled, pulled, pulling, created, started, pulled, unhealthy. That is the warning, because liveness was failing over here and killing. Clear out the console, get the status again, and restart count is 2. So this is the way how we can put the liveness probe. And in any case, if liveness probe will failed, your container will be auto restarted. There is no matter that restart policy is there or not. So this is the way we have seen the liveness probe for the command. Let's see how we can define the liveness probe for the HTTP API. So in the same manifest file, I have defined a partition, and here I'm defining a one more pod, which is liveness probe HTTP. And here I'm executing, my container name will be nginx, and over here we are executing the nginx image. And you can see here liveness probe is on the HTTP get call. We are checking the root of my server at port 80, and initial delay is 3 seconds, period second is 3 seconds. Let's copy this, open your file liveness pod probe, and we will define the rest of my file in the same YAML. We will save it, and we will execute kubectl apply -f liveness sc.yml. Hit enter. You can see the first is unchanged and second is created. Let's get the pods, and liveness probe is not in the ready state. You can see container creating. Let's execute this one more time. Still getting the same error. Let's execute again. Oh, let's execute the get again. Get pods again, and see liveness probe HTTP is in the ready state. Restarted 0. If you want, you can describe this kubectl describe pod and define your pod name. And here we are getting the description: image pulled, successfully created, the container created, and container started. My container is not restarting, and the reason is because I'm getting something on that HTTP call. If you want to, if you also want to verify, you can execute curl and define that IP, the IP of my pod. I will copy this and paste it here. Hit enter, and see I'm getting the nginx definition. By default, I'm putting it on the root and if I'm not defining any port, it means by default it is on the 80 port. My http get call is successful so that I'm not getting any error, so that my liveness probe is success and the container is not restarting. Clear out the console, execute kubectl, delete -f and define the liveness probe.yaml. It will delete the containers and we will discuss about the startup probe. So here I created another file for the startup probe, and over here again I'm using the nginx image. The only difference between the liveness and startup, you can see this is the liveness and this is the startup. The only difference between the liveness and startup is this about the probe name. You can see over here we have the liveness probe in the liveness, and over here we have the over here we have the startup probe in the startup. Rest other component will be same. Failure threshold we are defining 30 and period second 10. It means if that nginx will not start it, then this particular probe will wait for at least 5 minutes. Why 5 minutes? Because 30 multiplied by 10 is 300 seconds. What I will do, I will create a file called startup -hc means healthcheck.yaml. Go to the insert mode and paste my startup probe over here. Save this. After save the file, execute kubectl apply -f startup probe.yaml. Hit enter. You can see the pod is created. Let's execute the get command and we can see startup probe http that is in the running state but not in the ready state. Why it is not in the ready state? Because still the first startup probe is not executed successfully. That's why although the container or the pod is in the running state, but that is not ready. If we will execute it again, let's wait for 10 to 20 seconds and again execute the get command. Let's execute the get command again and see startup probe http pod is in the ready state. It means the first startup probe is basically executed successfully. So today we have seen the liveness probe and the startup probe, and we are also aware with the concept of the liveness and startup. Now we can assume that how useful and how powerful these features are. The startup probe and liveness probe are very necessary and very important feature in the Kubernetes, and you can use both probes startup and liveness within the same container manifest or within the same pod manifest. There is no restrictions. So thank you team, see you in the coming lecture. Hello team and welcome back. In earlier lecture we have discussed the liveness and startup probe. Today we will see a lab on the readiness probe. So we are inside the Kubernetes cluster and within the directory pods and containers. Here we will create a file vi readiness-hc.yaml. Hit enter and go to the insert mode. Within my Visual Studio, I have created a file for the readiness as well. And here is the file. So you can see we are creating a pod. The pod name will be hc-probe. Let's remove the HTTP as well. And we are defining the containers. The container name will be nginx. We are defining the image, which is nginx. And over here, you can see we are defining both of the probes. We are defining the liveness probe over here, which will ensure the status of my container. And we are defining the readiness probe as well, which will ensure that when my container will be ready to accept the traffic, right? For an example, we can see both of my props are on the port 80. So let's do one thing. Let's copy this and paste it here. Right now, I don't have the setup where I can show you the backend and frontend example, but we will explain both of the prop by a simple example. Let's save this file, execute kubectl, apply -f, and define readiness hc.yaml. The pod is created, execute the get command, and we can see the hc-probe is not in the ready state. That is only in the running state. Let's describe this kubectl, describe pod and define your pod name, which is this. And here we are getting the status created, container is created and container is started. Get the status again. The container is ready. HC probe is in the ready state. It means both of my probes are executed successfully. Now let's do one thing. Let's execute curl and define the IP of your pod. In my case, my IP is 17.08. I will copy and provide it here. Hit enter and you can see we are getting the nginx page. It means my container is basically accepting the traffic. And if my container is accepting the traffic, that is the same reason I'm able to curl this particular pod. Clear out your console, and to verify the readiness, let's modify your file and let's update the port of your readiness. Let's define some port on which the traffic is not accepted. So let's define port 9090. What we are doing, we are basically starting the container on port 80, but the readiness prop we are defining on port 9090. And we know very well that on port 9090 there is nothing, no service is running on port 9090. So this prop, readiness prop, will never get success, right? So we executed, so we save the file and execute the kubectl apply -f readiness.hc again. Hit enter and we are getting an error. Let's do one thing. Let's delete your container first. Kubectl delete -f readiness hc.yml. It will delete your pod, and after the deletion of this pod we will recreate this pod again, right? Let's get the pods, and that pod is not there. Let's again execute the apply for the readiness-hc.yml. You can see the hc-prob is created. Let's get the pod, and it is saying the pod is here, but that is not in the ready state, although the container is running. Describe your pod, and in the description you can see we are getting a warning. And what is the warning? We are getting readiness probe failed, and this particular url is not accessible. Definitely on port 9090 there is nothing running within my container. My container nginx is running on port 80. So until unless the readiness probe is failed, my container will not be ready. Let's clear out the console and get the status again. So over here we can see because of the readiness prop failure, the container is not coming in the ready state, although the container is running. So that is the way how we can manage the health check of my containers with the startup, readiness and liveness prop. Thank you team. See you in the coming lecture. Hello team and welcome back. Today we will discuss about the self-healing pod policies in Kubernetes. So Kubernetes have the self-healing policies, or we can say that Kubernetes have the container restart policies. So we will discuss what are the container restart policies in Kubernetes and how these policies can help us. Very first, I would like to explain that container restart policy is always a part of your Kubernetes cluster. Even if you are not defining the container restart policy explicitly in your manifest, but Kubernetes always have a default container restart policy. The first container restart policy is always. The second container restart policy is on failure, and third container restart policy is never. So we will discuss about all these three restart policies, and we will discuss about the use cases of all these policies. And after that we will do a lab on container restart policies. So first let's start with the restart policy. Kubernetes have the capability to auto restart the containers when they fails. So all the pods or all the containers which are running within your Kubernetes cluster, if they will fail with error code, then there is a default container restart policy in Kubernetes which will automatically restart your pods. Please remember, whenever the container will exit out with the error code or they will crash, Kubernetes will always restart your containers. The same thing is true with the liveness. But restart policy can provide us a flexibility on this behavior, and by the restart policy we can customize the container restart behavior in Kubernetes, and we will make it more robust, because whenever we are executing application in container, there could be many business needs whenever we don't want to restart the container or we want some customized behavior on the container restart. Kubernetes have the three restart policies: always, on failure and never. First, discuss about the always restart policy. Always is a default restart policy in Kubernetes cluster, and that is by default applicable on all the pods and all the containers if you are not defining restart policy explicitly within your pod manifest. Whenever we are not defining any restart policy, always restart policy will be applicable on your pod and container. And with the always restart policy, there is a drawback that it will always restart your container even if the container completed successfully. So sometimes we create a container which will do some temporary job and which is one time executable, and after that we want that container will exit out after doing that particular job. But if we are not defining the correct restart policy with that container, then container will execute, it will complete their job, and it will exit out. Restart policy will make sure that the container, whatever the container running in your system, that always restart, and it doesn't matter that they will exit out successfully or with a error code. So always restart policy make the container restart every time whenever the container will stop or container will exit successfully. The always restart policy is only recommended for the container that you want that container should always be in the running state. But if you are creating some intermittent containers which are specific to a particular job, and after the job complete that container will exit out, always restart policy is definitely not recommended for these kind of containers. To customize this behavior, we have the another restart policy which is called on failure. On failure is only works if the container process exit out with the error code. So suppose you designed a container and you want that container will always restart if that container exit out with the failure reason, or there could be any kind of failure in a container and that container will exit out, then we want the restart of that container. So we can apply the on failure restart policy with that container. On failure restart policy also work with the container liveness probe and determine if the container liveness probe is unhealthy, it will restart the container. We can use this policy on the application that needs to be run successfully and then stop. So if we want some containers that container will execute successfully and then it will stop, so there is a one time job of that particular container, we can apply the on failure restart policy on that container. Because due to any reason, if container will exit out due to any error in between and the job is not completed, then Kubernetes will auto restart that container and it will complete their job. The another and last policy is the never restart, which is a completely opposite of always restart policy. When you apply the never restart policy on your container, then your container will never restart. It doesn't matter that the container successfully completed their job at or the container exit out with the error code. Once the container will exit out, it will never be restarted if never restart policy is applied with your containers. We use the never restart policy with the application that run only once and never automatically restarted. If you have a specific need that whatever the job I'm doing within a container, that is only one time executable. It doesn't matter that job completed successfully or not, but that job is just one time executable. We will apply the never restart policy with that particular container. So we have discussed about all three policies. In the coming lecture, we will see a hands-on demonstration lab on container restart policies. So thank you team. See you in the coming lecture. Hello team and welcome back. And let's do a lab on self-healing pod concept in Kubernetes. So we will do a lab on Kubernetes restart policies. So here we are in Kubernetes machine and we will go to the directory pods and containers, clear out the console, and here we will create a file vi always restart .yaml. Let's go to the insert mode. So here I have created an YAML template for the always restart policy. We are defining a pod. The name will be restart always pod. And the restart policy, what I'm applying over here is the always. That is a container which will execute the Alpine image and we have a sleep of 20 seconds. It means after 20 seconds that container will stop successfully, right? Let's copy this and paste it here. So it's up to you. If you want to define the always restart policy explicitly on this container, you can define it. Otherwise you can remove it, because always restart policy is a default restart policy in Kubernetes. So I will save my file and we will execute kubectl apply -f always restart yaml. Hit enter. Let's execute the get command and you can see this is running. The restart count is 0. Let's wait for 30 seconds or 20 seconds and we will see that this pod will automatically restart by the Kubernetes. Why? Because I have only 20 seconds sleep within my pod, and after 20 seconds that pod will exit out successfully. Let's execute the get pods command again, and we can see we are getting the restart count 1. Why we are getting the restart count 1? Because after 20 seconds my pod got exited, and due to always restart policy is a default policy in Kubernetes, that pod is restarted by the Kubernetes itself. If you will wait for the another 20 seconds and execute the get command again, you will see that the restart count will be increased. Let's see. And yes, it increased. So this is the default behavior of your Kubernetes. But if you want that your container will not restart it if that container exit out successfully, then you need to change the restart policy of your pods. Very first, before going further, I will stop all these pods. Now I have removed few extra pods which was running on my cluster. Let's execute the get pods again, and we only have the restart always pod. Now we will create another file, vi on failure restart .yaml. Go to the insert mode, and here is the pod definition. We are defining a pod on failure always pod, that is the name of my pod. The restart policy I'm taking on failure. This is another the alpine image, and we are putting sleep 20 second. Let's copy this, put it here. So you can see we are putting the sleep 20 second. It means after 20 second this pod will exit out successfully. So define on failure restart YAML, hit enter, and pod is created. Let's execute the get command, and here is the restart pod which is in the ready state, and restart count is 0, age is 4 second. Let's wait for few second. We will wait for 30 to 40 second, and we will execute the get command again. Let's execute the get command again, and you can see the pod status is completed, right? This pod, the 20-second sleep is executed successfully. Now my pod completed their status. Now my pod is exit out with a completed state, and it will never restart, right? You can see the earlier pod is still restarting, but the on failure pod is never restart. Why it is not restarting? Because the restart policy which I put on my pod is on failure, and pod exit out successfully. So there is no failure. No failure means that pod will never restart it. Now let's do one thing. Let's delete this pod. So we will delete the on failure restart YAML pod, execute the get command again, clear out the console, and we will modify my file. So what we will do, we will modify the command a bit. We will modify like this. We'll put a single code here. We will define sh. It means the executable, put comma, define -c, which denotes the command. And now let's remove this command, and we will define a command like sleep 20 semicolon. It will complete my command, and define another command. Let's define any dummy command as a second command, so that after 20 seconds that command will fail and my container will exit out with the error code. So let's put any text like dummy command, because this is not a command in shell, so this will be failed. So it will execute sleep 20 seconds, and after 20 seconds the next, and after 20 seconds the next command will execute. This command will fail, my container will exit out of the failure, and on failure restart policy will be applicable on my container. Let's save this and clear out the console, execute the apply on failure restart YAML, and call the get command. You can see the pod is in the running state. On failure always pod is in the running state. After 20 seconds that pod will be failed and it will be restarted. So let's wait for 20 seconds, and we will execute the get command again. Let's execute the get command again, and see we are getting the restart count 1. So team, this is the way how we can verify the on failure and the always. Let's create another file, and it will called never restart.yaml. Hit enter, go to the insert mode. Now copy this manifest. The manifest is very simple. We are using the restart policy never. The command is again sleep 20 seconds. Save it, execute kubectl apply -f, never restart YAML. It will create the pod, get the pods again, and see the never always pod in the running state. We have to wait for a few seconds, for 20 to 30 seconds, and we will execute the get command again. Execute the get again. See, this is in the completed state, and rest two pods are still restarting. This is restarting because it is restarting with the always policy, and this pod is restarting on failure pod because we have mentioned the incorrect command after 20-second sleep. So team, this is the way how you can keep the container restart customized, and you can use the restart policy as per your business need. Thank you team. See you in the coming lecture. Hello team and welcome back. Today we will discuss another topic, which is multi-container pods in Kubernetes. We will see how we can create the multiple containers within a single pod, and what is the use case of creating the multiple containers in a single pod. So here we will discuss what is multi-container pod, what is the characteristics of the multi-container pod. Then we will see how we can set up the cross communication between the containers which is the part of same pod. We will also see a multi-container example, and we will see what are the possible use cases to creating the multi-container pod in Kubernetes. And then we will go with the hands-on demonstration and execute a lab on multi-container pod. First, let's discuss about the multi-container pod. So till date, we have created a single container within a single pod, but there is no limitation in Kubernetes. Kubernetes also provide a functionality that we can create a single or multiple containers within a single pod. Whenever we are creating the multiple containers in a pod, then container can share the resources of that pod. Container can share the network, and container can share the volume which is specific to that particular pod. Also, the containers which are part of same pod, they can communicate with each other on localhost. But as a best practice, we need to make sure that we try to keep a single container within a single pod until unless we have a very specific requirement to create the multiple container within a single pod. And what is that requirement whenever we want to create the multiple container within a single pod? So if there is a need to share the resources between the containers, then definitely you can create the multiple container within a single pod. If we have a multiple container within a single pod, how the communication will happen? So container sharing the pod can interact with the shared resources. As I told you that whenever the multiple container is a part of a single pod, they can easily share the resource of that particular pod. So using the shared resources, the containers can interact. So the first shared resource is a network, and containers which are the part of single pod, they can communicate to each other on any port until unless that port is exposed to the cluster. The another communication medium is the storage. Containers can use the same shared volume, and they can use the shared data, and they can interact using the shared data. Let's go with the hands-on lab and try to understand that how the multiple container can part of a single pod and how they can interact with each other. So we have created the connection with our Kubernetes cluster, and we will go to the directory which have the pods and containers YAML files. Here I will create a file vi and I will call it multicontainer.yaml. And here I have created a YAML file for this lab. You can see the API version is v1, and this is a pod kind of manifest. In the metadata, we are defining the pod name, two containers. Within the specification, we are defining restart policy, which is on failure, and we are defining a section containers. Now we are defining two containers over here. This is the first container, which is nginx container and using the nginx image. And this is the second container, which is a Debian based container, right? And here we are using the volumes. Although we have not discussed about the volumes till date, but right here I'm just using the bare minimum volume so that I can explain the concept of multi-container. But in coming lectures we will discuss about the volumes and the type of volumes, the use case of volumes in quite details. So first let's copy this and paste it here on my terminal. So over here, first let's remove the second container and we will see what is the output of my first container. So I will remove the data of my second container, and that's it. So right here what we are doing, although the pod name is same, which is two containers, restart policy is same, but we are executing just one container, which is a nginx container. And here we are mounting this particular location, user share nginx html. This location is present within your nginx container, and what I am doing, I am mounting that particular location with a volume called shared hyphen data. The directory of this data is empty. We will discuss about it once we will go through the volume section. Right now you just understand that we can define the volumes in Kubernetes, and this is the volume name, and this volume is basically attached or mounted with this particular container using this way. Right, we are using the volume mounts, defining the volume name and defining the path of my container which I want to mount with my volume. Please make sure this is the path of your container, not the path of your volume. I will save this. Once you will save the file, we will execute a command kubectl apply -f and multi-container.yaml. Hit enter. It will create the two containers pod. We will get the pods which are running on my Kubernetes cluster, and you can see two containers pod are running on my Kubernetes cluster. There's a one pod which is in the ready state and the pod status is running. This is the IP on which the pod is running. Let's execute curl on this particular IP. Hit enter, and we are getting forbidden access nginx 1.21.0, and we can see that nginx container is running and we are able to access that particular HTML page. Now we will modify my multi-container.yaml. We will remove this complete data. So to remove all the lines from your Vim terminal, you can press D and it will empty your file. Go to the insert mode. Now copy your complete data or complete manifest file. And here we have the nginx container and here we have the Debian container. nginx container is using the shared data, which is the volume we created. And you can see the Debian container is also using the same volume. The volume is same. Within the nginx, user share nginx html directory is mounted with this particular volume, and within the Debian container, pod data is basically mounted with this particular volume. Now what we are doing within my Debian, we are going and executing a command. This is a bash command, echo hello from secondary container, and writing this particular line in a file, and file is present at pod data, which is the volume mount path index.html. So what actually we are doing over here within the nginx, at this particular location there is a file called nginx.html. We have mounted that file at this particular location. The same location we mounted within the second container, which is a Debian, and then we are modifying the content of index.html by this particular command. So earlier we have seen that nginx was showing some kind of 403 forbidden, but now it will show you this particular line. Why? Because the resource is shared. You can see the volume is shared between the containers. Save this, and before executing this we will delete the earlier executing pod. So we will execute kubectl delete -f multi-container.yaml. Right, it will delete my earlier executing pod which have only one container, the nginx container. Once delete will successful, we will again execute the apply -f multi-container.yaml. This time it will create two containers within a single pod. Hit enter and see pod is created. Let's execute the get command, and now within the get pod you can see we are getting two. It means there is two container within this particular pod. It is still in the creating state. We will wait for a few seconds, up to 10 to 15 seconds, and then we will execute the get command again. Let's execute the get command again, and we can see one container is in the running state out of two. If you want to describe, you can describe kubectl describe, define pod and define your pod name, which is this. So we will get the correct status of my pod. So now I believe both of the containers got created. So first the nginx got created and second the Debian got created. Clear out the console, execute the get pods again. Okay, so why only one is in ready state? Because we have just executed a command from my second container and that container is exit out successfully. So that is not a container which is running continuously. It just executed a command and exit out successfully. And what is the task it did? It printed that particular statement within the index.html, which is the mounted location for the nginx container. If I will execute curl now and I will try to get this IP 172.170.0.5. See, we are getting the line hello from secondary container. The Nginx default content is basically being overridden by the statement which we have defined within my second container. And why that statement is being overridden? Because both of the containers are using the shared data, shared volume. Within the same pod, this is the pod and this is the volume of that particular pod. That volume is basically shared between both of my containers, so that I'm able to set up the communication or interaction between both of the containers, right? So this is the way how the multiple containers which are the part of a single pod, they can communicate. So team, this is all about the multi containers in a pod. If you have any question, any doubt, you can ask me. Thank you team, see you in the coming lecture. Hello team and welcome back. Today we will discuss another very important concept in Kubernetes, which is container initialization. We will see what is container initialization and why it is so important in Kubernetes. Within the init container or initialized container, we will talk about what is the container initialization, use case of the container initialization, and hands-on demonstration on container initialization. So let's start with the container initialization definition. What is container initialization or what is init container in Kubernetes? So in Kubernetes, we get a feature called init containers, and the init container are specialized containers that run before app container in your pod. So whenever we are defining the application container or containers within my pod, and if we are also defining the init container alongside with the containers within my pod, then init container will always execute before the containers in a pod manifest. The another feature about the init container, that the init container will only execute during the startup process of your pod. Although the container which we define within my pod manifest, we define the application container which are doing some application stuff. But as we are getting the init container is designed to execute only once, and they will only execute before the main container or application container of your pod. So we can use the init container for the application setup. If you want to set up something before the application container, you can use the concept of init container in your Kubernetes. So as I just told you, init containers can contains the utility or setup script that are not present in the app image. Whenever we are creating the application image, we want to create the application image less bulky and lightweight. So all the things and all kind of setup which you want to perform before starting off your application, you can define that particular setup within the init container, and init container will execute that setup for your application, and then your application will start by the main stream container of your pods. So if you will relate this use case with your daily to daily work, then definitely each application require a bare minimum setup before we start the application. It doesn't matter you are creating the deployment or you are executing the service on your local box. Every application requires a bare minimum setup before starting the application. So that setup, the initialization setup, we can perform with the help of the init container in Kubernetes. There is no limit to define the init container in Kubernetes. User can define n number of init container within a single pod manifest file. Let's understand the execution flow of the init container. So if we are defining the init container within my pod manifest, then very first, the first defined init container will execute before completion of the next init container or the mainstream or application container. So if you have the multiple init containers within your pod manifest, then the first init container which you have defined within your manifest, that will execute first before the execution of next init container or the mainstream container. And after the successful execution of init container 1, init container 2 will execute. User can have the multiple init containers and each will execute in a sequence, and the sequence will be strictly followed and they will execute one by one. First the first defined will execute, then the next defined will execute, then next defined will execute, and all the init container will execute, and then the mainstream container or app container will start execution. There's a prerequisite to start the app container that all the init container must execute it successfully before starting the app container. So init container is a very useful feature in Kubernetes which you can use to set up your application before starting your application in Kubernetes containers. Let's discuss about few use case of the init container. So with the help of init container, we can set up the application, right? We can execute the setup script of my application, which I want to execute before starting my application. The another benefit is if you want to install few packages, you want to get some library, you can get these library within the init container. And what is the benefit of it? It will make your mainstream application container image lightweight. Init container offer a mechanism to block or delay app container startup until a set of preconditions are met. Definitely, the app container will not execute until the init container will execute successfully. So by the init container, we are basically controlling the start process of my app container. We are blocking the start process of my app container, and this feature is very useful. So suppose you have an application which have the DB server, which have the backend server, which have the front end server, and you want that my front end server will only and only execute once my DB server and my backend server will be available. So you can put the condition within the init containers, right? Once you are designing the front end container pod manifest, you can define the init container definition, which will check the connectivity or availability of your backend and database. And once the database and backend application will be available, the init container will execute successfully and then it will start your front end application. Init container can securely run utilities or custom code that would otherwise make an application container less secure. So definitely if you want to put out some code out of your main container image, you want to execute that code, that custom code via init containers. Init container can also help to populate the data within a shared volume, and that volume further will be consumed by your application container, right? If my application container needs some data, then we can do the data seeding job or data setup job via init container. In the coming lecture, we will see a hands-on demonstration on init container, and we will see how we can execute the init containers with the mainstream container. So thank you team. See you in the coming lecture. Hello team, welcome back. And let's see a hands-on demonstration or a lab on init container in Kubernetes. So we are here on our Kubernetes cluster and we will go to the directory which we created for this section, pods and containers. Here we will create a file and let's call it initcontainer.yaml. Go to the insert mode and first we will go through the manifest file before pasting the file over here. So here I have created a manifest file for the init containers. You can see the kind is pod. In the metadata, we are defining the name of my pod, which is application-pod. Here we are defining the containers and I'm defining my container name, my app-container, and using the busybox 1.28 image. This is the command what I am executing within my container. So this is my mainstream container, right? This is the way how we can define the containers within a pod. In the command, I'm executing simple. This is an app and sleeping the container for 3600 seconds. And after then I'm defining one more annotation at a same or parallel level, which is init containers. And within the init containers I will define the init container for this particular pod. So first I'm defining a init container called init hyphen my service. The same image is used by this particular container as well, and it is executing a command. What is the command is until ns lookup my service. This is something a Kubernetes object. Then we are putting some environment variable, and that variable is basically reading the service account name from the namespace and creating the complete service account name, and then it is doing do echo waiting for my service sleep 5 seconds and done. So what we are doing over here basically we are doing a ns lookup for a particular service, right? And what is that service? That service is still unknown. It means I will create that service, right? Until unless I will create this particular service named my service, this init container will not successful and this container will not start execution. Similarly, I'm defining another init container and that is for the DB. And over here you can see I have the same command, exact same command, but the service name is changed. Right here I'm defining the MyDB service name. So what we are trying to achieve over here? Over here, we are putting this container dependency on a Kubernetes services. Still, we have not discussed about the Kubernetes services, but in coming lecture, I will show you what is Kubernetes services. Right now, you can understand that Kubernetes service is a connection point between the external world and the Kubernetes. So, by Kubernetes service, the outer world can access the services which is running or access the containers which is running within a Kubernetes. So I am putting a dependency over here that my app container will only and only start once these two containers will be successful. And these two containers will only and only be successful once these service will be available. So what I will do, I will simply copy it, paste it here and save my file. Execute kubectl apply -f, define your file name, init container, YAML, hit enter. You can see the pod created. Let's execute kubectl get -f and your file name. Over here you can see we are defining the pod name, which is application-pod. The ready state is 0, nothing is ready. And we are getting one more thing over here, which is the status of my init containers. It is saying that this particular pod have two init container and none of that init container is successful yet. Until unless this particular condition will met, the container which we are trying to run that will not execute. It means the precondition for start of this particular container is the init containers, that both of my init containers should be successfully execute. And why these containers are still not executed? Because these services which I am trying to access, the service is still not available within my Kubernetes service. If you want, you can check kubectl get services, hit enter, and I only have a single service which is called Kubernetes. I don't have any service named my service or the MyDB. If you want to describe this particular, if you want to describe this particular pod, we can describe it kubectl describe pod, and we can define the pod name, which is this. And see over here we are getting the complete definition of my pod, and we are getting the init MyDB status is waiting, and my container status is still waiting. So we can see the pod image is basically pulled, but still because init container is not successful, it is not executing my container. Get the pod status again and see the init is still waiting, so that my main container is waiting. Let's do and create the services. So we will create a file init container dependency.yaml. Go to the insert mode and let's go through the manifest. So here we created a manifest, right? You can see over here we are defining two services. See the kind is service. First is my service, which is executing on port 80 and using protocol TCP, and second service is MyDB, which is executing on port 80 and using the protocol TCP. Please make sure right now we have not explained anything about the services. So don't get confused over here. I will explain each and every point about the Kubernetes services in the coming sections. Right now, we are just understanding the concept, so that I took this particular example. What you need to do, you simply need to copy this, put it here, save it, and execute kubectl apply -f and init container -dependency.yaml. Hit enter. The services got created. Let's get the status of my main init container YAML. See, the init is still waiting and application pod is waiting. Let's get the status of this init container dependency.yaml kubectl get -f init container dependency.yaml. Both of my services are executing, right? Let's get the pod status again and see that is in the running state. So as soon as we created the services, the init container dependency fulfilled, and once init container executed, it started my main container. So this is the way how important the init containers are. So if we are using the init container concept, then we can make our application more reliable and more available. So thank you team. That's all about the init container, and that is also the last lesson of this section. In the coming section, we will learn about the pod allocation in Kubernetes. Thank you, team. See you in the coming lecture. Hello, team, and welcome to this new section. And in this section, we will learn how Kubernetes allocates the pod in Kubernetes cluster. So first, we will explore the scheduling and we will see how Kubernetes schedule the pod in Kubernetes cluster. As a part of this lecture, we will learn about what is scheduling in Kubernetes. Then we will learn about the scheduling process and we will learn about the node selector, node name, and then we will do a hands-on demonstration on pod scheduling in Kubernetes. Very first, we need to understand what is scheduling. Scheduling in Kubernetes is a process to assign pods to the nodes so that kubectl can execute them. Whenever we are creating the pods in Kubernetes cluster, the Kubernetes needs to schedule these pods to a particular worker nodes, and once the pods will be scheduled on the worker nodes, kubectl will execute them pods on the worker node. For that scheduling, there is a component in the Kubernetes which is called scheduler. Scheduler is a component of the Kubernetes master node, or you can say it is a component of the control plane. It is responsible to schedule the pods on the nodes, and that scheduling is depend on multiple factors. So suppose you have a master node and there are three worker nodes attached with that particular master node. Now, whenever user is starting few pods on the master node will schedule these pods across the nodes. It may possible that master node will schedule the pod on node 1 or node 2 or node 3. So principle is not like that master node distribute the pods equally on all the nodes or there is some kind round robin algorithm to schedule the pods. No. The scheduling of the pods depend on the multiple factors and we will learn about these factors. So the scheduling process in which the master node will schedule the pods on the worker nodes is like that Kubernetes scheduler select the suitable node for the pods on the basis of multiple factors and few of them like resource request versus available node resources. Whenever you are creating the pod and you are defining a resource request in that particular pod, then Kubernetes will read the pod resource request and it will identify the suitable worker node. If you are expecting 4 core CPU and 2 gigabyte resource request in your pod, but out of 3 worker node, only one worker node have that capacity, so that Kubernetes will identify that worker node and schedule your pod on that node. Another factor which will work in the scheduling process is the configuration, and that configuration is like the node labels. You can define the labels on your nodes and then you can use the same labels in your pod container specification. Kubernetes will read the pod manifest, it will read the labels, and then it will match the labels which are attached with the worker nodes and schedule the pod once the condition will be matched. There could be the another factor like the node selector, node affinity, and node anti-affinity. We will learn about all these things shortly. First, let's discuss about the node selector. So node selector is defined in the pod specification to limit which nodes the pod can be scheduled on. So whenever we are scheduling the pods, you can define the node selector definition within the pod specification, right? Where you need to define some key value pair, which is a label, right? And that label Kubernetes will match on the Kubernetes worker nodes. Once the label of your pod and the worker node will be matched, Kubernetes will schedule your pod on that particular node. It may possible that you will attach the same label with the multiple worker nodes. In that case, again Kubernetes can schedule your pod on any of the worker node which is matching your label. But if resource request is also defined, then resource request will be matched and pod will schedule on a node which will satisfy the label match plus the resource request match. Node selector use labels to select the suitable node. As I told you that you need to define the labels within your pod and that label will be matched on the worker node. So here is a sample pod definition. So you can see we are defining the Cassandra and we are defining a node selector. Within the node selector, we are defining a key value pair disk type and disk type is SSD. If you will execute this pod manifest, then this pod, the Cassandra, will only execute on a worker node which have this particular key value pair as a label. Until unless this particular key value pair will not be matched, your pod will not scheduled on any worker node. Another configuration is the node name. User can bypass the scheduling process by assigning the pod to a specific node using the node name. It means within your manifest file, you can define the node name, and Kubernetes will schedule your pod on a node which name is basically defined within the node name selector. Right. So over here you can see we have the pod definition and we are defining the node name. And over here you need to define the worker node name. Typically, we should avoid these kind of practices. We should not use the node name, because if we are executing the Kubernetes in the cloud environment, then the infrastructure will be dynamic, and it may possible that the worker nodes are basically going down dynamically and new worker nodes will be spin up dynamically. In that case, these kind of practices will be very harmful, because if node name is not matching, then Kubernetes will not execute your pod. In the coming lecture, we will see some hands-on demonstration on the node selector, node name, and the resource request, that how Kubernetes scheduler will work and schedule the pods in the Kubernetes worker node. And in that lab, we will use the Kubernetes HA environment, which will have one master and two worker nodes. So thank you, team. See you in the coming lecture. Hello, team, and welcome back. Today, we will see a hands-on demonstration on pod scheduling in Kubernetes. So in this lab, we will use Kubernetes HA setup, where we have one master node and two worker nodes. So we are on Kubernetes master node, and if we will execute kubectl get nodes, you can see we have one master node and we have two worker nodes, worker node 1 and worker node 2. Now we will check what number of pods are running in my default namespace. We will execute kubectl get pods, and no pods are running in my default namespace. So very first we will create a directory called pods underscore allocation. Go to the pods allocation, and here we will create a file vi node selector dot yaml. Right, hit enter. Now we will see how we can define the node selector. So here in my Visual Studio Code, I have created a manifest file, and this is the pod manifest which I'm going to use for the node selector. Over here we can see this is a pod object. The object name will be nginx node selector. Here I'm using the nginx image, and I'm using the node selector within the pod specification. And for the node selector, we are using a key value pair disk type SSD. It means only the worker node which have this label can execute this pod. I will copy this, paste it here, and save my. Now execute kubectl, apply -f, and define your file name node selector yaml. Oh, I need to make sure that my pod name should be in the lowercase. We will edit the file, and there's a s in the capital case. We will make it small, save it, and again execute the kubectl apply -f node selector yaml. You can see this pod is created. Let's check the status of my pod. We'll execute kubectl get pods, and you can see that node selector pod is in the pending state. Let's execute -o void. So you can see this pod is not scheduled on any node, right? This is in the pending state. If we will describe the state of this pod, kubectl describe pod and define your pod name, we can see that we are getting failed scheduling status, right? And here it is saying nodes are available, 3 nodes didn't match pod node affinity or selector. It means whatever the nodes are executing as a part of this particular cluster, they are not matching this node selector, which is disk type equal to SSD. Let's clear out the console, get the pod status again, which is in the pending state. Now let's see what are the labels are attached with my cluster nodes. For this, you can execute a command kubectl get nodes space hyphen show hyphen labels. And these are the labels which are basically attached with your node. This is the master node. Master node have the labels beta kubernetes io, beta kubernetes io os, exclude from external load balancer, right? And these are the labels which are basically attached with your worker nodes. So if I want to execute this particular pod on any worker node, first what I need to do, I need to assign that particular label with any of my worker node. And how can we assign a label to a worker node? That is still a question. For this, you need to execute a command kubectl label nodes, define your node name. Here we are getting a node name. So suppose I want to tag that label with my node 2. So I will copy this and provide it here, k8s worker node 2, and define that particular label. What is that label? The label is disk type equal to SSD. You can see we are defining like this. That is labeled. If we will again get the show labels, then we can see the disk type SSD is attached with my worker node 2. If we will get the pod status again, then my pod should be scheduled on my worker node 2. And see, it is running. And where it is running? It is running on the worker node 2. So this is the way how pod scheduling work with the help of node selectors. So using this way, the Kubernetes scheduler work with the pod scheduling. Let's clear out your console and get the node labels again. Now we will see how we can use the node name. So we will copy any of my node name. And I want to copy my first node name. Let's copy this. And over here you can see there's the second manifest, which is a pod kind of object, and I'm using the node name. Over here I will provide my node name. This is my node name k8s hyphen worker hyphen 01. There's a spelling mistake, that should be hyphen worker, but whenever I created the node, there was a spelling mistake over here. Now what I will do, I will copy this, create a file vi node name.yml, paste it here. And again we need to modify my container name, that should be in the lowercase. Save this. Now we will execute kubectl apply -f node name, hit enter, and the pod is created. Let's get the pods, and you can see the node name pod is basically scheduled on my k8s worker node 01. So this is the way how Kubernetes scheduling process works. Now we will see how the Kubernetes scheduling work on the basis of resource request. So I created a manifest file over here. You can see this is a manifest file front-end app. This is a pod kind of file where I'm using the Alpine image, and here I'm asking of a one core CPU, right? The node selector type is the disk SSD. So over here you can see I'm using the two parameter. First I'm using the node selector disk type, which is SSD. It means this particular pod will only and only execute on a worker node which have this particular label. And once this particular condition will be satisfied, this node will only assign to a worker node which will have this much of resource available, right? Which means CPU 1 core and memory 64 megabyte. So let's copy this and we will create vi resource request 1.yml. We will paste it here, right? So I'm using the node selector as well, plus I'm using the resource request as well. You can see I'm requesting the resource with 1 core CPU and 64 megabyte memory, plus I'm also using the node selector which have the disk type SSD. So in my case, only worker 2 node have the disk type SSD label attached. I will execute kubectl apply -f resource request 1.yml, and you can see front end app is created. We will get the pods, and the front end app is in the running state, and that is running on the worker node 2. Let's do one thing. Let's copy the file resource request 1 resource request 1.yml. We will copy this, define a separator, and define my file again. Over here let's take it front end app hyphen 1. I am again creating one more pod which will execute on a node which have the node selector disk type SSD, which will have this particular label, and I'm again asking one core CPU in this particular pod. Let's copy this and execute kubectl apply -f resource request YAML again. You can see one pod is basically configured and one pod is basically created. Let's get the status of my pods again and see. My another pod is in the pending state. And why this is in the pending state? Because the scheduler is fulfilling the first request. It means scheduler is fulfilling the node selector request that this pod can only and only execute on a node which have the disk type SSD. But we don't have this much of CPU to execute that particular pod, because I'm just using the 2 core CPU machine, and out of that, one core is consumed by this particular pod and another core is basically used by the Kubernetes itself. So we don't have the CPU available for this particular pod. And my another worker node, which is K8 as worker node 1, this worker node have the resources, but this worker node don't have the label, so that the pod frontend app-1 will not execute on that particular node. If we will execute the get again, see, it is still in the pending. If you want, you can describe, copy this, kubectl describe pod, define your pod, and see it is saying insufficient CPU, right? So it is matching the node label, but the resource request is not matching. Clear out this console, create one more file, resource request to YAML, go to the insert mode and copy this manifest. Here I'm again executing frontend app2 and I'm asking one core CPU but not attaching any node selector with this particular manifest. Copy this, paste it here, save this and execute. Hit enter. You can see frontend app2 is created. Get the status of pods. Then you can see the frontend app2 is executed on the worker node 1, but frontend app is still waiting. So this is the way how Kubernetes pod allocation or how Kubernetes pod scheduler work in Kubernetes cluster. We have seen few ways to schedule the pods on the worker nodes. In the coming lectures, we will see few more things. So thank you team. See you in the coming lecture. Hello team, welcome to Kubernetes training. And today we will learn about daemon sets in Kubernetes. We will see what are the daemon sets and what is the use of daemon sets in Kubernetes. In this lecture, first we will discuss what is daemon sets. We will discuss about the daemon sets working in Kubernetes, and we will learn about the relationship in daemon sets and the pod scheduling, and then we will see a hands-on demonstration in daemon sets. So daemon set in Kubernetes is an object like the pods, which will automatically run a copy of a pod on each node. So whenever you want to create that a copy of a particular pod will execute on each node present in your Kubernetes cluster, you need to create the daemon set of that particular pod. Daemon set run a copy of pod on new node as they added to a cluster. So whenever we are creating a daemon set, it will execute a copy of defined pod on each available node in Kubernetes. Plus, as you will add a new node in your Kubernetes cluster, daemon set will execute a copy of the pod on new node as well. So daemon set will make sure that whatever the nodes are present in your Kubernetes cluster at a point of time, a copy of a particular pod which is defined in daemon set will execute on each and every node which is a part of your Kubernetes cluster. So these kind of functionality can be helpful in multiple kind of operations. Some of them like the monitoring. If you want to put some kind of monitoring on your Kubernetes worker nodes, you can execute the monitoring application as a daemon set. If you want to execute some kind of log collection, some kind of data collection, right, you can execute that particular thing from a daemon set, so that that log collection or data collection will be done from all of the pods. If you want to configure the proxy setting by which you can communicate over the internet or some external network, then you can set that particular thing with the daemon set as well. So there could be multiple kind of business use cases where you can execute the pods with the help of daemon set. And what is the basic requirement to use the daemon set? So whenever you want to execute some kind of configuration on each and every node present within your Kubernetes cluster, you can define that thing in a pod of daemon set. The restart policy which is attached with the daemon set is a always restart policy. So if you have a two nodes in your Kubernetes cluster, then daemon set will automatically execute the pod on each of two nodes. And in future, whenever you will add a new node in your Kubernetes cluster, the daemon set will execute the same pod on the that node as well. So daemon set will monitor the Kubernetes cluster, and as soon as the old node are going and the new node is coming, daemon set will perform the operation as per the daemon set specification. Whenever we talk about the scheduling and the daemon set, then daemon set follow the normal scheduling rules. So the scheduling rules we have learned about the labels, tent and toleration. We have not discussed about the tent and toleration. In the coming lectures, I will show you what is tent and toleration in Kubernetes cluster. So whatever the rule are applicable for the pod scheduling, all of the rules are basically applicable with the daemon set as well. If pods normally not scheduled on a node due to any reason, then daemon set will also not create a copy of pod on that particular node. And as soon as the pod schedule will be available on that particular node, daemon set will create a copy of a pod on that node. In the coming lecture, we will see a lab on daemon set. Thank you, team. See you in the coming lab. Hello, team. Welcome back. And today, let's see a lab on daemon sets. So first, let's go to the Kubernetes cluster master node. And on Kubernetes master node, I'm in a directory pods and allocation. Here I will create a file vi daemonsets.yaml, and I will define the daemon set manifest over here. Let's go through the daemon set manifest first. So here I created a sample daemon set manifest. You can see the API version is apps v1, and this time the object type is a daemon set. Daemon set is object in a Kubernetes. So before this we have seen the kind only pods, but this time we are going to create another object in a Kubernetes which is called daemon set. Here we are defining the metadata of this object. The name could be the logging, right? Then we are defining the specification of my daemon set. And within the specification, first we are defining the selector. And in the selector, we are defining the match labels. And here I'm defining a label app httpd-logging. We have not discussed about the selector till date, but once we will learn about the deployments and services, I will show you the actual use of the selector. Right now, you can assume that this selector can be used to identify the pods running in your Kubernetes on the basis of that particular label. Then we are defining the template, and within the template, you need to define the manifest of a pod. So here we are defining the metadata labels, and we are defining the label app httpd-logging. You can see this label what we are defining over here and the label what we have defined within the selector are same. Please make sure the label what you are defining in a template of your pod and the label which you have defined within the selector of daemon set, they must be match. Then we are defining the specification. In the container, I'm going to use the container name web server. I'm going to use the image httpd which will execute on port 80. So that is the basic daemon set manifest what we are going to create. Let's copy this and paste it here. Save it. Before execute this file, let's see how many pods we are running on my Kubernetes cluster. So we'll execute kubectl get pods -o void, and no pods are running on my Kubernetes cluster. Let's execute kubectl apply -f daemon set yaml. Hit enter, and you can see daemon set apps logging is created. If we will execute kubectl get daemon set, hit enter, then you can see one daemon set is running. Desired is 3, current is 3, and ready is 3. It means 3 copy or 3 pods of that particular daemon set is running. Desired state is also 3, current state is also 3, and ready state is also 3. So if you will check the pods, we will copy this command and execute. So you can see 3 pods will be running for this particular logging daemon set. See, the logging 1, logging 2, and logging 3. And they all are running on the individual node. First is running on the master, another one is running on the worker 1, and another one is running on the worker 2. So that is the use of daemon set. Now if you remember that we have defined the same label for my pod and for my selector. Now let's do one thing. Let's update the match label selector for my daemon set. So I will again open my file daemon set YAML, and I will update this particular match label. Suppose I am going to update it match label logging -1 like this. Save it, and we will execute the apply on daemon set YAML again. Hit enter. Then you can see we are getting the error, and error is invalid value. What is invalid value? Invalid value is the HTTPD logging selector doesn't match the match template labels, and it is also saying the field is immutable. So we need to be make sure that whatever the match label we are putting over here within the match labels, the same label should be applied in the template labels, right? By this particular label, the daemon set will identify that which port is a part of a daemon set, right? So over here, this particular daemon set is identifying the port on the basis of this particular label, because this label is attached with your pod. If you want to see, I can show you. Let's execute kubectl describe pod and define your pod name. Suppose we are going to define the pod from my second node. Hit enter, scroll a bit, and see. Over here you can see we are getting the label. So on the basis of this particular label, the daemon set is identifying the which pod is running on a particular node, which is a part of this particular daemon set. And if you will describe your daemon set, let's clear out the console and describe your daemon set. Kubectl describe daemon set logging. Hit enter. Then see over here we have the selector, right? So this selector must be matched with the level of your pod. So team, this is the lab on daemon set, and this is the way how we can define the daemon set and execute the daemon set. Thank you team. See you in the coming lecture. Hello team and welcome back. We will learn about the static pods in Kubernetes. We will see what are the static pods and how we can use the static pods in Kubernetes. So we will start with the basic definition of a static pod. Then we will see what is mirror pod, and then we will see a hands-on demonstration on a static pod and mirror pod. So first, let's start with the static pod. What is the static pod? So till date, we have learned about that in Kubernetes, there is a typical architecture, master-slave architecture. And all the operation which are performing in a Kubernetes cluster, master node is basically governing, or master node is basically managing all the operations in your Kubernetes node. But a static pod is out of way. A static pod directly managed by the kubelet on Kubernetes nodes. So kubelet is an agent which work on the worker nodes, and static pods are basically directly managed by the kubelets. They are not managed by the control plane or Kubernetes API server. Kubernetes API server is nothing to do with the static pod. Even the Kubernetes API server or control plane is not required to execute the static pods. So each and every resource, whatever you are creating or whatever you are executing in your Kubernetes cluster, that is being managed by the master node or the control plane. But a static pod is the only entity which is being managed by the kubelet itself. Kubelet watch each static pod and it restart if it fails. So if due to any reasons the static pod which is running on a node, if that execute, if that fails or that exit with the error code, then kubelet will automatically restart that pod. To create the static pod, you need to define a YAML manifest file. That YAML manifest file is similar to the pod manifest file, but you need to create that particular file at a specific manifest location, and at that location, kubelet will automatically identify the YAML file and create a static pod for you. Now, you may have the questions that what is the use of a static pod? So suppose you want to put some kind of monitoring or you want to put some kind of configuration what you want to execute without the API server or without the control plane, you can put these kind of settings or you can put these kind of use case within the static pod, and static pod will execute on each and every node which is the part of your Kubernetes cluster. Then what is the mirror pod? So mirror pod is nothing but a replica of the static pod. As the static pod is being managed by the kubelet, so we don't have any way to see the pod status to get the pod information. so that kubelet will create a mirror pod for each static pod, so that user can access the static pod via Kubernetes API servers. So mirror pod allow user to monitor the static pod by the Kubernetes APIs or Kubernetes control plane. Although you can monitor the static pod, but you cannot change or update the static pod by a mirror pod. If you want to perform some kind of operations that is changing the state of your static pod, or that is doing some kind of update in your static pod, you cannot execute that kind of stuff by a mirror pod. For that change, you need to update the YAML file on the node itself, and kubelet will update the status. But by a mirror pod, it is not possible to change the state of your static pod. In the coming lab, we will see a hands-on demonstration on the static pod. Thank you, team. See you in the coming lecture. Hello, team. Welcome back. And we will see a lab on static pod. We will see how we can create the static pod and how we can get the static pod monitoring by a mirror pod. So here we are on Kubernetes master node, but as I told you that static node is not being managed by the master node or the control plane. So we need to make a SSH connection with any of my worker node. So let's see what are the worker nodes available with my Kubernetes cluster. We will execute kubectl get nodes. So we have the two worker node K8s worker node 1 and K8s worker node 2. Let's open any of the worker node. Now in another terminal, we have created a connection with the worker node 2. Let's go to the master node and execute the get status on pods. So we can see only daemon set is running because 3 logging pod are running in my Kubernetes cluster. We will go to the worker node and we will create a manifest file at a particular location. Why we are creating a manifest file at a particular location? Because we need to define the manifest file in a location where kubelet will look for the YAML files for the static pod. As we are executing our system with a kubeadm, so we need to create a manifest file at etc kubernetes manifests, right? Let's put ls or ll. So we don't have any file over here. Let's create a file vi static pod.yaml. Go to the insert mode and here you can define any pod YAML file. So let's suppose we are going to define this, which is this nginx YAML file. I will copy this and provide here. So you can see this is a very simple nginx file. I will rename it like nginx static pod, right? And I will save it. Now if you want, you can wait for some time. Kubelet will automatically read this file and create a pod for this. But if you want to make it effective, if you want to make this pod effective immediately, you can restart your kubelet service. So we will execute sudo systemctl restart kubelet. Hit enter and it's done. Now let's go to your master node and execute the get pod command again. You can see one more pod is running nginx static pod, and then it is defining hyphen and your worker node name on which particular worker node this pod is running. So this is a mirror pod of my static pod which is running on my worker node 2. Now if you want to describe this pod, you can describe this kubectl describe pod, define your pod name, hit enter and see. We are getting the pod description that the node on which this pod is running is a worker node 2. Here we are getting the information about the container, the image ID, and we are getting the other inputs. Now let's clear out your console and execute the get pod command again. Now suppose what you want to do, you want to delete this particular pod, right? So let's do it. I will copy this, execute kubectl delete pod, define your pod name, hit enter. It is saying delete it, get the status again, and you can see the pod is still running. Why? Let's describe the pod again, and you can see we don't have any status over here. So what is happening? Although I executed the delete and we got the message that pod is deleted, but still pod is running again. Why this pod is running again? So ideally this is a mirror pod, right? And you cannot change the static pod state by a mirror pod. That's why you are not able to delete this particular pod, or you are not able to perform any change in the static pod by this particular pod or by a mirror pod. So you have seen the concept of the static pod. Whenever you want to put some bootstraps on your node, you can execute that particular thing by a static pod, and that static pod is not being managed by the Kubernetes control plane or Kubernetes master node. So thank you team. See you in the coming lab. Hello team, welcome back. And today we will discuss about node affinity in Kubernetes. We will see what is node affinity and what is node anti-affinity and what are the use of affinity and anti-affinity in Kubernetes pod allocation. So in this section we will learn about the node affinity. We will see an example of the node affinity and node anti-affinity, and then we will move to a hands-on demonstration on node affinity and node anti-affinity. Node affinity is also a mechanism to allocate the pods on Kubernetes cluster, but that is an enhanced version of the node selector. We have already learned about the node selector where we need to define the key value pair, which is a label on node, and on the basis of that label, node selector work. But node affinity is an enhanced version of the node selector, because in node affinity you can put the conditions. In node selector we don't have the conditions, but in node affinity we can provide the custom conditions, and that is introduced in Kubernetes 1.4. As I told you, node affinity is also a pod allocation mechanism in Kubernetes. So by node affinity and node selector we can schedule a pod on a particular node, the set of nodes or a particular node which have a specific tag or a specific label. But what if you don't want to schedule the other pods on a particular node? So let's take an example of our Kubernetes cluster. And in our cluster with a specific node, with worker node 1, we have attached a label disk type SSD. Now suppose there are few pods which I don't want to schedule on the node which have the SSD disk. So we can use the node anti-affinity. Node anti-affinity help us not to schedule the pod on a particular specific nodes. Anti-affinity is opposite of the node affinity and node selector concept, where the node affinity and node selector are scheduling the pods on a particular node. By anti-affinity, we can skip the scheduling of pods on particular nodes. Let's understand the difference between the node selector and node affinity by a simple manifest file. So this is a manifest file for a pod where we are using the node selector, and in a node selector we are using the label, which is a key value pair. But the same thing if we want to achieve by a node affinity, the node specification will look like this. Here I am taking the syntax from the specification, it means from here. So see, we are defining the specification, pod specification, we are defining the containers, and then instead of the node selector we are defining the affinity. Within the affinity we are defining the node affinity, and within the node affinity we are defining required during scheduling, ignore during execution. We will talk about it, what is this. Then we are defining the selector terms, then we are defining the match expression, and then we are defining the key, which is a disk type, then the operator and the values. So over here, if you have a label which have the multiple values, you can define that thing as well. You can see here we are putting the conditions, and node affinity have a enhanced syntax as compared to the node selector. We will discuss shortly how node affinity is more flexible as compared to the node selector. But there is a difference between the syntax of node selector and node affinity. Both of the syntax will do the same work. The pod on which this syntax will be applied or this syntax will be applied will only and only execute on a node which have a label disk type equals to SSD, right? But the syntax is different in case of the node selector and in case of the node affinity. We just seen a particular term required during scheduling, ignore during execution. Let's understand what is this. So whenever we are using this particular syntax with the node affinity, so here you can see this syntax is divided in a two part. First part is required during scheduling and second part is ignore during execution. Required during scheduling means whenever the pod is scheduling on the Kubernetes node, the condition whatever we are putting in a node affinity, that must be fulfilled, right? If that condition is not fulfilled, the pod will not be scheduled. That is also called the hard affinity, because we are forcing node to execute on a specific node. Ignore during execution means pod will still run if the label on a node change and affinity rules are no longer met. It means at a particular time, whenever I am creating this pod, my node is basically satisfying the condition of a node affinity. But in future, if I will update my worker node and I will remove the label, right? The label which was the part of node affinity, then ignore during execution means if in future that node label will be changed, it will not impact your pod. Pod will still continue to work on that particular node. Pod will not be terminated if the label is changing on a node. So that is the one thing where we are getting a bit of flexibility as compared to the node selector. Another syntax we can use, instead of the required, you can use preferred during scheduling, ignore during execution. So required during scheduling is a hard affinity, but preferred during scheduling is a soft affinity. Here Kubernetes prefer the affinity syntax, and it will try to schedule the pod on a node which will justify the affinity. But if due to any reason Kubernetes is not getting that particular node or not getting the resource on that particular node, then it will schedule the pod on some other node. So here the pod creation will not be in the pending state. If the node affinity syntax is not justifying the criteria in Kubernetes, then it will not block the pod. It will execute or schedule the pod on some another Kubernetes node. That's why it is called the soft affinity. There is a one more syntax which is planned for a future. At a time whenever we are recording this lecture, this feature is not available, but this feature is planned for the future release in Kubernetes, which is required during scheduling and required during execution. It means the node affinity condition must be matched whenever we are scheduling the pod, plus it also be matched whenever the pod is in the execution state. It means if in future the label will be changed, pod will also be destroyed on the node. We have discussed about the node affinity. Then what is the node anti-affinity? Anti-affinity is just opposite to the node affinity, and if you want to put the anti-affinity in a node, you just need to change a bit syntax in your manifest file. So here is the syntax of the node affinity, and here we are using the operator in the node anti-affinity. The complete syntax will be same, but in the operator you need to use not in. So if we are using the not in with this particular condition, it means this will execute this particular pod on a node which is not justifying this particular condition, or we are forcing our pod to not execute on a node which have this particular label disk type SSD. This is called node anti-affinity. In the coming lecture we will see a hands-on demonstration. Thank you, team. See you in the coming lecture. Hello, team. Welcome back. Let's see a lab on node affinity and anti-affinity, and let's see how anti-affinity and affinity works in Kubernetes. So we are here on our Kubernetes master node, and we will execute the get pods command. So you can see we have only one pod running on my Kubernetes cluster, which is a static pod, right? Or we can say this is a mirror static pod. Now let's do one thing. Let's create a file vi, and I will name it nodeaffinity.yaml. Go to the insert mode and we will see the manifest file for the node affinity. So here we created a manifest file for the node affinity. We can see the kind is pod. This is the name of my pod, nginx node affinity. We are using the nginx image. Then we are defining the syntax affinity, node affinity. And this time we are using required during scheduling, ignore during execution. It means this condition, whatever we are putting in the match expression, must be fulfilled while the pod is scheduling. So let's copy this, paste it here, and save your file. Let's get the status of your Kubernetes labels, and we will execute command kubectl get nodes -- show labels. We can see disk type SSD, that is a label attached on worker node 2. It means whenever I'm going to create a resource which I have defined in the node affinity.yaml, that must be execute on worker node 2. So we will clear out the console and execute the manifest file kubectl apply -f node affinity.yaml. Hit enter. and you can see the nginx-node affinity is created. Let's get the status again and see my pod is executing on worker node 2. Why it is executing on worker node 2? Because I have defined required during scheduling and ignored during execution. And we have already discussed about the syntax, and over here we are defining the match expression disk type in SSD. So it is matching the node label. Let's do one thing, create one more file, node ntaffinity.yaml, paste this particular syntax in that file. Over here we are using the same syntax, but the operator is not in, right? Earlier the operator is in. It will match and execute the pod on a node which don't have this particular label. So we will copy this and paste it here. Save it. Now execute the pod. So we will execute kubectl apply -f node ntaffinity.yaml. The pod is created, get the pod status, and this pod must be executed on worker node 1. And yes, this is executing on worker node 1. So this is the way how we can allocate the pod in a Kubernetes cluster. We can use the node selector, we can use the node name, and we can use the affinity and anti-affinity. And the preferred way is definitely node affinity and node anti-affinity, because this provide a flexibility over the node selector, and node name is definitely not a good choice to work with. So team, if you have any question, any doubt, you can ask me. Thank you team. See you in the coming lecture. Hello team, and welcome to this new section where we will discuss about the scaling, replica set, replication controller, and deployments. There are few topics which we are going to cover in this section, and after this you will feel more confident in Kubernetes. So first we will start with scaling application in Kubernetes. So here we will learn what is application scaling, what are the stateless application, and how the stateless application can be scaled in Kubernetes, what are the stateful applications and how we can scale the stateful applications in Kubernetes, and then we will see a hands-on demonstration on scaling the application using the replication controller. So very first, let's understand what is application scaling. So application scaling or scalability is the potential of any application to grow in time. It means whenever the application is getting more traffic, then application have the capability to scale itself to handle that traffic. And whenever the traffic is going down, the application instance should be terminated. So application scalability means application can grow or shrink as per the traffic. Whenever we are getting a more traffic, application should have the capability to grow in size, and whenever we are getting the less traffic, application should have the capability to shrink in size. In Kubernetes, the application will execute in a container and container will execute within a pod. So in Kubernetes, we have a capability to scale the pods, and we can scale the pods up to n number of pods. And that pod scaling could be the manual scaling or it could be the automated process. So application itself detect the traffic and scale itself. In this section, we will learn about the manual scaling, and in the coming sections, we will also learn about the auto scaling. Now, there's a term called vertical scaling and horizontal scaling. So, pod can also be scaled vertically or horizontally. Let's understand what is vertical scaling and horizontal scaling. So, here we are getting a diagram where my y axis is a vertical scaling and x axis is a horizontal scaling. So horizontal scaling means whenever we are adding more number of node in application, right? We are adding more number of nodes in application, or we are going to spin up more number of instances of my application, that is called horizontal scaling. Then what is the vertical scaling? Vertical scaling means within the existing running application, we are adding more resources. So within the existing running instance of your application, if you are adding more CPU, you are adding more memory, then that scaling is called vertical scaling. But if you are going to spin up new instances of your application, either on the same node or on the other node, that is called horizontal scaling. So in simple terms, vertical scaling is when resource is adding in the running instance of the application, and horizontal scaling means add more instance of your application. Now, each application cannot be scaled, and there are few constraints about the application scaling. So to understand these constraints, we need to understand the stateless and stateful application. There are two kind of applications, the stateless application and the stateful application. Stateless application are those application which are not maintaining their state, and whenever we are saying the application is not maintaining the state, it means application is not saving the client data, and the output of my application is completely depend on the input set. We don't have any intermittent state of my application, and the value of output is solely depend on the input value. That is called the stateless application. Stateless applications can be scaled horizontally. So whenever we have the stateless application, we can create n number of instances of my stateless application, because we don't have any data which application is storing in the local file system, right? It is not maintaining the state of the application. So we can create n number of instances of my application to serve the traffic. And whenever we are saying the n number of instance can be created, it means new pods can be created in the stateless application. So generally the 90% front end services are the stateless application. Now what is stateful application? Stateful application is just opposite to the stateless. Stateful application will maintain the state of my application. They will save the state of the client data, and whenever they are getting the input, the output will be depend on the state of your application. The database system is a typical example of stateful application, because here we are saving the state of my application, and the output of application depend on the input plus the internal state of my application. The stateful application cannot be scaled horizontally. Why? Because we cannot break the file system, or we cannot split the file system into the multiple instances. Some instances are running the database, they have their state, they are maintaining their data. So we cannot split or break the file system and create the new instances for my database. So the stateful applications can be scaled vertically. It means within the stateful applications, you can add more number of resources in terms of memory and CPU. So these are the two types of scaling, horizontal scaling and vertical scaling. And stateless applications are capable to scale horizontally, and stateful applications are capable to scale vertically. And in Kubernetes, whenever we want to create the multiple instances of my application, we want to create the multiple instances of a pod with the same template, there are multiple ways. And first is the replication controller. So replication controller can be used to manage the application scaling in Kubernetes. Replication controller ensure that the specified number of pod replicas are running any point of time. Within the replication controller, we will define the specification of replication controller, and we will also define a basic template. In that template, you will define that how many number of pod, and in that template you will define that how many number of pod of your application need to be started by the replication controller. Suppose you are defining the 10 number of pods, then it's responsibility of the replication controller that due to any reasons, if any of the pod is going down, then replication controller will create a new pod and it will maintain the state of replication controller. Replication controller makes sure that the pod or a set of pod is always up and available. So that is the same statement that a replication controller is basically maintaining the state of the replicas which it is executing on your Kubernetes cluster. In the coming lecture, we will see a hands-on demonstration on scaling and descaling the application, and that scale and descale operation we will perform manually. So thank you team. See you in the coming lecture. Hello team, welcome back. We have discussed about the scaling in Kubernetes, and we have discussed about the stateless and stateful application. Today we will see how we can scale application in Kubernetes. And to achieve the application scaling or create multiple instances of your application, we will use a Kubernetes object called replication controller. So first, let's go through the manifest file of replication controller, and then we will execute that replication controller manifest on Kubernetes. So here we have defined a sample manifest for a replication controller. And the replication controller have the three major element. First is the metadata, second is a specification. This specification is about the replication controller specification, and third is the template. That template we need to define for the pods. So here we are defining the API version v1. We are defining the object type is a replication controller C. Then we are defining the metadata. This is the name of your replication controller, Alpine box replication controller. Then within the specification of replication controller, we are defining the replicas. Here we are defining three. It means once this replication controller will execute, it will execute three pod of this particular template what we are defining over here. If we will define five over here, then it will create a five pod of this particular template. So replicas means whatever number you will define in front of replica in replication controller, it will create that number of pod of your defined template, and these pod will be the part of your replication controller. Then we are defining the selector, and within the selector we need to define the label. Over here we are defining a label app alpine hyphen box. Please make sure this selector or this label must match with your pod level, right? So pod level and the selector must be same. Then we are defining the template, and in this template we will define a template of my pod. Metadata, this is a name, so name of your pod will be alpine. This is a label which is attached with your pod, and this is a specification of your pod. So we are going to create a container alpine box. The image we will use alpine image, and this is the command which will execute in your container. So we will go to the Kubernetes cluster. So here we have created a connection with my minikube cluster or single node Kubernetes cluster. We will create a directory and we will call it deployments. Let's go to the directory deployments, and here we will create a file replication controller dot yaml. Go to the insert mode and paste the file we created on a Visual Studio Code. So I will paste it here. So you can see we are creating the three replicas of this particular pod. So I will save this. Now to create the Kubernetes object, we have a simple command kubectl apply -f and your file name. Hit enter and see we are getting a message replication controller, and this is the name of a replication controller is created. Let's copy this name and type kubectl get and provide this name. Hit enter and we can see we are getting the replication controller name, the desired state of my replication controller, the current state of my replication controller, and the ready state of my replication controller. Desired state means the number of replicas you have defined within your manifest. Current status means the number of pods running within this particular replication controller, and ready means the number of pods which are in the ready state in this particular replication controller. If you will find out the pod which are running on your cluster, so we will execute kubectl get pods -o void and see the three pods are running which are the part of my replication controller. So the pod name is with the replication controller name, then we have some random id after the replication controller name. These are the pods which are running on my cluster. Let's do one thing. Let's delete any of the pod, right? Why we are deleting the pod? Because we want to see if the replication controller is maintaining the state or not. So we will execute kubectl delete pod and define any pod name. So suppose I'm deleting the second pod which have the id dm9b5. I will copy this and paste it here, hit enter, and we are getting a message this pod is deleted. Let's wait, and pod deleted successfully. Let's get the status of your application controller, and status is still current 3 and ready 3. Let's see what are the pods running on my box, and see again 3 pod are running for my application controller, but this time we are not getting this pod which have the id dm9b5. No, No, the pod is not here. But you can see a new pod is basically started 49 seconds ago. Although the two other pods are 3 minutes older, but this is a latest pod. So as soon as any of the pod got deleted or any of the pod got crashed, replication controller will automatically create a new pod and it will maintain the state of your application. Clear out the console. Let's get the status of your application controller again. And now suppose you want to scale your application horizontally. So how we can do that? We will execute a command kubectl hyphen hyphen replicas equals to and define the number of replicas. Now suppose we want to create three more pods in my replication controller. So three is already there and we want to create three more. So we will define total six over here. And then you need to define your replication controller name like this. Hit enter and we are getting that replication controller is scaled. Let's get the status again and we are getting three desired, current 6, ready 6. Let's see how many pods are running over here and see three more pods got created 15 seconds ago, right? Now my replication controller is executing six number of pods. So this way you can scale your application manually. If you want to descale your application, you can do that thing as well. And suppose we want to descale my application and we just want to run two number of pods as a part of replication controller. Hit enter, the state is updated. Let's get the pod status again and see. The rest of my four pods are terminating. And you can see the termination order is it is terminating the latest or recently created pod, right? Both of my old pod or the first pod which is started as a part of the replication controller, they are present, but only the recently created pod are got terminating, right? So there's a termination order as well. Clear out the console, get the number of pods running, and we have only two pods which are the part of my replication controller. Let's get the status of your replication controller and see we are getting two desired, two current and two ready. So team, this is the way how you can create the multiple instances of your application. Whatever the number of replicas you will define in replication controller, it will create that much number of replicas of your pods of your applications. If you want to delete your replication controller, the command is same, kubectl delete hyphen f, define your file name which is replication controller.yaml. It will delete the replication controller. You can check the number of pods and they are in the terminating state, right? So team, this is the way how we can scale and descale the application with the help of replication controller in Kubernetes. Thank you team. See you in the coming lecture. Hello team, welcome back. We have seen the scaling of application by replication controller, but other Kubernetes object provide the similar kind of functionality, and one of them is replica set. So we will discuss about the replica set. We will see how we can use replica set to scale the application, and we will also see the difference in replica set and replication controller. So in this session, we will cover what is replica set. We will understand the fundamental differences between replica set and replication controller. After then, we will see the difference between replica set and bare pods. Bare pods means the pods which don't have any kind of controller like the replication controller, deployment or replica set. The pods which created by a pod template are called the bare pods. And then we will see a hands-on demonstration on replica set. So replica set do the same kind of work like replication controller, but replica set is an enhanced version of replication controller, or you can say replica set is a new generation of replication controller. Replication controller was used earlier, but replica set is an enhanced version of replication controller, provide the same basic fundamental functionality with additional features. As we just mentioned, like the replication controller, replica set purpose is to maintain a stable set of replica pods running at any given time. So like we have defined the replicas in replication controller, we defined the three replicas, and whenever we will create a template for replica set, we also need to define the number of replicas. And like the replication controller was managing the state of the replica pods, replica set will also manage the
state of replica pods. If you define 10 number of pods or replicas in replica set, and due to any reasons if any of the pod going down, then replica set will create a new pod, and at any point of time replica set will maintain the running pods in Kubernetes. Now, what is the difference between replica set and replication controller? So the main difference between both of them is the selector support. So whenever you define the replication controller template, you have defined the selector over here. And that selector was a key value pair, and that selector must be matched with the labels of your pods. So in replica set, we will use a enhanced selector. Here in the replication controller, we just use key value pair in the selectors. But in replica set, we can use the match expressions in selector, where we can provide the conditional statement as well. So as we just mentioned, the label selector is used to identify set of object in Kubernetes. Definitely, whenever we are executing the pods, and that pod is basically going to created by a specific template, and we have defined some kind of label on that pod, the pod is a Kubernetes object. Other Kubernetes object will identify that object by the defined label on that particular object. So label selector is very important feature in Kubernetes, and all the Kubernetes object can be identified by the label selectors. Replica set allow the user to use set based label selector. It means you can define the set in value of the label selector, and as we mentioned that the match expression can be the conditional. So we can use in, not in, and exist operator that match the Kubernetes object labels. So let's see the fundamental difference between both of the manifest. So when we created the replication controller, we defined the specification like this. We defined the specification, then we defined the number of replicas, and within the selector, we was defining the key value pair. Here you can define one key value pair or multiple key value pair. And then we was defining the template, and that template will contain the pod template. Whatever the pod this particular replication controller is going to create, that is the template of that pod. Within the replica set, you will get a enhanced version of the selector. So you can see specification will be same, the replica will be same, but within a selector we are getting one more parameter called match expressions, and that match expression will provide a additional feature. So suppose you want to match expression that this particular label app alpine box could be anything, that could be the app engineering, that could be the app example, that could be the app production, that could be the app rs. So you can define a key like app, then you need to define the operator. In the operator we are defining in, it means this key will contain the values, and then we will define the values within a set. Over here we are defining three values, example, example, and rs. You can define any number of values over here, and that is a set of values. Please make sure the value whatever you are defining over here, they should not be duplicate as we mentioned in the given set. That is a human error. In the similar way, we can define another key, like we are defining the key tier, and we are defining operator not in. It means it will match the pods which have the tier not production. So if you have the label in your pods like tier equal to dev, engineering, production, pre-production, so this particular replica set will only and only consider the pod which don't have the tier production. So here we are getting the flexibility over the selector, and that is the only difference between the replication controller and replica set. Rest all of the functionality will be same. One more thing about the replica set, and that relation is with the bare pods. Bare pods mean the pod which created without any template. I mean to say without any controller template, like no controller is executing on above of that pod like the deployment or replica set or replication controller. So while creating the bare pods, bare pod do not have the label which match the selector of any of your replica set. Whenever we are creating the bare pod in Kubernetes and we are using the replica set, we need to make sure that the label, whatever the label we are using in the bare pod, that must not be matched with the label which we consumed in the replica set. And why that should not match? Because replica set is not limited to the owning pods which is specified by its own template, right? It can acquire the other pods which have the matching labels. It means
Suppose you are defining a pod template within your replica set and you defined the three number of replicas, right? Later you created another bare pod and that is using the same level expression. So replica set will also consider that pod as a part of the replica set because replica set is just not limited to its own template. Let's understand this with a diagram. So suppose we have a replica set, and within this replica set, we have defined three replicas of a pod like Nginx pod, and which have the label like application equals to front end. So these are the three pods which are running in this replica set. Now you will come after some time and you will create a bare pod, and that bare pod have the same label like application equals to front end. Then this particular replica set will consider this bare pod as a part of the replica set, and it will create the further operation on that pod. So we need to be make sure that whenever we are creating the bare pods in Kubernetes, the label of bare pod will not match with the running replica sets in your Kubernetes cluster. In the coming lab, we will see hands-on demonstration on replica set and bare pod replica set relationship. Thank you team. See you in the coming lecture. Hello team, welcome back. And today we will see a demonstration on replica set. So before starting the execution, let's understand the replica set manifest file. So here is my replica set YAML. We are defining the API version Ep3. Then we will define the object type of Kubernetes, which is a replica set. We are defining the metadata of my replica set, the name and labels which are going to attach with my replica set. Then we are defining the specification of this replica set. Three replicas will be created as a part of this replica set, and within the selector we are defining match expression key equals to tier in front end, right? It means it will only and only consider the object which have the label tier equals to front end. Then we are defining the template of my pod, metadata, labels. These are the two labels which I am defining with my pod. App equals to my app, tier equals to front end, and within the pod specification we are defining the container name and container image. So this is the basic manifest file of a replica set. I will copy this and go to my Kubernetes cluster. So we are in our Kubernetes cluster and we will go to a directory deployments. Here we will create a file replica set.yaml, and in this file we will go to the insert mode and paste the manifest, right? Let's close this. Now to create the replica set object, we will use a command kubectl apply -f replica set.yaml. Hit enter and we can see replica set apps my app replicas got created. Let's get the status of your replica set. Kubectl get and copy this and provide it here. You are getting that this is your replica set. The desired state is 3, current state is 3, and ready state is also 3. There is no requirement to provide this much of lengthy statement. You can also follow a shortcut like kubectl get, and for the replica set you can use rs slash define your replica set name, which is my app replicas, and this will also provide the same status, right? So this is a shortcut for the replica set. Similarly, if you want to use replication controller, rc is a shortcut for the replication controller. Let's describe your replica set. We will execute kubectl describe and provide rs and your replica set name. And here we are getting the replica set complete description, the name, namespace it is using, the selector which it is using, say tier in front end, the labels which are attached with your replica set, the current count, desired state, pod status, right, and the pod template, image, port, and other things. And we can see three pods are running as a part of this replica set. If you will clear out your console and execute kubectl get pod -o void, we can see three pods are running within my replica set. Now let's do one thing, and suppose we want to scale the number of pods running in my replica set. So similarly we can execute kubectl scale -replicas equals to and define the desired number of pods which you want to add in your replica set. Suppose I want to add 10 pods, and after then you need to provide your replica set name, which is
like rs backslash and provide your replica set name my app hyphen replicas. Hit enter and see we are getting a message that replica is basically scaled. And let's get the number of pods again, and we can see that 7 more pods are basically created, right? We can see the age of these pods are just 18 seconds ago, whether the earlier pod is running from 3 minutes. Similarly, if you want to shrink your replica set, you can again execute the same command, and within the scale you can provide the number of pods which you want to put in your replica sets. So suppose I want to reduce the number of replicas and want to execute only 2 replicas of this particular replica set, we will descale it. Get the pod status again and see the rest 8 pods are in the terminating state. Clear out the console. Now we have also discussed about the relationship between the replica set and bare pod. So we created another manifest and it is here. Here you can see I'm creating a pod. The name of my pod will be my pod 1 and I'm using the same label, right? Tier front end. This is a label which is attached with my pod which are part of my replica set. So I'm using the same label, and here I'm not going to execute the nginx. Although you can execute the nginx container, but suppose I'm executing some other image, right? Because that may be the production scenario that you can use this label with some other image, and I'm executing the Google sample image hello app. Similarly, I'm creating the another pod, my pod 2, which is also using the same label which is defined within my replica set pod, and we are also putting the match expression on this particular label. Then we will see what will happen with these bare pods. So I will copy this, create a file vi bare-pods.yaml, paste the pods here and save your file. Let's execute kubectl, apply -f bare pods. Hit enter and you can see we are getting a message pod created. Let's get the replica set status again, and my replica set desired state is 2 because we reduced the number of pods. Let's get the pod status again, and you can see the my pod 1 and my pod 2 are in the terminating state, right? They are not running. Let's see why they are not running. We will execute kubectl describe pod and provide any of the pod name like my pod 1. And here you can see, although we have not attached the replica set, but it is saying controlled by replica set my app replicas. We have not defined any replica set to control this particular pod. That is a bare pod. You can see the definition. We are not using any replica set over here, but still, whenever I'm getting the description of my pod, it is saying that controlled by the replica set. Why? Because the label which we defined on these pods, that is the matching expression label of my replica set. So all the Kubernetes object which are using this particular label which I have defined within the selector of my replica set will consider these pods are a part of the replica set, either they belongs to this template or not. So that is the thing you need to take care whenever you are working with the replica set. So if you are creating any bare pod, the match expression will not be match with the expression defined in the replica set. Let's do vice versa. Clear out the console and delete your replica set. Kubectl delete -f replica set.yaml. Let's get the pods running again, right? And you can see my replicas pod are in the terminating state. Let's wait, and no pods are running in my Kubernetes. Clear out the console. If you will open your replica set, you can see we are executing 3 replicas, right? We will clear out the console again, and this time very first we will create or execute the bare pods. So kubectl apply -f bare pods yaml. It will create 2 bare pods. We will get the status of pod running in my Kubernetes cluster and see both of the bare pods are in the running state. Now let's execute your replica set created, and let's execute the number of pods. And you can see only one pod is created in the replica set, right? And if we will get the status of my replica set, let's get the status.
We can execute a command kubectl get rs slash my app hyphen replicas, which is the name of my replica set. Then strangely we are getting desired state 3, current state 3, and ready state is 3. But in actual only one pod is running of this particular replica set. So why we are getting this desired state? Because the match expression, the label which is attached with your bare pod is matching with your replica set. So your replica set is also considering these two pods as a part of this same replica set, although the pods are not belongs to this particular replica set. If you describe your replica set, then you can see over here we are getting only one pod. But because this selector is matching the label of your pods, your bare pods, so that replica set is considering this pod as a part of the replica set. Let's clear out the console, get the pods again, and do one thing: delete any of the pod. Kubectl delete pod, and suppose I will delete pod 2. Hit enter. It will delete the pod 2. Pod is deleted. Let's get the pod status again. You can see once this pod deleted, replica set created another pod, and that is created 21 seconds ago. Why? Because replica set need to maintain the state of the replicas. It need to maintain the number of replicas which are part of the replica set. So this is the problem with the replica set and bare pods. We have seen how we can work with the replica set and how we can work with the replication controller, and how we can scale and descale the number of instances manually by help of Kubernetes object. So thank you team. See you in the coming lecture. Hello team, welcome back. And today we will discuss another component of Kubernetes called deployments. Deployment is a one level higher abstraction of replica set and replication controller. So we will see what is deployment and what is the benefit of deployments over the replica set. So today we are going to cover, so we will understand the deployment object in Kubernetes and the purpose of deployment in Kubernetes. And then we will discuss a bit more about the desired state of deployment. And then we will discuss about the deployment use cases. After this, we will get a hands-on demonstration on deployments lab. So first, let's try to understand the deployment. So till date, we have discussed about the replication controller, which was creating the replicas of pod. Then we have seen a one level higher abstraction layer, which is called replica set, which was creating the replicas, but it was providing more flexibility over the replication controller. And deployment is a top level abstract layer in that hierarchy, and it will provide one step higher than the replica set. In other words, we can also say that deployment is a desired state of replica set. Whenever we are defining the deployment, basically we are defining the replica set and pods. So don't confuse right now. Shortly we will see how we will do that, how the deployment is a higher level than the replica set. So as we just mentioned that deployment is a one step higher than the replica set. Deployment basically control both. Deployment can control the replica set, and deployment can also control the pods, and that control is being done by the declarative manifest we defined in the deployment. So by a deployment manifest, you can control the replica set and the pods. The smallest unit of the deployment is a pod that runs the container, and each pod has its own IP address and share a PID namespace, network, and the host name. So the hierarchy will look like this. At the top level, we have the deployment, and deployment is managing the replica set. A single deployment can have n number of replica sets, and these replica sets are basically executing the pods, and these pods are basically have the basic building blocks called containers. So pods and the container are the unit level for the deployment. Now let's discuss about the use case of deployment, and it will also explain how deployment is a one level higher than the replica set. So the first use case is create deployment. Whenever you want to execute your application within the pod, you want to deploy your application pod, you need to create the deployment. Update deployment. So if your application is running but you want to push a new version of your application, you can use the update deployment, and by update deployment you can push a newer version of your application within the running pods, and that operation is done in a controlled manner. We will discuss about it how the update is done in a controlled manner. The rolling upgrade. So basically the rolling upgrade is a part of the update deployment, and it will upgrade your application containers in a rolling manner. It means if 5 container or 5 pods are running as a part of a deployment, and you will start upgrading your deployment via rolling upgrade, then deployment will update a single pod at a time. It means if 5 pods are running as a part of application, deployment will basically upgrade the pods one by one, and in that case my application won't face any zero downtime. Because if one instance is in the upgrade in the maintenance window, then other instances are up and they are serving the traffic. Then we have the deployment rollback feature. So after the upgrade, you realize that there are some issues in this particular build. There are some issues, and customer are facing some unnecessary glitches. Then you can simply roll back your complete deployment, and it will also revise your deployment version. And rollback is also done in the rolling restart manner or rolling rollback manner. Another use case is pause and resume a deployment. So you can pause your deployment, you can do the YAML changes, and then you can resume your deployment. And what it will do, it will roll out the certain changes which you done in your deployments. Deployment, rollout, upgrade, and rollback upgrade will look like this. We have a deployment, we create the deployment that will create the replica sets like replica set 1, replica set 2, replica set 3, and replica set n. Once you will push the rollout upgrade or rollback upgrade, what it will do, deployment first pick the first replica of your application, it will upgrade it or rollback it as per the instructions, and whenever it is upgrading or rollback the replica, it will create a new replica every time. But as this operation is going in the rolling upgrade fashion, so application won't face any downtime. In the coming lecture, we will see a hands-on demonstration on the deployment, and we will see what are the operations we can perform with the help of a deployment which is not possible with the replica set. So thank you team. See you in the coming lecture. Hello team, welcome back. And today we will see a lab on deployments in Kubernetes. We will see the labs, how we can create deployment, how we can upgrade the deployment, and how we can perform another use case on deployments. So before starting the deployment execution, we will understand the deployment manifest. So here I have created a deployment manifest, and you can see the API version for this deployment manifest is Ep3. The kind is deployment, and here we are defining the metadata for this deployment. The name of my deployment will be chef server. The labels, I am attaching a single label with my deployment app chef. Then we are defining the specification, and the specification we are defining the replicas that is similar to the replica set and replication controller. Within the selector, we are defining the match labels, and it will match a label on the pods. Label is apps chef server. This is the label which will be matched on the pods. Over here, we are defining the template for the pods. Within the templates, we are defining metadata and labels. And you can see the pod label is again app chef server. Please make sure this label and this label, they must be same. If they are not matching, if the selector label and the pod label is not matching, then definitely you will face the issue. Then we are defining the specification, and we are defining 2 containers. This is my first container where the container name is chef server. The image I'm using chef dk colon 4.9. How we can select that image, we will look into it shortly. We are defining the port on which particular port this image will execute, and port is 8080. Then we are defining a execution shell command, right? -c for passing the command, and this shell command will just print this particular thing and sleep for 300 seconds. And after the chef server container, I'm defining another container within the same pod, and the name of my container is Ubuntu, and this is using Ubuntu 18.04 image, again executing on port 8080, and this is the command which will execute on this container. So this is a deployment manifest we are going to use to spin up the deployment. Now first let's check this image, which is a chef image and Ubuntu image, how we are getting these specific image number. So we will go to the browser and we will go to the Docker Hub. So we will type Docker Hub, click the hub.docker.com, and here search for the chef. So we are getting the chef DK image. Let's open this, and within the tags you will get the specific image. So we are consuming 4.9. These are the images 4.9, 3.1416 and 4.9.8 which is present for the chef, and we are using this particular image. Similarly, if we will open this in a new tab and we will search for the Ubuntu, so here we are getting the Ubuntu, and see we are using 18.04 image. Other images which is available with Ubuntu is 20.04 and 20.10 and other few images. Now we will go to the terminal and create a connection with my Kubernetes cluster. So here we created the connection with my Kubernetes machine and we are in the deployments directory. Over here we will create a file vi deployments.yaml. Hit enter, go to the insert mode, and we will copy this manifest and paste it here. Now I will close this. So you can see we are using chef image 4.9 and Ubuntu image 18.04. We have defined the three replicas. To create the deployment, we will execute kubectl apply -f deployments.yaml. Hit enter and see we are getting deployments apps chef server is created. Let's get the status of this deployment. So kubectl get and provide your deployment name. So we can see that the deployment is in the ready state. It is expecting the three replicas. Out of three are running and they all are up to date and all are available. If you want to check the rollout status of your deployment, you can execute command kubectl rollout status and your deployment name. If the deployment is in progress, you will get the in progress status over here. And as we can see, the deployment is successfully created. So we are getting deployment, your deployment name successfully rolled out. Let's describe this deployment. So I will execute kubectl describe and provide the deployment name. Over here we are getting the details, the name of my deployment. Then over here we are getting the replicas, and three replicas are desired state, three updated, total three, and three available. Zero replicas are unavailable. And we are also getting one property called rolling update strategy, which is saying 25% max unavailable, 25% max search. We will talk about it shortly, that what is rolling update strategy and what is the meaning of 25% unavailable and search. Here we are getting the pods which is running as a part of this deployment, and the label of the pod is app equals to chef server. Within the pod we are running two containers. So this is the first container, right? And here is the second container, which is a Ubuntu based container. So within the first container you can see this is a chef server. The image we are using chef dk 4.9, and we are also getting the commands. The second container is Ubuntu container, and image we are using Ubuntu 18.04 and the command. If you will scroll a bit, in the end it is saying, then in the events it is saying scaled up replica set chef server, then some random id to 3. What does it mean? So I told you that deployment is a higher level abstraction layer of the replica set, and deployment will directly manage the replica set and container. So ideally we just created the deployment, we have not created the replica set. But if you will execute a command kubectl get rs, which is main replica set, you can see a replica set is already running, and that replica set name is starting with my deployment name and then some random id. The desired state is again matching with my deployment. So basically this replica is being created by my deployment. So the structure is like this. Here we have the top level, and at this particular level we have the deployment, and here we have the deployment. This deployment is creating a replica set, and these replica set will have the further pods. You can have the n number of pods as defined in the replica set. So we created the deployment created the replica set. Now if we will execute a command to get the number of pods, let's see what we will get. So we are executing command kubectl get pods hyphen hyphen show labels, and see three pods are running over here. and every pod id is starting with the replica set name. See, then we have some random ids, and one more thing, each pod is running two containers, right? So this is the complete structure. We are executing the deployment is executing the replica set, and replica set is managing the number of pod which is running as a part of deployment. So I hope you get the basic concept that how Kubernetes is basically maintaining the multiple instances of your application. And if you want to maintain the multiple instances of your application, then deployment is the correct Kubernetes object for you. So I'm closing this lab over here. In the coming lab, I will show you what are the other benefits deployment provide over the replica set. Hello team, welcome back. And this is the another lab on deployments in Kubernetes. Earlier we have seen the basic architecture of deployment and the working model of deployments. Today we will see how deployment is more flexible, or how deployment is more useful as compared to the replica set. And we will see how we can perform the other operations on deployment, like the rolling update of application, rollback of your application, pause the deployment, do some addition changes in your deployment, and resume the deployment rollout. So first, let's understand the rolling update. What is the rolling update? Rolling update means, suppose this is your deployment, and within your deployment there are multiple pods are running. Suppose within my application these pods are running, and there are three pods which are running as a part of my deployment. They all pods are running on some specific version. We can assume that they are running on application version 1.1. All pods are running on 1.1. Now you have done some changes in your application, and you created a new image of your application that have some additional features, and you created a new image called 1.2. Now you want to upgrade your application with the latest image. So you need to roll out your latest image within the deployment. And to roll out the new application image, what you need to do, you need to edit the deployment, and deployment will roll out the new image for your application. But that rollout or that upgrade will be a rolling upgrade. Now let's understand what is rolling upgrade. So rolling upgrade means deployment will create the three another pod, and these pod will have your latest image 1.2, right? And rolling update means that deployment will down a single pod and up a single pod with the latest image. Once this particular thing will be done, now the situation is that two of my pods are running on the old image and one pod is running on the new image. So once the operation will be done for one pod, deployment will do the same thing with the second pod. It will make down the second pod and up the another pod with the latest image, and so for the another pod. So by this way, what we are achieving, basically, at any point of time we are not breaking the application, we are not halting the traffic. My application is continuously serving the traffic, and in a background, deployment is basically doing the rolling upgrade. Here it is making the pods down one by one and upgrading the another pod with the latest image. This is called rolling upgrade. Let's see how deployment will do it. So we will go to the Kubernetes. So here we are on the Kubernetes, and these are the pods which are running as a part of my deployment. The all pods are running since last 14 minutes. Now what we will do, suppose we want to upgrade the chef server image. Currently my chef server is running 4.9. So you can see my chef server is running on 4.9. What are the other images available for the chef? And other available image like 4.9.12, 4.9.13, 4.9.14, 4.9.10. So suppose we want to upgrade my chef server to this particular image 4.9.10. So what we will do? There are multiple ways to upgrade your pods. So let's see the first way how we can do it. We'll execute a command kubectl set image, define your deployment name, deployment slash chef server. Now you need to define your container name. In my case, this is chef hyphen server. So I will provide it here, equals to, and define the image which you want to update. So I want to update on image 4.9.10, which is this. So I will copy this and paste it here, chef dk 4.9.10. So this is the command which you want to hit. Let's hit this and get the rollout status. So we'll execute the rollout status command, hit enter, and you can see chef rollout is basically waiting and it is executing for the first pod. The three are still in the pending state. So by a rollout status command, you can monitor the rollout of a new image within your deployments. So you can see it is basically working on the first out of three. If you will exit and get the number of pods, you can see it is creating the container creating. And over here, the other three pods are still running. So first it will create first container, it will make any of the container down, then it will create another container, make any of the container down, it will create another container with the latest image and then make the last container down. Let's get the status again, and you can see three new containers are created and earlier three containers got terminated. Let's get the rollout status again, and it is saying deployment is successfully rolled out. Now we have executed this particular command. We have updated the deployment once. So in deployment, you have a feature that you can get the revision history. So clear out the console and execute the same command. And instead of the rollout status, let's watch the rollout history. Hit enter. And here we are getting the rollout history. We are getting revision 1 and revision 2. But we are not getting that what is the change we have done. The change we have done is still missing. So that is a problem, and how we can address that problem. Let's do the upgrade again, and suppose we are upgrading the image to 4.9.13 this time. So we will execute the same command but update the version to 13, and after the command we will execute one more parameter called record. What this will do, this particular record will basically keep the record of this command. Let's hit enter, get the rollout status. You can see the rollout is working for the one container. Let's wait and watch the rollout of your deployment live over here. So we can see this particular rollout or my service upgrade is a rolling upgrade. It is not making all pods down at a one time and creating all three new pods. No, it is creating the pods one by one, right? So we have to wait until the rollout of my replica is done. The rollout for 1 is finished, for 2 is finished, for 3 is finished, and it has terminated the earlier pods. Now we are getting the successful rollout status. Hit enter and let's get the history again. And a new revision is created, and over here we are getting the change as well. So what is the change you has made as a part of this revision? We are getting that change. So it is recommended to use the record command whenever you are making the changes in your deployment or whenever you are upgrading your deployment. If you want to check, let's list out the pods. Let's get the description of any pod, kubectl describe, and provide any pod name. Go to the Ceph server pod and see. We are using the latest image 4.9.13. Before this, we have used the image 4.9.10, and before that, we was using the image 4.9. Let's clear out the console. Now, suppose after upgrade, you are facing some issue in your production services and you want to roll back your changes. For that, you need to execute the similar kind of command, rollout, kubectl rollout, and instead of the history, you need to mention undo like this. Hit enter and it will roll back your changes. Let's get the status again. The deployments are successfully rolled out. If you will get the history and see, the change causes again nothing. So ideally we have rolled back these changes. What is the image we was using before this? The image was 4.9.10. Let's describe the deployment. Go to the chef and see we are using 4.9.10. So this is the way how we can upgrade the application in deployment and how we can roll back the application in deployment. Clear out the console. Now suppose you want to roll out your application to a specific revision. How we can do it? So first gets the history, and suppose I want to roll back my application to revision 1 where I was using the chef server image 4.9. So I will execute the similar set of command kubectl rollout undo, right? Define your deployment name Then define hyphen hyphen 2 hyphen revision equals to and the revision number. In my case, I want to roll back my application to the revision 1. Hit enter and see we are getting the rolled back message over here. Let's get the status and this is done. Let's get the history again. You can see we are getting the another revision which is revision 5. Let's describe your deployment and now Ceph server must be on 4.9. Yes, that is on 4.9. So this is the one way how you can perform the upgrade and rollback of your application in deployment. There is a one more way, although I am showing you this way, but this is not recommended. The way is we need to execute a kubectl command, kubectl edit and your deployment name. Hit enter and it will open the deployed YAML of your deployment. Over here you can edit anything. You can edit anything over here. Now suppose I want to edit the image of my Ubuntu container and I want to upgrade my Ubuntu to 20.04. So I will go to the insert mode and put a updated version over here 20.04. Now we will save this. Press escape WQ. As soon as you will save it, it will roll out the changes. Let's see the rollout status and see the deployment rollout is done. We will get the number of pods and see the old pod are terminating and new pods got created. If you will describe your deployment now, you can see my Ubuntu container is running on 20.04. Clear out the console and get the history again. You can see a new revision is created, but we are not getting the change cause. That's why I told you deployment edit is not recommended, because here we cannot record the change in deployment, and record a change in deployment is very necessary for your deployment management. Let's clear out the console and we will see the deployment pause and deployment resume. So to pause a deployment, we will execute a command kubectl rollout pause and define your deployment name. What this particular command will do, this particular command will basically pause the rollout of your deployment. Now you can do a bulk changes in your deployment and these changes will not be rolled out in a single go. The changes will be rolled out once you will resume this particular rollout. Let's do that. So we will edit the deployment again, and this time suppose we are going to set a chef image on some another version, and this time I'm going to make a version 4.9.16. So we will do it 4.9.16 hyphen hyphen record, hit enter. You can see the image updated. Let's get the rollout status and see it is saying 0 out of 3 replicas have been updated. Why it is not updating the replicas? Because we have paused the rollout. Let's put Control C and make another change in an image which is Ubuntu image. So we will make a change in the Ubuntu image. So we will mention the Ubuntu container name which is Ubuntu and put the image on which we want to update my Ubuntu. So suppose we want to update my Ubuntu on 21.04. So we will mention Ubuntu colon 21.04. Hit enter. This change is also done. Let's get the status. The deployment is also not updated. Why? Because the rollout is paused. Now you can do more changes over here. And suppose we are putting the memory limit on my chef. So memory limit is not a operation on the image, that is a operation on the resource. So we will execute a command kubectl set resource. After then we need to define the deployment name, which is this. After then we need to define the container on which container we want to apply this limit. So that can be defined hyphen c equals to, and my container name is chef server. Suppose I want to define a memory limit on my chef server container space, then I'm defining limit equals to, suppose I'm defining memory equals to, and we are putting a memory limit of 250 mi, which is 250 megabyte. Hit enter. The resource is updated. Let's get the status again, and deployment is still not updated. If you want to check the age of your pods, you can see the pod was created 7 minutes ago. Let's check the history of your deployment as well. So we are not getting the history updated as well. Now to make all the changes effective, this is the first change we done, we updated the Ceph image. This is the second change we done, we updated the Ubuntu image. And this is the third change we done, we have updated the limit resources on my Chef server. These are the three changes. Now this is a bulk change in my deployment and I want to make these bulk changes live. For that, you again need to execute the kubectl rollout command, and this time you need to mention resume and your deployment name. Let's get the status again and see my change rollout is basically started. So by this way we can pause the rollout, we can do the bulk changes in my deployment, and then we can put all the changes in a one go by resume the rollout. So over here we are getting the latest status of the rollout. If you will put Control C and get the running pods again, the new pod is in the creating state and other pods are still running. Clear out the console and watch the rollout status. So it is working for first pod out of 3, and it has completed for the first, completed for the second one, and terminated the old one as well. Let's get the pod status again. See, the new pods got created and older pods got terminated. Let's describe the deployment, and over here you can see we have the latest image 4.9.16, the first change in the Chef. Then we are also getting the memory limit over here, which is 250 megabyte, and we are getting the another change over here, which is Ubuntu image 20.04. And all these changes are basically done in a single go. So if you want to make the bulk changes in your deployment, you can use the deployment pause and resume feature. Let's check the history one more time. And within the history we are getting only one change, right? It is not listing all comma separated changes which is done. Now one more thing with your deployment, if you want to scale your deployment, how we can scale the deployment? For this we'll execute the same command, kubectl scale deployment name, define the replica and the number of replicas you want to create. So suppose I want to create 5 replicas of this particular deployment, so I will put 5 over here. Get the rollout status, it's done. Get the number of pods running and see 5 pods are running. So team, we have seen almost all of the operations which you can perform on the deployment, and we have also seen that how deployment is helpful for my application. It will help us to manage the application in many ways. So team, if you have any doubt, any question, you can ask me. Thank you team, see you in the coming lecture.